and welcome everyone. Hi, Deacon.
Hello. Oh yeah, there's some delay between my my move in my head and with the screen. Some lag. Hello, Alex.
Hi, Deacon. Is that morning for you?
Yes, it's 10 a.m. here in Indonesia, and I believe you are at down
I-
5 in the morning. Wow.
Right, it's 5 a.m., but there is nothing I wouldn't do for a good Cassandra
Yeah.
Day.
Yep. Thank you for being here for Indonesian developers and all the community here. We're really excited to have Cassandra here in Indonesia.
So, I think you can start.
Okay. So let's check. Oh, we already. Okay. So, kita langsung aja ya mulai ya. Halo semuanya. Selamat datang para developer dan siapa saja yang hadir di YouTube channel ini. Perkenalkan, nama saya Diki Duyanto dari PT Bitsen Inovasi Teknomatrik yang merupakan subsidiary dari PT Strategic Partner Solution atau SPS. Nah, pada hari ini kita akan membawakan satu topik yang menarik tentang database di dunia IT, yaitu Cassandra. Apa itu Cassandra? Ya, oke. Check, wait. Wow, logonya ada mata di sini Cassandra. Ya. Mungkin bagi beberapa developer ada yang sudah mengenal, ada yang mungkin baru-baru dengar hari ini, atau baru samar-samar, baru rumor dan sebagainya. No problem, karena justru hari ini kita akan membahas apa yang dimaksud dengan Cassandra dan apa sih yang ditawarkan oleh Cassandra oleh database yang baru atau baru terdengar ini, bukan baru, tapi baru mungkin bagi sebagian kalangan inilah baru hari ini mendengarkan tentang Cassandra. Oke. Oh ya, sebelum saya lanjutkan, di sini I'm here with Alex from DataStax. Halo Alex.
Hello everyone. Hello, Deacon.
Yeah, so he based on Germany, but when he speak Russians, and it's good to have him, and also with Stefano later. The two guys will bring the most of the presentation today. They are, I can assure you, they are very expert on that Cassandra.
Thank you.
They both work at DataStax. Oke, sebelum kita menggali lebih dalam apa sih Cassandra itu, sebagai intro aja, Cassandra itu adalah database NoSQL yang terdistribusi dan terdesentralisasi. Sedikit sejarah, awalnya dibuat oleh atau di-create dalam Facebook, kemudian sejalan dengan waktu dia kemudian menjadi salah satu top level project di Apache Foundation. Sudah bukan rahasia lagi, jika kita ingin teknologi berkembang, kita harus di open source kan. Dan itu Cassandra adalah salah satu open source database yang akan kita bahas dalam hari ini. Cirinya apa aja ya? Salah satunya adalah big data ready. Artinya apa? Mampu mengelola data yang masif. Nanti akan jelaskan dalam event hari ini seberapa besar sih data yang mampu diolah. Kemudian highest availability, karena menggunakan arsitektur multi-node, multi-server, dia maka bisa meningkatkan availability. Kemudian sejalan dengan teknologi IT modern, dia scalable secara linear dengan menambahkan node. Kemudian sangat umum dan sangat mungkin dia terdistribusi secara global atau geografis, multi-continent, multi-country. Kemudian performance yang tinggi dalam read and write, dan ini yang paling penting adalah vendor independent, artinya bisa diinstal on-premise, bisa diinstal cloud, dan kalau kita bicara cloud, tidak hanya satu atau dua vendor, AWS, Azure, GCP, Alibaba, you name it, or even on-premise, bahkan dimungkinkan juga hybrid. Oke. Ya, kemudian, nah mungkin beberapa orang Cassandra baru dengar hari ini atau baru terdengar samar-samar, tapi saya yakin yang nama-nama berikut Anda pasti tahu semua. Ada Netflix, Apple, Stern, Huawei, dan sebagainya. Nah, ya inilah nama-nama yang menggunakan Cassandra. Bahkan boleh dibilang dua nama besar di atas, Netflix dan Apple, menggunakan di production. Jadi kita, meskipun kita belum tahu Cassandra, tapi dari siapa yang menggunakan, kita sudah tahu apa atau sekelas apa, level apa yang digunakan oleh, yang bisa dihandle, data yang bisa dihandle oleh Apache Cassandra ini, berdasarkan hanya dari nama-nama yang ada di sini. Nah, ini kita ngutip. Jadi Indonesia ini kesekian negara kesekian yang Cassandra Day. Sebelumnya kalau tidak salah, I believe in June or July, Alex,
Yes.
Cassandra Day India. So it is from Cassandra Day India. We
Right.
quote some slide from Netflix engineer Vinay Chela. Jadi di sini kita bisa lihat ukuran atau seberapa besar yang bisa di-handle oleh Cassandra. Sebagai contoh, 30 juta operation per second itu di single cluster tunggal yang paling aktif. Kemudian 500 terabyte data hanya di single cluster atau di cluster yang paling padat atau paling density-nya paling tinggi, dan menggunakan CPU hingga mencapai 9.216. Nah, dari angka-angka ini saja kita sudah bisa membayangkan berapa skala yang bisa dihandle oleh Cassandra ini.
Right. I would also add here,
Yep.
Vinay Kumar Chella, he's a cloud database architect in Netflix and one of the biggest Cassandra developers. My point is what Apple, Netflix, Instagram, and other companies, they are not only using Cassandra, but they are also developing Cassandra, and they did incredible effort to release recently released version 4. So that's incredible how many biggest companies work together to develop the database.
Great.
Even then their competitors in real life, they still work together on Cassandra. I like it.
That's the beauty of open source.
Yeah, right.
Many companies, many developers contribute to technology that may have benefits to all of us actually. Yeah. Okay. Dan berikut adalah agenda hari ini. Jadi setelah ini kita akan langsung masuk ke workshop pengenalan Cassandra oleh Alex sendiri yang akan membawakan. Jam 12.15 nanti ada break quiz. Kemudian jam 13.15 sekali lagi ada quiz live dari DataStax. Dilanjutkan dengan workshop data modeling dengan Cassandra. Nah, ini data modeling ini penting. Mengapa? Karena meskipun Cassandra itu powerful, diperlukan suatu pengetahuan, suatu skill, knowledge, terutama dalam data modeling untuk bisa menggunakan menggunakan Cassandra secara optimal. Maka workshop nanti data modeling menjadi syarat utama untuk bisa menggunakan Cassandra dengan optimal. Kemudian kita lanjutkan dengan sesi tanya jawab pada jam 15.45. Tentunya sekali lagi Alex dan Stefano dan mungkin beberapa orang dari DataStax akan hadir dan sekaligus menjawab. Mereka adalah praktisi, para pakar yang sehari-hari sudah menggunakan Cassandra. Jadi kita manfaatkan kesempatan tersebut untuk bertanya kepada para ahlinya. Kemudian dilanjutkan dengan pembuatan aplikasi. Nah, ini yang menarik. Pada ujungnya, akhirnya kita harus membuat aplikasi. What application we want to make? And Stefano will present about the one example of how to make application using Cassandra. Dan pada saat penutup nanti masih ada satu quiz lagi. Dan maka pastikan Anda tetap menyimak terus, stay tune ya, karena ini setidaknya ada beberapa kesempatan quiz. Nah, sekali lagi saya highlights ya. Jadi jam 12.15 nanti sebelum break makan siang, kita akan share satu link. Silakan diisi, berhadiah OVO sebesar Rp400.000 untuk 3 pemenang jam 12.15. Pastikan Anda tetap di channel ini. Kemudian setelah kita istirahat jam 13.15 kita mulai lagi yang lebih live competition tentang Cassandra, kemudian lebih seru lagi. Masih ada kesempatan memenangkan hadiah nanti pada jam 15.45 pada saat tanya jawab. Sesi pertanyaan yang menarik, paling menarik akan atau berbobot akan sekali lagi diberi hadiah oleh DataStax. Dan bahkan sampai akhir pun nanti jam 17.15 kami masih menyediakan hadiah. Jadi pastikan Anda stay tune di channel ini sampai dengan event ini berakhir. Kemudian begitu pula ini ada link untuk voucher atau sertifikasi. Mengapa sertifikasi? Karena sekali lagi untuk menggunakan Cassandra dengan benar, Anda memerlukan skill tertentu dan sangat dianjurkan untuk memiliki sertifikasi. Dan itu bisa dilakukan pada link tersebut, silakan dikunjungi, kemudian kita ngisi form, maka Anda berhak antara salah satu antara voucher sertifikasi atau kredit DataStax Astra. DataStax Astra adalah versi cloud dari atau DBAS. Ya. Nah, siapa yang menyelenggarakan event hari ini ada disponsori dan diorganisir oleh DataStax Developer. Nah, connect every developer in the world to the power of Apache Cassandra. Just like Alex mentioned before, many developers, many companies, many organizations contribute to Apache Cassandra. Ya. Dan oke, kita masuk. Alex, you want to introduce yourself? Here, Alex, in your screen.
Yes, sure. First of all, I speak English, Russian, German. I learn Italian, but I don't yet speak Bahazan. So for
Don't
the
worry, never mind.
so for the workshop, I will try to do it simple and useful for you as possible. But Cassandra fundamentals and Cassandra data modeling will be held in English with a strong support of our Bahazan-speaking friends. So Diki, our partners from SPS, and some more people will support you in the chat and will answer your questions in the chat. About myself, I am a developer advocate at DataStax. For the last years, I'm working to deliver best of the world knowledge to best of the world engineers like you. And we will today learn the fundamentals of very powerful but not so simple database as Apache Cassandra. And I would say many thanks to Stefano Latini and Dicky for the people who work so much to help us deliver this Cassandra Day Indonesia. That's incredible day for me, and that's just exciting what's the collaboration was done behind this to make it happen. So thank you so much, Dicky.
Yeah,
and
you're welcome.
Yep. Do you have some more slides?
Yeah.
Okay. So let's proceed then.
Okay.
Yep.
So after this, this is only a note. Saya ada beberapa catatan penting. Ini bisa beberapa link penting dan yang berhubungan dengan event hari ini. Yang paling penting adalah academy.datastax.com. Itu adalah tempat di mana kita bisa menggali konten, kemudian materi-materi kurikulum yang kita perlukan untuk nanti mengambil sertifikasi. Dan sebagaimana Alex katakan, presentasi nanti sebagian dalam bahasa Inggris, tapi ada saya dan ada beberapa chat moderator yang akan mendampingi teman-teman dalam bahasa Indonesia. Ya, sekali lagi saya ingatkan, jam 12.15 ada quiz. Jangan kemana-mana, ada quiz jam 12.15, dilanjutkan jam 13.15. Sekali lagi ada quiz live dari DataStax. Nah, pada saat sesi tanya jawab nanti, silahkan dari rekan-rekan developer, jangan ragu untuk bertanya. Silahkan dalam bahasa Indonesia, kita akan bantu juga. Untuk itu saya hadir bersama beberapa rekan untuk memastikan bahwa jika Anda memiliki pertanyaan, kami bisa menyampaikan kepada para pembicara hari ini. Ya, dan pada saat exercise nanti silakan jalankan exercise, nanti Anda akan mendapatkan badge yang bisa Anda pamerkan di lab GitHub Anda, sebagai contoh. Yap, dan yang penting bahwa nanti ada voucher gratis untuk sertifikasi Cassandra, dan sebagaimana saya katakan, Cassandra ini memerlukan skill, memerlukan knowledge dan skill dan sekaligus sertifikasi untuk bisa menggunakan secara proper. Manfaatkan kesempatan ini, nanti isi formnya dan Anda mendapatkan voucher sertifikasi gratis dari Apache Cassandra. Baik, sekali lagi menjelang penutup jam 17.15 kita masih memberi lagi hadiah. Jadi stay tune sampai akhir, nanti jam 17.15. Jangan kemana-mana, kita nikmati hari ini. Okay? So, that's it from me, Alex. So, enjoy the day. Yeah, enjoy the day, and I hope this day will bring many benefits to here community and developers in Indonesia.
Yes. Yeah. So, we will get back in 1 minute to start first Cassandra Fundamentals Workshop. Let's make this day great.
Okay.
So, hello
everyone.
Hey.
Hi Alex, how are you?
Hi Stefano, I'm very good. I'm happy to be here. And I'm happy, that's another Cassandra Day. Last one was too many months ago. We have to do it more often.
Yeah, we had a summer stop, but we are back to rock. So, hi everyone, welcome. It's very great to see so many people, and as you said, Alex, Cassandra Days are one of the best things that we do because they are fully open source, and it's a good occasion to reach many interested people and make Cassandra known because it's great. And I think Alex is going to explain to you how great that can be.
Yeah, and I hope you will help me.
I will, sure. And in particular, I think we have someone in the chat, Lukmanul, and maybe Diki, and maybe also
SBS
somebody
people?
else.
Yep.
Yeah, people from SBS who will help you guys with questions, with anything, especially when it comes to language support. So we will be speaking English, but no problem if you want to express yourselves in Bahasa.
Yep.
Yeah, you.
Good. And we have a question from Tommy Hendravan. What's the best case to use Cassandra? We have a special slide on that, so don't rush. You will see it very soon. And that's a good time for us to start. To stay on track, we have a lot of things to cover today. So, let's go. Apache Cassandra is a NoSQL distributed, decentralized database, and it's used by the biggest and most known world companies over the world for the following features, what makes this really incredible database. It's at first absolutely ready to work with the big data. And then I say big data, I mean like huge, tremendous amounts of data. For example, Apple handles, with help of Cassandra, hundreds petabytes of information. Cassandra provides highest possible availability with replication and multi-data center deployments. Using multi-cloud, for example, you can try to reach even up to 100% uptime even under some very bad circumstances like a disaster or something like that. So it's the highest possible availability on the database market. Geographical distribution. Then your company is globally geographically distributed and you have clients in Australia, Asia, Europe, and the United States, for example, you want to keep your data as close to your clients as possible, so they will always have a great response time. Then that's getting very important. When read and write performance, of course, that's very important for us for the database to be fast, even then it handles again petabytes and petabytes of data. And finally, Apache Cassandra is managed by Apache Software Foundation, non-commercial, non-profit, open source software organization, which makes the decisions about Cassandra. So it's vendor independent, it doesn't belong to any commercial company, and it's open source software, of course. So if you want to participate in development of such a database, you can do it because it's open source. So Cassandra is used by many companies you know. Technically, you are already using Cassandra, even if you don't know it, but if you have iPhone or MacBook, you use Cassandra. If you watch Netflix, you use Cassandra. If you send or watch photos on Instagram, you use Cassandra, and so on and so forth. So, what are the primary features people pick Cassandra? First, it's distributed, so it's running, it can be launched in multiple data centers over the world. It's highly scalable and highly responsive. It's also replicated, so your data is stored not on a single machine, but on the multiple machines on multiple data centers. So it's highly available. And finally, it's masterless, decentralized, so there is no single point of failure. With other databases, those follow master-slave or primary-secondary server architecture. This master server or primary server is always a single point of failure. If it's out, you cannot write to a database anymore. Cassandra is decentralized. That means that there is no master node and every node is able to process every request. When we speak about scaling is highly important for your database. Maybe in the beginning you don't have too much workload, you don't have too many queries to serve, and you don't need to have like powerful database served by the cluster of thousands and thousands CPUs. So how do we scale database normally when we need more firepower, when we need higher performance? Typical approach is to have vertical scalability. So that's a normal way for the databases to scale up. They go for vertical scaling. What means vertical scaling? It means what basically you replace your previous machine, previous server with a more performant one, which has more memory, more CPU cores, and so on and so forth. And then you just move your database to this new server, and it's great, but it has some problems. Vertical scalability, although it's easier to get, it's also getting extremely expensive very soon because powerful database servers, they are also very costly. And there is still problem of single point of failure, SPOF. What then your server is down, doesn't matter if it's expensive or not, or if you have no internet connection with the server, you cannot reach it. There is another way to scale distributed systems known as horizontal scalability. Horizontal scalability means what we do not replace one server with another, but that means what we add more servers to the cluster. So that gives us some benefits. First of all, it's normally cheaper to reach the same performance level as we would have with a single highly performant server with multiple commodity hardware servers. Second, it removes single point of failure because now my data is spread over multiple machines. And there is no single point of failure. In case one is out, data is replicated to others. Of course, it's logistically harder, but good news with Cassandra. Cassandra manages this logistics complexity, which is very helpful for us because we just want to store our data, we don't want to lose it, and we prefer to spend as less time administering database as possible. Cassandra scales horizontally, and Cassandra has linear growth of performance and linear growth of workload. Cassandra scales horizontally. Okay, that means add more servers. But what does that mean, linear growth, exactly? The point is, other databases, then you add more nodes into the clusters of other database management systems. Performance doesn't grow linearly. Every next node introduced to a cluster, every next server may bring some overhead, and as a result, the more servers you add, the less performance you get in the end. With Cassandra, which scales linearly, it's different. It means what if you want to have to double performance of your cluster, doesn't matter if we speak of operations per second or if we speak about volume, so available disk to store your data. You basically just have to double the number of nodes, and if our first cluster or if our first data center has 3 servers with overall performance of 100,000 transactions per second, when we just add 3 more and we will have 200,000 transactions per second, and so on. There is a great research done by Netflix and published it in their Netflix blog. They benchmarked Cassandra scalability on Amazon Web Services over 1 million writes per second, going from like 45 servers and scaling Cassandra cluster up to 300 something servers, so quite a lot. And take a look at this nice smooth line, nice straight line. The more servers they add, the higher performance they have, and there is nothing like these lines decreasing in the end. That's famous Cassandra linear scaling. By the way, Netflix Tech Blog is a great thing. If you are not yet subscribed, I believe you should, because for me it's a great place to learn something new on how Netflix solves their technical problems. For me, it's always incredible reading, so I do recommend you as well. How does it work? So all the great of the Cassandra features, how does that work? First thing, data is distributed. Take a look. Here we have a cluster of a single data center of 7 servers. We call Cassandra server usually a node, just traditionally. And on the right side, we have a table, a simple table of country, city, and population count. Basically, how many people there are per city, per country. How we normally store these data on a relational database, for example? Each server stores the complete table, and there is normally one master server, what you can store data in, and read replicas, what you can read data from, but you cannot write on read replicas, because they are read-only replicas, of course. Cassandra works differently. Instead of storing a copy of this table on each server, Cassandra distributes data over multiple servers. So you see there are only parts of this table on each server here. You may ask why. Why does it happen? Why does Cassandra is doing like that? Answer was on the first slide. Cassandra is big data ready. And there are many definitions of what is big data, but I prefer the simple definition. Big data is the data which doesn't fit to a single server. As said, Apple handles hundreds petabytes of data with Cassandra. Can you imagine copying hundreds petabytes per server? It makes no sense. There is no server able to survive it and be performant at the same time. Yes, with network attached storages or things like that, you can have such capacity. But can you get the answer within single-digit milliseconds? No. With Cassandra you can, because Cassandra distributes data over multiple servers. That gives us also this ability to scale indefinitely. Because when we just have more data, we have to put it on the bigger amount of servers. We put more servers into the cluster, and data will be redistributed over new servers as well. So, okay, data is distributed, but it's called partitioning, by the way. But how exactly data is partitioned? Take a look at this table again. You see how country column is marked specially, partition key. What does that mean? When we create a table, we have to assign a partition key. This partition key defines how data will be spread into partitions. So take a look. We have these country values: Australia, Canada, Deutschland, Germany. So this is a partition key. Value of this column is hashed by a partitioner with murmur-free hashing algorithm into an integer. So we see here 59, 12, 12, 45, 45. Why? Because we need these, they are known as tokens. Basically, hashed value of Australia is, let's say, 59, and those are tokens. I would have to admit what actually normally tokens are not like 59 or 12. They are integers, but much bigger, longer, because again, we may need a lot of partitions. But anyway, as a result, every row has a token assigned to it. In this case, for the demonstration purposes, we use the simple integers, so it will be 59, 12, and 45. Now take a look at a very important point. Every server you have is responsible for the range of tokens. For example, in this case, we have 4 servers, and each of the servers therefore responsible for the range of tokens. For example, this one from 1 to 25, this one from 26 to 50, 51 to 75, and so on. And now you can guess why do we need integers here. Of course, rows with token 59 will go to this server, and rows with token 12 will go to this server, and rows with token 45 will go to this server, and this server for the moment stays without any information, which is completely fine. We will keep it busy later. So, Cassandra nodes are responsible for token ranges, and rows with a token go to a proper node, and they together build a partition. Partition, we will speak a lot about it today. Partition is a group of rows stored together because they share partition key value. Now, how Cassandra cluster scales out or scales in? Imagine on many businesses, sometimes you have Black Fridays, you have, I don't know, New Year sales or so on. So when you have a lot of customers who want to buy a lot from your company, and many people visiting your website, using your application, and so on and so forth. During this time, you need to have a lot of servers. And then there are times when people are busy in vacations, people don't visit your website, don't use your application because there is, I don't know, whatever time is not really for them to buy something. So every business has some times when it's in high demand and in low demand. For example, and for big companies, again, like Netflix, it costs literally hundreds of thousands of dollars per hour to run huge infrastructure. That's why Netflix prefers to keep very dynamic infrastructure. If they need more nodes, if they need more computational power, they will put more servers into a cluster. But for example, when they release a new episode or new season of Games of Thrones, or sometimes there is everything quiet and they don't need such many nodes. How that works? Take a look. Now every server in my cluster is responsible for the range of 25 tokens. There are actually not from 0 to 100, again, there are much bigger ranges, but it should work well. Then I introduce a node number 5. Then Cassandra will automatically recalculate the token ranges. And we will see what this server is responsible for token ranges from 1 to 20. This one from 21 to 40, 41 to 60, 61 to 80, 81 to 100. So Cassandra cluster will recalculate distribution of the token ranges over servers and bring some responsibility, bring some data to store for the server number 5. Quite opposite, if you don't need such a high firepower, so such high computational power on your cluster, you can decommission this node, take it down, say to Cassandra cluster, okay, I don't need that anymore, and therefore again Cassandra cluster will recalculate token ranges, and this one will be responsible 1 to 33, this one will be responsible 34 to 66, and this one will be responsible 67 to 100. And data will be shuffled over cluster to keep it all available. That's incredible, because this partitioning is fully automated and you don't have to think or manage it anyhow. You just have to design your data model right. I'm speaking about that because, well, I've worked in my life with very many different databases, and something similar to Cassandra's partitioning in relational database world, known as sharding. And it's not even close from the any point of view. You have to do a lot of manual work to make your sharding work. And in case you change something, if you want to introduce more servers, you again have to do a lot of manual work. Not with Cassandra. Thank you, Cassandra. So, but that's not enough. Now with distribution of the data, we can scale our cluster linearly. But that's not only that. We still need to have high availability. And it's done with data replication. Replication means what? Your data is stored not on a single server, but the same exact data stored on multiple servers. Take a look. There is a thing in Cassandra known as replication factor. Replication factor means what every row is stored on as many different nodes as specified in replication factor. So in this case, I have replication factor 3. It means what my rows for Canada, or better to say partition, it's important, will be stored on 3 different servers. That's what replication factor 3 means. How it works? Then my server, when any of the servers, because any of the servers is able to process any query, any request, receives data for Australia. Let's say server number 17 got this query. This server is not responsible for this piece of data. Data is distributed and replicated, but this particular server is not responsible for this data. What will it do? It becomes so-called query coordinator. Query coordinator's job is to define which servers are responsible for this data and deliver this information to them about a change. For example, you added some new data, you added a new city, or changed something because there are some new citizens in Sydney, for example. So that's what query coordinator does. It calculates proper servers and dispatches this information to them. By the way, it's very important to understand that there is no designated query coordinator, but every server what gets the query becomes query coordinator. So if it would be server 50, it would be server 50 as a query coordinator. And as a result, all of our replica servers, replica because they bear this information, they will get this data. Now, what happens if one of the servers is on fire, literally or not so literally, but that doesn't matter. Anyway, it cannot store your data. Power outage, network issues, schedule it, update, whatever. What happens then? That's interesting. Cassandra has very many layers of self-defense from cross-node inconsistency. And that's the first layer of defense. It's called hinted handoff. When query coordinator sees what one of the nodes is not available, so this server confirmed I got your data, this server confirmed I got your data, and this server is quiet, when query coordinator will store the hint on disk, and as soon as this server recovers, query coordinator or query coordinators, if there could have been many operations during this time which this node was not available, they will dispatch hints again fully automatically, and this server recovers and becomes into a consistent state fully automatically, and you don't have to think of that, you don't have to do any manual operations. That's cluster job, and cluster is very good in doing that. So that's just incredible. It's called self-healing. Then a cluster recovers itself from a failed state into the good state. And that's amazing. And while we are having all of that, that's important to understand what even when one node is failed, our data is still stored and available on other replicas, so we can keep working with it. And a single server outage is not a reason for us to panic, because we still have no downtime. That's incredible. High availability as it is. So, and together with decentralization, distribution, and replication, Cassandra helps us to build globally geographic distributed systems. For example, you can have multiple data centers in multiple regions, but working together, and this is a single cluster. So that's not like multiple clusters, that's one single cluster, which is built of multiple data centers across the world. And it's very easy with Cassandra. Again, that's a native behavior. For example, with our databases, if you want to build multi-data center active, then it's a big problem. And obviously with Cassandra, it's a native behavior, so it was created to handle these kind of workloads. And finally, as I said before, Cassandra is platform agnostic and cloud agnostic. So you can run Cassandra cluster on Microsoft Azure Cloud, Amazon Web Services, Google Cloud Platform, on your own on-premises data center simultaneously, and it will be a single cluster working together. So this one may be on Azure and this one may be on AWS. AWS is cheaper in the United States than in Europe, for example. And you can completely go for it, reaching multi-cloud or hybrid cloud as it fits your strategy. How data replication works in multi-data center deployments. So take a look. First, that's important to understand what we can specify different replication factor for different data centers. In this particular example, we have replication factor 3 in each data center, but it can be different. So I can say what in this data center I need replication factor 5, which is a rare case, but sometimes we may need it. And I can have replication factor 1 on this data center, or even 0, and I won't have any copies of this data on the data center east. For example, if data of my west clients, I don't need to be duplicated in another data center. In this example, we have replication factor 3 in each data center. So how does the multi-data center replication works? Then center in the data center west receives this query for still our dear Australia. Then that's when this node becomes a query coordinator, right? So it will dispatch information to all the replica nodes of each server asynchronously, simultaneously, non-blocking. And at the same time, it will make a call to a data center east. to a query which will become a remote query coordinator. And as soon as this remote request reaches remote coordinator node, it will dispatch information to replica nodes of a data center east. Boom, deliver it. So after those two simple steps, data is spread all across the cluster. What are the main use cases for us? What are the main use cases for Cassandra? Scalability and everything what belongs to scalability. If you want to be able to handle high throughput, or if you need to store a high volume of data and process a lot of heavy writes or process a lot of heavy reads, you can do it with Cassandra. And there are many use cases when you have really write-intensive operations. Event streaming, Internet of Things, logs, any other write-intensive time series, but also heavy reads. Some people say Cassandra is read optimized. Some people Cassandra is write optimized. You know what? They both are right, kinda, because Cassandra is optimized for everything. That's one of the best benefits. People often ask me, how does Cassandra compares to MongoDB? That's a very common question. They both belong to NoSQL world. Mongo has some of its benefits, like this no schema, or better to say flexible schema. And it scales good for read-intensive operations. But when you have really a lot of writes, Mongo doesn't scale so well. With Cassandra decentralization, it scales much better for write-intensive operations, of course. Okay, so availability. Every time when you require 100% uptime, or at least as close as possible to it, with no data loss, always on data database, that's also very much about Cassandra. And there is a lot of kind of information you want to be always on. And we use it to think of the banking, we use it to think of the data like required for financial operations. But what if I tell you what also Cassandra is heavily used by medical institutions, exactly for always on highest possible availability. For example, one scientific institution in Germany heavily uses Cassandra, not because they require a big data feature, at least not yet, they don't have too much data, but they require highest possible availability, because at some point it can be a question of literally life and death. So that's a very good case for Cassandra with multi-data center highest application deployments. Well, distributed, as said, you can have a global presence with Cassandra with multiple data centers over the world. It also may be important for compliance or GDPR purposes. So, for example, in Europe, in Germany, you have to store data of German clients in your German data center. You cannot store it in the United States data center. With replication factor of Cassandra, you can simply specify what you're going to have replication factor in Germany and have zero replication factor in the United States, and your data won't be replicated to United States, so you follow these GDPR requests. I don't know if you have something like that in Indonesia, but it's nice to know what this feature is available at least. And finally, everything what belongs to modern cloud native applications. So everything what you may want to run on Kubernetes, everything what you can run as multi-cloud or hybrid cloud, Cassandra supports it natively. Now, by the way, Stefano, are there any questions you would like us to answer by voice?
Well, there have been a few questions about whether Cassandra is good for multidimensional data warehousing solutions, but I answered in the chat. So Cassandra itself is more for OLTP, but it is well integrable. It can integrate well with, for example, Spark or Hadoop. That was a question. The other interesting question, while you were about to speak about that, was about what happens when you want to add a node. So not only is the process of redistributing data basically automated, but the nature of the hashing, it is called consistent hashing. That's a detail that makes it optimized. So it's the way data are hashed and distributed across nodes is such that when you change the number of nodes, the minimum amount of data has to move around. And that's you can mathematically prove that the hashing that Cassandra uses is achieves the minimal amount of data moving around, which is good when you have terabytes or petabytes. So yeah. Okay, well, that was it. And yeah, I think you can go ahead because there were questions about consistency as well. And I just answered, you will soon see it more in detail. So go ahead.
Yeah, thank you. Okay, so thank you for asking questions. Don't forget and follow Stefan's instructions on asking questions at datastax.io, CD Indonesia questions and answers. That's
sorry,
important.
By the way, yeah, you can ask questions in Bahasa and in English, no problem. And you can also go there and just upvote other questions just to give them priority, because then we will try to address them all from the start.
Yep. And don't forget what the best questions will get deserved prizes. So you can and you should maybe ask your questions on YouTube, but don't forget to go to datastax.io, CD Indonesia QA question link is in the chat, and ask them. So famous Cassandra consistency. Many people call Cassandra's consistency eventual. Soon we will see if it's right, or you will see. So, I believe some of you already understand the problem. When you have no replication for your data, and all data stored on a single server, like traditional relational databases, whatever you ask your database, you always get the most up-to-date information. But the replication, when you store different copies of your data on multiple servers, there can be a potential danger of inconsistency or cross-node inconsistency. What does that mean? If two servers got the update and one server didn't get the update, if you ask those two first, they will give you the most up-to-date value. But the third server wasn't updated for whatever reason, shit happens. And then you just ask it for the data and you get stale data. That's known as cross-node inconsistency. Let's take a look at it. But before, we have to learn something new. There is a thing known as CAP theorem or Eric Brewer's theorem. And that's a very important thing to understand. That's not about databases only. That's about any distributed system. And if you are developing a distributed system, you need to know how it works. You are welcome. So, CAP theorem claims what in the distributed environment, in case of failure, you can have only two qualities out of those three. What does that mean, and what are those qualities? Take a look. Three qualities of the distributed system we need to understand: consistency, availability, and partition tolerance. What does that mean? Let's start with the simplest one, availability. Availability means what then you ask for something, you ask your system for something, you ask your database for something, you get the answer. That's simple, it's a simple quality. If you ask your database all the time for something and you always get the answer despite any issues, your database is highly available. If you ask database, but in some cases of even minor outages, you don't get your answer, it means your database is not highly available. Consistency. Consistency is the idea I explained just a minute ago. Consistency means whatever server of your distributed system you ask, you get the same answer. So basically, if you have three servers and you ask each of them, you will get the same answer every time. And if data is changed, you update some information, it will be updated on all of the servers. Let's call it consistency in this case. And the third quality is partition tolerance. Now, it's the most misunderstood quality because people misunderstand that all the time. I will help you to do it right. Partition tolerance means ability of your system, of your database to survive network partitioning. What is network partitioning? Imagine I have 5 servers and there is a network split. So my network, I have a network connectivity issues between some servers to other servers. For example, my servers A, B, and C can reach each other, but cannot reach servers D and E. And therefore servers D and E can reach each other, but cannot reach servers A, B, and C. That's called network partitioning. If your database is not ready for network partitioning, so it's not partition tolerance, it may lead to a real disaster. Then different clients will work with a different part of your clusters, but updates cannot be delivered to the second part of your cluster because ABC cannot communicate with D and E and vice versa. What does that make in the end? Some servers, some of your clients work with the first segment, some of your clients work with a second segment, and as a final result, you have 2 completely different copies of data. And what's worse in this scenario, there is no single chance to recover from this state kinda automatically. It may take really a lot of manual work to try to put all the data together. Network split, it's also known as split brain problem, is a huge disaster because servers will restart and recover, consistency may be recovered, but split brain is a huge disaster. So, the CAP theorem states what when everything is good and sun is shining and grass is green, rainbows and ponies and so on, your database will be consistent, available, and partition tolerance at once. But as soon as anything bad happens, power outage, network outage, whatever outage, then you can pick only between those 3 qualities, you can pick only 2. And at this point, you have to decide if you want to be consistent and available and partition tolerant and consistent. So there are only 3 options. And by no circumstances you want to quit partition tolerance because it's very important. It's the worst kind of a possible outcomes, possible problems with that. So technically we can decide between availability and partition tolerance, overall known as AP, and we have to decide between consistency and partition tolerance, known as CP. So you have to stay with consistency and partition tolerance or availability and partition tolerance, CP or AP. Again, that's not only about Cassandra, that's about any kind of a distributed storages. Is Cassandra AP or CP? There is an known statement what Cassandra is AP, available and partition tolerant. But I cannot fully agree with that because Cassandra is configurably consistent. And in any moment of a time for any particular query, you can set your consistency level you require to have. And that means what I can switch with Cassandra from this field to this field in any particular moment of a time per each particular query. So I do it with consistency level. What is it, consistency level? Consistency level means amount of replica nodes I will wait to confirm the data is not stale, to confirm what data was delivered, for example, when I insert or update some information. Typical consistency levels we work with is any, 1, 2, 3, quorum, and all. So, as said, what does that mean? Consistency level 1 means what if I have a write consistency level 1 replication factor 3, Client writes something to me. Query coordinator dispatches this information to all replica nodes, but it will wait only for one confirmation what data was persisted. So these three requests will be executed all at the same time, simultaneously, asynchronously. But as soon as I get first answer, it will be immediately returned to client. Okay, dear Mr. Sir client, we got your data, everything is good. With consistency level quorum literally means majority. So for replication factor 3, majority of the nodes will be half plus 1, 2. So majority for replication factor 3 is 2, majority for replication factor 5 is 3, half plus 1. And as you could guess, as consistency level is quorum, so it's 2 for replication factor 3. It works exactly the same way, except of the fact I will wait for 2 confirmations. 1, 2, okay, we are good. And finally, with consistency level all, as you could guess, I will wait for confirmations of all replica servers, so I won't return answer to a client before data is confirmed to be received by all of the servers. And for multi-data center deployments, there are some more options. Local one, local quorum, and each quorum. What does that mean? Local one and local quorum both have a local prefix. What does that mean? Take a look. When you have database servers and application servers in the United States, in Asia, and in Europe, you want your application server in the United States to work with which database server? The closest one, so in the United States. So for application server in the United States, local means United States data center. For your data center in Asia, local will mean local data center in Asia, and therefore for European, local will mean European data center. Why does that matter? If your application server is closest to this data center or this Cassandra cluster, you don't want it to work with this one, because it will take a lot of time, like transatlantic connection is not as fast as a local connection in the same physical DC, let's say. When you specify local one or local quorum, it will wait for the confirmation from the closest servers. And each quorum, quite opposite, means what it will wait for confirmation of every replica of quorum of replica servers in each data centers you have. Each quorum can be dangerously slow because some of the data centers may be very remote, but it guarantees what quorum of every data center will get this information. Now take a look. Do you remember when people say what Cassandra is AP? I disagree. Because Cassandra is neither AP or CP, but Cassandra is configurable. Take a look. You can set consistency level 1 and wait for a single confirmation. It may work a little bit faster. You can set consistency level quorum and get confirmation of a majority of the replica nodes for this piece of data. You can set consistency level all and wait for confirmations of all of the replica servers. And now you may think, hey, consistency level all is great. Consistency level all is exactly what I need. I will always use consistency level all, right? Yes, but no, there is a big problem. The problem is CEP theorem never quits, never sleeps. It's always there, and it will catch you as soon as you go with consistency level all. Take a look. Then you go with consistency level all, you move from availability and partition tolerance into consistency and partition tolerance. So basically you move from AP to CP. And although it's great from the consistency point of view indeed, you are not available anymore. Why? Because the idea is very simple. When you start to use consistency level all, you will have to wait for the confirmations of all of the replica servers for this partition. And if one of the servers is not available or slow, you will get an exception after some time, cannot reach desired consistency level. You choose consistency over availability. Here we go. You are not highly available anymore. Now you may ask me, okay, Alex, that's all great, but you know what? I work in bank or I work in somewhere. I want my data to be fully consistent. I don't want my client to hate me because we treated their bank statement, bank accounts in the not fully consistent way. Does that mean what I cannot use Cassandra after all? No. You can, and actually a lot of banks are using Cassandra. But how do they reach consistency? There is a thing known as immediate consistency. There is a sweet spot in the middle of CAP theorem, and we can try to get there as close as possible, at least with the immediate consistency approach. What does that mean? Take a look. If I write with the consistency level all, that means what all of the nodes will get up-to-date information. I know it. Then I can read with consistency level 1. It doesn't matter which node will first give me the response. It will be always up-to-date. Sounds good, and read time may be very fast, but it's not optimal from the write point of view. And again, I may run into the problem of data not available because one server is down. There can be a second way. If I write with consistency level 1, so I know what at least one server will get my data, then I can read with consistency level all, and in any case, I will get information from all servers. Query coordinator will compare the data, return most up-to-date answer to me, and initiate repair to recover cluster consistency. But it also has this problem. Now my write time is perfect, but read time is maybe endangered, and we will have some repairs on read, which is maybe not the best. The right way to reach immediate consistency is write with consistency level quorum, read with consistency level quorum. And now take a look. There is a little bit of mathematics. Quorum means majority. 2 for replication factor 3, 3 for replication factor 5. A little bit more than half. And if I write with consistency level quorum replication factor 3, that means what I will wait for 2 confirmations. It means it's guaranteed what 2 of my servers got the right data. They are up to date. Third one may be not up to date. Mostly probably it's up to date. We cannot be sure. But we already got 2 fastest answers. Then we have, we read with consistency level quorum. Consistency level quorum means we wait for 2 answers. And now take a look. There are 2 possible scenarios. All servers are up to date. Then we are obviously good. What doesn't matter which server you ask, you will get up-to-date information. And there is a bad scenario. When this server actually didn't get the data, it was out or it was some network issues, whatever, doesn't matter. It didn't get the data. It somehow didn't get the hinted handoff. So it has the stale data. But as we wait for 2 answers, not 1, but 2, when we read, that means what again, there are 2 possible scenarios out of that, out of a bad scenario we've chosen before. If those 2 servers are first to answer, then I get most up-to-date information, which is returned to the client. And if this one server and this one server first to answer, so I get one outdated data and I get one up-to-date information. When query coordinator compares them, sees the inconsistency, returns to client most up-to-date information, and initiates repair for this node, so it will get data, it will recovers from this inconsistency. And that's the story. When you write with consistency level quorum and read with consistency level quorum, there is no mathematical possibility to run into inconsistency, because you are always consistent, but meanwhile you can afford losing a single node. So that's the right way to work with Cassandra, using immediate consistency. To be a bit more scientific, I will give you a little formula here, but very simple one. If consistency level of your write plus consistency level of your read is more than replication factor, that's called immediate consistency, and that means what you are always getting most up-to-date information. So consistency level of write quorum will be 2, plus consistency level read quorum will be 2. 2 plus 2 is 4. 4 is bigger than 3. And here is the immediate consistency. Consistency trade-offs. The higher the consistency, the less chance you may get stale data. We pay for this with possible latency. All the nodes are asked at the same time, and then for the higher amount of answers we'll wait to, higher the chance there will be some latencies, of course. So if you execute query with consistency level 1, it's obviously what you will follow the first received answer, the fastest answer you will get. And it depends on your situational needs, absolutely. And for different scenarios, for different types of data within the same application, you may want to use different kinds of consistency levels, and that's completely fine. For example, for IoT and sensor systems with extremely write-heavy workloads, where you can have millions of write operations per second, which is quite a heavy workload, you may benefit from consistency level 1 for writes if data is not required immediately. The point is, if data was delivered, it will be delivered to other servers. Consistency level 1 already guarantees what data has reached your server. If you don't read this data from other servers immediately, the very same moment you store it, then consistency level 1 may be a good choice for you if you require highest possible performance. But overall, our recommendation is to go for quorum. Quorum for the reason I've explained it already. Hey, Stefano.
Hey.
So, how it goes? Are there any good questions?
Yes, there is. I think the chat is on fire, but DK manages to help me answering all of them. But I picked a few questions that, if we have a few minutes, I would like to bring to anybody's attention. One is a very interesting question. Ismail is asking, I have a workload based on event logging with a lot of writes and few reads, and they are all time ordered. Is Cassandra good for that? And what I said is, that's exactly one of the best use cases for Cassandra, because not only is that write optimized, so if you have a lot of writes and few reads, that's really the best use case for Cassandra, because he mentioned, if I'm not mistaken, that they are using Mongo for that, but Mongo is showing its shortcomings when it comes to this kind of workload, and I can relate to that a bit. No offense to Mongo meant, but that's exactly one of the best loads Cassandra is built for.
Yes.
And in particular, now that's a bit of an advanced topic, but if you are exploring a switch to Cassandra, seriously, there are several specialized optimizations for exactly that workload. For example, we didn't speak of compaction yet, if I'm not mistaken, but there is a specific compaction strategy to better handle the way data are kept orderly on the disk. That's compaction in short, so to speak. And that's exactly aimed at that kind of workload. Not only that, but if you're planning on having a proof of concept, you can try and reach us, DataStax, for a consultation. That might be the start of a good collaboration. So yeah, that's a very good question. The other one is, what is the language used by Cassandra? That was asked by Basten Angoro. And Diki answered, so Cassandra internally uses a language called CQL, which is not SQL. It's Cassandra query language. You will soon see an example of that, but that's internal, let's say that's the main protocol Cassandra uses to speak with the outside world. But from your application, you can use any programming language because there are a lot of drivers, and you will see some of them later today. The other interesting question, well, that was by Rahul. He asked, what happens if some of my nodes were in a hibernate state or sleeping state? And I think that has been extensively answered by Alex, because it's the same as when your node crashes for some reason and then comes back up. So depending on how long it has been down, there are several methods. In practice, there is the hinted handoff method that was described. There is the repair mechanism that can be manual or automated or partially scheduled. And yeah, so that's more or less an answer. So consistency is always, there are various mechanisms that ensure your data is the same on all nodes. Yeah. So those were, I think, the 3 most interesting questions. And by the way, I thank you all because I had a peek at the questions page, and there are already a lot of interesting questions. So that will make for a nice Ask Me Anything session later. So thank you for writing your questions there. I've already seen a few cool questions to speak a bit about.
Right. Keep it going. Keep it coming. Keep it coming.
Absolutely.
And don't forget to upvote the questions you like.
Yeah, there are several upvotes as well.
Good. So now, data. How Cassandra handles data, what kind of data, and how it's managed. Let's take a look. So, for us, it all starts with a cell. Cell is an intersection of a row and a column. It stores data. Very simple, right? Then a group of cells build a row. Row is a single structured data item in a table. We go one step higher and we already see a partition, and now that is something new. I believe most of you have experience with relational databases. So in relational databases, you have columns, you have rows, you have cells, but you don't have a partition. And that brings us to a very common mistake when people misunderstood or underestimate the importance of a partition knowledge, understanding of a partition, and they run into problem. Cassandra is a very powerful tool, but from the point of the complexity, as any powerful tool, basically, on the scale from a bicycle to a Boeing, it's a very much of a Boeing, not a skate or bicycle or something like you can just jump in and ride. No, you have to learn something from that. An idea of a partition and partition management is the most important thing to learn during this workshop. So, what is a partition? I told you already. A group of rows with the same partition key will group a partition. In this example, if we use this table to define the partition by the department, then those 3 employees, let's say, working in wizardry department will build a single partition, and people working in dark magic department, they will build a second partition. Good. And then finally, table in Cassandra, because Cassandra is also table-based database. It's a group of columns and rows storing partitions. How do we create a table in Cassandra query language? First of all, let's take a look at this definition on this statement. First thing you may think is what it looks very much like SQL, standard query language statement, and it looks like, but don't make a mistake. Cassandra query language is not standard query language, and if you understand SQL, that doesn't mean you are already good to go with Cassandra. Cassandra is different. There are many people doing this mistake, and then they try to use Cassandra as MySQL without joins, and they inevitably fail because Cassandra is not MySQL without joins. Okay, there is no joins, but that's definitely not MySQL. It requires a special approach. It requires some knowledge to manage. So in this case, we indeed create a table. And when we create a table, statement is very simple. Create table, key space, Key space is a simple thing. Key space is just a group of tables stored together. Then table name. When we have column definitions, city, last name, first name, address, email. In this case, they all are text, 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 text. We have more than just text data type, for sure. And then finally, we have to define a primary key. And now this one is important. Primary key consists of partition key and clustering columns. And don't hurry, I will explain it all step by step. So, when we create a key space, we have to create. So, key space is a group of tables stored together. Key space, creating key space, we have to define a key space name. And then there are many possible configurations, options, but only one is required, really, replication. Creating key space, you must specify replication strategy and factor for this particular key space, for which you will create then tables. Let's take a look for that. Key space is a group of tables that share configuration settings, for example, replication. When we create key space, we have to specify replication. First, we have to specify is a class of replication. And there are only two possible strategies. A simple strategy, which is good for your laptop and bad for everything else. And network topology strategy, which is good for your production infrastructure. What's the difference? And what is that? What is the network topology strategy? Take a look. You have, if you use your own data center, you have a data center, you have server racks, and in those server racks, you have servers. If you use cloud deployments, you have regions, and in these regions, you have availability zones. Those are basically the same as regions to data centers and availability zones as to server racks. More or less, I'm simplifying, but that's a general idea. Now take a look. Cassandra tries to put your replicas as far away from each other within data center as possible. Not to put it into a single server rack or into a single availability zone, but to put it to multiple different server racks or multiple different availability zones. Why? Because servers what are in the same server rack or virtual servers in the same availability zones, they tend to fail together because server rack can have a single power source, and if power disappears, the whole server rack will be left out of power. Or availability zone also tends to fail together in cloud deployments. So network topology strategy is smart, and it tries to keep your data in multiple different server racks or multiple different availability zones. So the risk of two different replicas will be down at the same time, will be significantly decreased. So it's very easy to remember. Simple strategy for your laptop or maybe for test environment, for development environment, and network topology strategy for production environment or staging environment. Now we have to define a replication factor. And in this case, I specify replication factor 3 for my data center United States West 1, and I specify replication factor 5 for my data center Europe Central 1. Now, I have a special question to you, and you can answer right in the YouTube chat. Tell me, please, how do you think, how many data centers I have within this cluster, considering this statement is correct?
That's interesting.
How many data centers I have within this cluster if this statement is correct? There is no mistake in this statement. 2. Any more options? I'm curious. I know a lot of people watching us right now. 2. Any other ideas? 3. Okay, why? 2 2. Correct is true. No. No, 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 no. The right answer is 2 or more. The point is, I said before, you don't have to replicate your data over the whole data centers you have, over each and every data center you have. So my cluster may consist of 5 data centers or 10 data centers, 2 dozens of data centers. But if I want to have my key space users over only 2 of them, I can completely go for that. So right answer is at least 2 or more. Good. So I'm glad we clarified that. Now let's move on. Now with a high-level overview, we can remember it all starts with the key space, which stores tables. Then table have a name and have some rows and columns. Within the table we store partitions, and the partition key column would define partitions. Clustering column, we will discuss why do we need them. And data column, what stores data. Now, it's very important to understand the idea of the keys: primary, partition, clustering column. So let's take a look smoothly how it works. When we create a table, we always have to specify primary key. Primary key have 2 main responsibilities. It must ensure uniqueness. It may define sorting. A primary key always consists of at least partition key, because partition key is required, and it may contain clustering column if needed. Now take a look. A good example of a primary key for our users by city table: city, last name, first name, email. There is a line, bad example, right behind me, which has city, last name, first name. Would you please tell me in the YouTube chat comments why this is considered a bad example? City, last name, first name. Why is it a bad primary key? I'm waiting for your answers. Can be not unique. Right, Budi. Budi Hertanto gave the right answer from the first attempt. Well done. Indeed. I did a little check. There are like over 20 of John Smiths in New York. And every next John Smith will be a very bad surprise for the previous John Smith, because Cassandra uses so-called update or insert is technically the same. And that means what next data may overwrite previous data if you don't use special mechanism to avoid that. Then this is the right thing: city, last name, first name, email. In this case, it's basically the same. We just add email, and email guarantees uniqueness of this primary key. But let's move on. Now, first part of the primary key is a partition key. It's required. What is a partition key? Partition key is an identifier for a partition. It consists of at least one column, maybe have more, and it has only one and only one requirement: it partitions rows. Very simple. For example, here we have table, like imagine you are watching YouTube and you are writing comments, and we have to design a table to store comments for your for this video. When we can group them, partition them together by video ID, and they will be stored together, and that's quite a good strategy. We will discuss soon why. Or if we just have a table of users, not grouped by city, but just table of users, so we can use user ID as a partition key. And that's completely fine, because we will have as much partitions as much users we have, and that's completely safe. Cassandra can support nearly any amount of partitions you may want to have. And there is a special bad example, but I won't discover that right now because I have a special explanation for that very soon. I have a special slide for that. And then finally, last part of the primary key is the clustering column. What is a clustering column? Clustering column has two responsibilities. First, it's used to ensure uniqueness. As you've seen, we use it with email to ensure uniqueness, because first example is not unique and second is unique enough. And that's the first responsibility. But there is a second responsibility. Clustering columns also define sorting order within the partition. For example, when we store comments to a video, when we show them, we want to show most recent first. Oldest comments will be down and latest comments will be up. And this example is good because it's unique. We partition comments by video, and clustering column as a comment ID will be good from the uniqueness point of view, because they both are unique and comment ID is universally unique identifier. That is good, but it's not sorted. And if we store that like that, video ID created at comment ID created at will define sorting order, which may be not yet unique because there are many comments wrote in the same moment of the time. And to avoid collision, we add comment ID as a clustering column. And as a result, this one will be not only unique, but also sorted by time. And that's a cool feature because it will be sorted on insert time. So when on read time, I don't have to do sorting because it's stored already in the right order, which is quite cool. Now, if you have no time for the rest of a Cassandra Day today and you have to leave, now pay a full focus. Well, even if you don't have to leave and we want to stay for the full Cassandra Day, still pay a full focus because those slides are the most important. If you won't learn what we are showing right now, you will then, as I say, try to use Cassandra as MySQL without joins, and it may lead to a big problems on your production. Cassandra uses partitioning to distribute data. If you understand this mechanism, you will succeed with Cassandra. If you don't, I'm not so sure. So, there are only 3 rules you have to learn. Only 3 simple rules. And those slides are the most important slides what you will see in this year. I've created those slides. That's why I gave them the Slide of the Year award, because, well, it's of course a joke, but I do believe they are highly important for your success, and I want you to succeed. So, there are 3 simple rules. First, store together what you retrieve together. What does that mean? That means what we should put into the partition something what we expect to retrieve together as a simple query. For example, take a look. We open a video, get all the comments in a single query, not in a dozen of queries. Get them all on the single partition. So as partitions stored together, you will have to hit one single node, not a dozen of nodes. And as a result, we partition comments by video ID. They store it together. When I open a video, it will be one simple request. But take a look. If I don't partition comments by video ID, if I have, for example, partition them by comment ID, so I will have as much partitions as comments I have. By itself, it's fine. But if this video has 1000 of comments, as a result, I will have to reach 1000 of different partitions, and those partitions will be distributed over cluster. As a result, it will be much more operations, and obviously the answer to my client will be much slower, so I want to avoid that. That's always think first about how to partition data, think how are you going to retrieve data. Stephanie will talk more about that on the second data modeling workshop, which is highly important. So, oops, wrong, yeah. Now, avoid big partitions. Take a look. What does that mean? There are some, why do we partition data, first of all? Because we know what, if we want to be quick, if we want to dispatch answers within single-digit milliseconds, we need to partition data and keep partitions not so big. If partitions are too big, we again run into the problem of too much data per server. Server stalls, server works slowly, and we are not happy, our client's not happy, our boss is not happy, and everyone is angry to each other. To avoid that, because I prefer to live in the happy society and keep my clients happy and keep my salary high because of that, we have to think how to keep our servers performant. The key for that is to avoid big partitions. Keep your partitions of a reasonable size. What's important for us and at this point is to control partition size, and we control it with the partition key. For example, in this case, video ID, it means what all the comments for video in YouTube will go to the same partition. And as a result, I retrieve them together, see the first rule, and about the second rule, you can say, hey Alex, how is it right if there are some videos on YouTube what have a lot of comments, like really a lot, thousands. Answer is, yes, you're right. There are some comments with a lot, there are some videos with a lot of comments, but by itself, let's say, what is a comment? Author ID, comment ID, video ID, text, timestamp, author name, because we use denormalization. I will explain it later. So basically that's it. 6, 7 fields, text fields, short fields. There is no way we will store any kind of a heavy data there per row. And as a result, yes, we might have a lot of comments, but this partition still will be small because just of weight of the row per, as it is very low. Another example which I want to discuss, we work in a, let's say we work in an e-commerce company that sells something. And let's say we start in Europe. In Europe, we have a lot of countries, but many of them are very small. Not so many people there. And we have, for our clients, stable partitioning done by country. And it works well in the beginning. But let's say when we go to China, and our goods are extremely popular in China, and everyone is buying something from us in China. And now we have, take a look, we have dozens of small partitions, or maybe not so big partitions, and we have one partition, and we are extremely successful in China, so everyone is buying something from us. So literally, nearly everyone Chinese citizen is in this list. And as a result, we have a bunch of small partitions and one huge partition. That's bad because that doesn't scale well, and this partition, huge partition, is hard for the database to manage and maintain, harder to compact. We don't discuss compaction too much today, but again, keep partitions small. And this partitioning by country may be suboptimal because what is it about partitioning? Partitioning is about even data distribution over the cluster. And it's better to have partitions of more or less the same size. Then it's easier to scale. So what are the limits? There is only one hard limit. You cannot have more than 2 billion cells per partition. Amount of cells is easy to calculate. Columns multiplied by rows will give you a cells count. And that's a hard limit. And those two are recommendations. In general, we recommend to have not more than 100,000 rows in a partition and not more than 100 megabytes of data in a partition. Those are recommendations. There are some people doing ugly things to Cassandra. We've seen partitions over the terabyte of data. And that's
poor Cassandra.
Poor Cassandra. Don't do that. It's disgusting. Keep your partitions
it's performance crippling more.
Yeah. So keep your partitions small. It will work much better for you. Now I have
Alex, sorry, before you move to the next slide, may I just interject shortly?
Yeah, sure.
I've seen a question by Ricky about that makes me think of the need for making a distinction now about primary key and partition key. I know you spoke at length on that, but that's always a bit difficult to grasp on the first get. So look at the slide. You see, let's look at the first example. You see primary key, video ID created at comment ID. These three fields are the primary key. That determines uniqueness of rows. And that's one thing. So there can't be two rows with the same values of these three fields. But the partition key in general is a subset of them. So it's only some of these columns. So in this case, it's only video ID, which means that you might have several rows, different rows with the same video ID, because uniqueness is all three, and they will be grouped in the same partition. So that's just to make it clear. We will come back on this point, but it's very important that you get the distinction. Primary key, the whole thing is for uniqueness. Partition key is how to group rows together in the same partition, and that's only part of the columns of the primary key. If they coincide, then you have one row per partition, by definition, if you want, and that's not a problem in itself. That's a good pattern in Cassandra, just to make it clear. Sorry, that was something I wanted to stress once more, because it's always a bit hard to get in the first step.
Yes, thank you so much. Good. So now let's take a look at a real life example. What happened with one of our colleagues and clients. I can't discover and open a name because, well, we keep secrets of our clients, but it's a real life story. Imagine we work together on a huge international telecommunication company. It's a huge telecommunication company, so we have hardware, data centers all over the world. And to understand how our system works, we have really millions and millions of different sensors reporting their state every few seconds. Every sensor reports its ID, it reports the timestamp, and it reports some value. For example, if it's a temperature sensor in my data center, in server room, it will report its ID, whatever 1, 2, 3, 5, 6, 6, 6, 6, 5. Timestamp, so when this temperature recorded, and value what temperature recorded. Or if it's a door, like security system, and it's a door sensor, it reports any event, what door was opened or closed. And so on and so forth. So there are very many different sensors, and we store very many different information there, right? So every sensor reports its state every few seconds. We have to store this data, and we design a model which is looks like that. Primary key will be sensor ID partition key, reported at clustering key. Why do we do it? First, sensor ID. We follow the first rule, store together what we retrieve together. In the future, I want to see the, let's say, temperature diagram, and I want per sensor, per room, and it makes sense to store this data together for real. And then I store also timestamp, reported at, because I want to understand, I want this data unique. Sensor ID is not unique because the same sensor will report its state like many times per minute. Stefano, I'm very sorry. Could I ask you for...
Sorry.
Yes. Keyboard is very loud.
Yes, sorry.
I'm afraid...
My mic, I have to tune it. Sorry.
No, all good. I'm afraid my noise suppression mechanism works not so well today.
No, this microphone is too powerful, so I'll switch it off for a second.
Good, thank you. So, well then, let's take a look. I have a sensor ID as partition key, reported it as clustering column for sorting and uniqueness. We are all good? Yes or no? Now, everything works well in the beginning, but after some time, I run into troubles and something goes very, very wrong with my cluster. Now, please answer in the YouTube chat what is wrong with this design and what will go wrong and when it will happen. And while I'm waiting for your answers, I will answer a question from Ismail. The quality of secondary indexes determines how efficiently you can access records in the database. How is Cassandra support for secondary indexes? First of all, it's obviously recommended way to work with Cassandra using primary indexes, not secondary indexes. And primary indexes are partition key and clustering column. This way you get best performance right out of the pocket. And Cassandra supports secondary indexes. But the problem is Cassandra's data is decentralized, distributed over multiple servers. And it has exactly the same problem as you would have with any kind of a distributed data. Building a distributed index is a quite hard thing. So there are indexes what base it on supported on a partition level, when you have secondary indexes, but again limited to a single partition. And to have secondary indexes over multiple partitions, you have to build a distributed secondary indexes, which is quite a long story. In short, recommendation is to always go with primary indexes, not secondary indexes, although they are supported. Hey, Tommy Hendravan just gave the right answer. It will create very big partition as the partition key is sensor ID, and that's the right answer. Over time, in the beginning, it will be fine because it groups data by sensor ID, and in the beginning, per sensor, you have 0 rows, 1 row, 2 row, 3 rows, 5 rows, and so on. But over time, it will be grow too large. And as a result, you will have to match data per partition, and your partitions will be too big, and cluster will be stalling, and that's something we want to avoid. How do we avoid that? There are two possible solutions. Well, maybe more, but two main solutions. First one, known as TTL, time to leave optional property. Using time to leave, you can specify a particular value or a whole row to be expired after this TTL expires. And in this case, writing data to your cluster, you can always specify TTL 1 month. This row will be discarded after 1 month automatically, and you don't have to take care about that. Sadly, it wasn't this case because this company wanted to store data for years. So TTL was not the best way to handle that. TTL is a great thing, but in this particular scenario, we wanted to store data for many years. So how do we solve that? There is a special approach, known as bucketing. What is bucketing? Bucketing means, take a look here, we are introducing a compound partition key. So before we were getting sensor ID, timestamp, and value. Now we also store in the table month year. What is a month year? Basically, easiest to explain on an example. That's a September of 2021. So month year will be 092021. And now you can think about the trick. Then this month changes. So when October comes, it will be what? 102021, not 09 September, 9th month of a year, but 10th month of a year, October. And as a result, as a month changes, Month year will be changed, and as this value changed, compound partition key will be changed, and token will be new one. So we basically create now partitions per sensor per month. And when month is over, we create a new partition. As a result, we will have as much partitions, as much sensors multiplied by month years we will have, and that's completely fine again. And that's the idea. You can keep month year as an integer or a string, that doesn't matter. But that's the primary idea of creation of buckets with store data div. Now, many people ask, why don't we use date? Why do we use month year, not a week, not a day, not an hour, not just the timestamp? We have timestamp. Why don't we put this reported at into a partition key? It could have been sensor ID reported at. Answer is very simple. Take a look. When you order food delivery, when you order pizza, do you specify your full address or do you specify only street name, city and street name? I don't know about you, but I prefer my pizza hot. That's why I always specify full address. So when the delivery boy or girl reaches the place, he or she can immediately find me. Makes sense, right? Now take a look. Why I'm talking about that right now? Then you, in your query, select something or insert something. Do not specify partition key. All the components, all the compound partition key. What will happen? How will Cassandra calculate which particular server to ask for your data? Without a full partition key, there is no way to do it. And executing a query without specifying all the parts of a partition key is exactly like ordering a pizza without specifying full address. How is delivery boy is going to deliver this pizza to you if you didn't specify your apartment number or your house number if you live in a house? Basically, there is only one way. Go through the street, knock to every door and ask, "Hey sir, have you ordered pizza?" "Oh, sorry, I will go to next door." "Hey ma'am, have you ordered pizza?" That is as stupid as it sounds. Exactly as stupid as it sounds. What do you want? You don't want your database to work like that. So remember a simple rule. Always specify all the parts of a partition key. If it's a compound partition key, you have to specify all the components of this compound partition key. That means, what if I have to get query data of with sensor ID, I will have to specify a sensor ID. I want to get the data statement, the diagram of the temperature for this particular room over last 3 months. How will my query look like? Select whatever I need, select all from my sensors reports, where sensor ID equals 11223355 and month year is September 2021 or August 2021 or July 2021. So my select statement will be quite simple. But imagine I have bucketing based on an hour. I will have to specify each and every hour for the last 3 months. Can you imagine this query? That is obviously not going to be optimal request. That's why we are bucketing based on the month. You every time doing a design, which Stefano will explain you in the second workshop. That's very important workshop you must attend. So think of the partition size and maximum partition size. It's easy to calculate. You know the size of a single report. You know how many reports you will get per minute. And then that's easy. Calculate approximate size of a partition and make bucket based on some reasonable limitation. Week, month, maybe a day if you have a huge workload per one single writer. So, and then finally, last slide over here, a word. Rules of a good partition. Avoid hot partitions. What is a hot partition? Do you remember the example I gave you with this e-commerce company, which was not so maybe successful in Europe, but became extremely insanely popular in China? Imagine it has a cluster of 10 servers with single data center, just for simplification, and replication factor free. It has as many partitions as countries it operates, and for the dozens of European countries, they are quite small and not so intensively accessed. And there is one single partition which is overloaded, this famous Chinese partition, which is being accessed all the time because there is a huge amount of people and someone is buying something all the time. Well, then you can say, okay, cluster of 10 servers. And they are extremely popular in China. Now they have a lot of money, as everyone is buying something from them, they have a lot of money. So just buy some more servers. You told me before what Cassandra scales linearly. Yes, but take a look. Cassandra linear scalability is a shared responsibility. There is no magic button, but you have to work and you have to think on how do you design this system. Take a look. This company has money and they buy 10 more servers. They add it to a cluster. Now they're a cluster of 20 servers, right? Sounds good, doesn't work. Replication factor is free. Still, there are same servers responsible for the same partitions. When you have many of the partitions and you add more servers, these partitions will be distributed over more servers. As a result, every server will have less partitions, and that's how it scales well. But if you have one huge overloaded partitions, doesn't matter how many servers you add. You can add 10, you can add 100, you can add 1000. It will only lead what other partitions will be removed from these servers responsible for this one, but there still will be only 3 servers overloaded. If your partition is accessed too much, then again it's a bad idea. And it was not perfect design, and now we have to rework it somehow and partition maybe people based on cities or something. We have to think about better design for that. So avoid hot partitions. Try to keep your partitions even by the data size and even by the access patterns. You can tell me what, okay, Alex, in the previous example, when we have a bucketing on the sensor ID and month year, aren't we running into the same problem because there are September partitions what are being accessed all the time, but let's say August partitions are not accessed after August has ended? And the answer is yes, but take a look. In this case, we have one huge partition, and all the others are minor and not under heavy load. And in this case, we have many partitions, many small partitions. In this case, scaling will work because when I add more servers, they will be distributed over those servers. So for this scenario, it's completely fine. But for this, it isn't. Hot partition is not scaled. Good. And you know what? We have 20 minutes left, right? Stefano, you are muted.
Thanks, sorry. We have 15 minutes. We should be able to do a little lab so you can have hands-on experience of Cassandra in the form of a database in the cloud offered as a service. So you will not have to install anything. Now, my plan is, since I collected a few interesting questions, so I think we might do like this to optimize time. We first go and I will show you how you set up your free online database as a service to do later a little exercise on. And while we wait a few minutes for the database to become active for all of you, I wrote down a few questions and I would like to quickly go through them because they are very interesting.
Yeah,
so,
please.
So, okay, now I have to share my screen and...
okay, give me a moment to switch.
Yeah, Yeah, so we might have surprises because, okay, let me set up my, let me set up my screen because I know I might have problem with resolution. So 1 second. Yeah, there we go. I think that's good. Okay, so.
And I'm switching. Are you all ready? I'm switching to your screen, right?
Okay, so I
Good.
should be able to
Yep.
share my screen here. So yeah, there we go. I'm sharing my screen and
yes, your screen is live. And
very good.
before we proceed with that, let me explain you something. Not you, of course, but I mean our attendees. That's everything what we will do now as an exercise. We will do with Apache Cassandra based database, cloud database as a service, AstroDB, which is absolutely Cassandra compatible, which is based on the Cassandra.
I'm sorry, I have to do a bit of tricks with my screen because I want to paste a few links in the chat. So
yeah,
don't mind me, please.
Yeah. And why I'm talking about that? You can do all the exercises locally, and if you want to install Cassandra and run it locally, you are completely good to go. But to simplify that, we will use today a free account on AstroDB, which is Cassandra as a service. And why we want you to do those exercises? All the theory is dead without practice. I want to put your hands on. I want you to do the lab. I want you to follow the steps what Stephanie will show you. And that's very important to you to do that because first, you will learn this better. And second, if you complete the homework and submit the homework, as Stephanie will explain you, you will get a special badge or participation certificate. You can brag on LinkedIn or Facebook. You attended Cassandra Day. You learned fundamentals of one of the most powerful NoSQL databases in the world. You just become a better developer or administrator or engineer, whoever you are. So please follow that. You have to do those steps in order to complete homework and get your badge.
Yeah, those are wise words. Thank you. So let's start. Okay, so welcome to the practice part of today, Introduction to Cassandra presentation. Okay, so you will find in the YouTube chat 3 links. So one is to this screen to register to AstroDB. What is AstroDB? Alex just said that. So you can use this or you can have your own Cassandra installation, no problem. So this is the screen I ask you to register. It's free. You can log in with GitHub, Google, or create your account. So let's say you click sign in and you will be brought to a page like this, more or less. In particular, okay, I tried to make it big enough for you to see. By the way, Alex, I have to share my screen, so I'm not seeing the YouTube chat. So please help me as much as you can. Thank you.
I'm on it.
Okay, great. The other links I pasted is to this repo, Intro to Cassandra. Here you will find all instructions. So if you want to do this later at your own rhythm, just go ahead, read here. There's a lot of explanations, and you will be guided to do this exercise by yourself. The third link is just a link to the part about homework that will explain to you better here, sorry. It will explain better what you have to do to get your badge and to get your knowledge, because there is something to do besides what we will do today. Okay, so let's start. So let's say you have registered to AstroDB. So you're ready to create your own database, which you will do like here. You will end up either because you logged in or because you clicked on this button, create database, or here, create database. You click here and you will be able to create your own very own database in the cloud. By the way, that's in the cloud. That's managed for you. So as opposed to installing Cassandra on your own machines in the cloud by yourself, you will not have to do any administration, any operations, any maintenance. It is just there. It's a managed database. So for exercise, it's good. And I have to say, not only for exercises, also big companies find it convenient not to have to deal too much with maintenance, because that's done for you in the cloud. So I'll also paste these information here, because we ask you to please stick to these names when you create your database. So you will call your database Killer Video Cluster without the E, so like you see in the YouTube chat. And the key space name, please stick to Killer Video. That's obviously just a choice, but it will make the commands we will run easier to run. That's just it. So you will not have to adapt anything. So Killer Video Cluster and Killer Video. To complete creation of the database, you should choose any cloud provider you want. I choose Amazon Web Services, why not? But that's the same for you. And probably you want to choose Asia Pacific, probably maybe it's convenient for you to stick to the region and the geographic area closest to you for latency. So I'm in Italy, so we'll choose Frankfurt and AWS, why not? Okay, so then I click Create Database, and that's it. In a few minutes, you will have your own database ready to play with. You see, this Killer Video Cluster now is listed here in my databases. I have something more, but that's a detail, and you will see it in the pending state for a while. Let's say a few minutes. So we just leave it there, and I ask you to please give me a thumbs up in the chat. Good, nice thumbs up when you get to the database in pending state. So I know you succeeded, and we just wait a few minutes for the database to become active, because while this is pending behind the scenes,
there is quite a lot of work.
Yeah, the Astra engine is spinning up new stuff. It's doing a lot of Kubernetes instantiation of pods, and behind the scenes, your database has been created on different machines in different data center, in a single data center with multiple nodes. So there's something heavy going on, and you just have to wait a bit. So please, when you create the database, please stick to the database name and the key space name. You know now what a key space is. It is just a way to contain a few tables, basically, and a few other things. Then you choose a region, a provider, you click Create Database, and you're done. So
we have the first thumbs up. Alodia, well done.
Great. Alodia, you won. Oh, Yanto, welcome to the world of those who have the database ready or waiting to be ready. Okay, so while we wait, I will just touch on a few questions, then we wait 2 minutes or so, and then we do a bit of exercise. I think we will go 5 minutes beyond the schedule, but there is the break, so I hope that should be fine. Okay, so a few interesting questions. One very quick. Adam asked, what is the license to use Cassandra? Good thing is the license is the Apache license, so you're free to use it because it's open source and it will always be open source. So you can use Cassandra and SQL as a free product because it's open source. Then again, there are commercial solutions such as the DataStax Enterprise, and most important, the one you're just seeing on the screen is a database in the cloud offered for you as a service, and it is built on Apache Cassandra. Now you are using that as a free product, and you will be able to use it for free up to a very high level of I/O and storage. But then above that line, if you are a big business, you will have to switch to a paid plan, but that's absolutely not the case for today and for a foreseeable future for your experimentation. But if you run a big business, you will switch to a paid license, obviously. Another question was about unique ID. So can you have the database create a unique ID for you? Yes, and you will see it soon in the exercise. Another question by Rahul was about distribution of data between data centers and within data centers. So the big distinction is that what you define at key space level is what happens between data centers. So you take a whole key space and you decide, this is going to be on these and these data centers. This other key space is only on these data centers. That's useful because you might have to comply to compliance regulations. So this data, as Alex mentioned, this data has to be on Europe only. But then when it comes to in-table data, row by row, then the distribution among the nodes in the data center is automatic. with the partitioning mechanism. Another interesting question was about time zones. So what happens if you have a database over multiple time zones? Don't you run into problems with different times? Well, internally, you store timestamps, so Unix timestamps, which are non-ambiguous. And the trick is to always specify the time zone when you insert the date, data. So they will be translated in a non-ambiguous way, and there will be no problems with that. We all know that time zones are one of the hardest problems in data handling, but this is luckily not a problem here. Another question was, what happens if I try to insert 2 rows with the same primary key? It just can't happen that you have multiple rows because uniqueness is guaranteed, and actually you will get an overwrite of 1 row to the other. So by design, you will have 1 row in that case. Yeah, then a remark. Alex mentioned pizza a few times, and you will see a lot of pizza mentions in the data modeling talk because I like pizza, so I put a lot of pizza in the talk. There was also a nice question about Cassandra. Can it work as an in-memory database? Well, actually, since it's made to work with big data, it's more like the answer is no. It's mostly based on on-disk storage. Think about what happens if you restart a node. You would lose everything, so no. But on the other hand, Cassandra is a very sophisticated in-memory mechanism it's a caching mechanism, very complicated and very powerful to make reads very fast.
I would say answer is yain. Answer is yes and no simultaneously. Exactly. First, you can. First, Cassandra is normally not used as an in-memory database. Second, using some special configuration, you can try to reach similar idea, but you are obviously going to need to have a lot of RAM space. But that's not it, because there are also works in progress. It's not yet released, but there is a work in progress on pluggable storage engines and pluggable memory engines. And in theory, in the future, we can have in-memory as a pluggable storage.
Yeah.
But
with the care that if you reboot your node, then you might have a problem. So you have to know what you're doing, I would say.
Yep. And George asks, will there be a quiz in the end? A quiz will be there, but as it's Cassandra Day Indonesia, it will be accordingly to the schedule in approximately 1 hour from now.
1 hour.
And second, it will be held in Bahazan.
Yes, so there will be actually 3 different quizzes. We will speak of that later. So I think it's now time to have a bit of a experience with Astra, with Cassandra, the underlying Cassandra. So I hope all of you have your database active now. So let's start. So I have my killer video cluster here. That is the database, and it's active. So I can start clicking on connect. If I click on connect, I'm brought to a page where I can connect to this database in various ways. Today, we will use the CQL console. Look here, there is a tab here called CQL console, which is a very handy way to interact with the database directly with a shell that offers CQL commands. CQL is the language, the native language to communicate with the database. Then again, there are drivers. There are various other ways to access it. But now we are looking at the main, most basic way to interact with the database. So I'm trying to follow the instructions in the README. So I will switch between these 2 tabs. Let me bring this tab here for convenience. So I hope you're all in the CQL console, and it is a console where you just type commands like this one. Commands have to finish with a semicolon. I hope you can see my screen big enough.
Yep.
Then you type your command and you click enter. So what I just wrote is use killer video. That means I'm moving my, let me just move over to follow the steps. Yeah, so I already skipped one, no problem. So use killer video means I will work now on the killer video key space. What are the key spaces? So if I type describe or desk key spaces, I will see how many key spaces are there. And many of them here are system key spaces created for me, but my killer video is here for me to use. And by the way, we have tab completion. So if I type use key and I click tab, I just get my command completed. So I'm now working on the killer video key space. And here we will do a few things. Use killer video. So now we are creating a table. So the next command to run is the one to create a table that you have seen already in Alex's presentation. So create table, if not exist, table name, and then the column making the table, CT text, last name text, and so on. And then look at this command. This statement specifies what is the primary key of the table. And as you see, there is the primary key that is this whole thing. And then this inner parenthesis specifies what is the partition key, all in one command. So let me copy this command here, the one to create the first table, and I paste it here. So right click, paste, and I execute it with enter. So the table exists. Let's see if I do describe tables, I see my users by city table here. Okay. Looks like my screen being so big font messes up a bit the formatting, but I think I have to make it like this. You can see it better. Okay, so we have our table. Very good. Alex, please stop me if there are some problems or if I have to go slower, because again, I'm not seeing anything else than the screen I'm sharing.
All good. Nothing what
Great.
I can transfer by text.
Very good. Very good. Okay, so there is a table in our database. Now, let's create a few more tables. Why not? So there is just another couple of create table commands. We create a table called comments by user, where the primary key is, so this is a table hosting comments about videos. It's a little bit of a sample YouTube-like application, so users are able to comment on videos. I create a table called comments by user, where I store comments, and they are, the primary key is user ID, comment ID, but the partitioning is by user ID. And then I also create a similar table called comments by video. And notice one thing, the table has the same fields, but it is grouped, they are grouped differently. So they are grouped by video ID. That's a very common pattern in Cassandra. So now I copied this command and I'm ready to run them in the console. It's a common pattern, and sometimes the best thing is to have just duplicated data grouped differently in two ways, so I can access them with different queries. We'll see this better in the data modeling workshop, but still. Okay, so let's say I created more tables. So if I run desk tables here, I will see, look, 3 nice tables ready for me. So I think it's now time to insert some data. So I will do a bit of standard CRUD, so create, retrieve, update, and delete. First, let's run a few insertions. So look at this command. This inserts into comments by user, and it inserts. So the syntax is insert into table, then I specify the column names, and then the values itself, the values themselves. Look, I have an ID. There is this nice macro, if you want, that CQL expands to current time, so I don't have to specify it explicitly if I want. So let's run this one command, or maybe, yeah, let's run this one first. I copy it, I paste it, and I think this worked. Look, this worked, and I think I inserted one row already. So let me just run the other insertion. So I insert something else in the comments by user, and comments by user. So I'm inserting a few rows. Paste. Yes, there we go. I inserted a few more rows. Maybe, yeah. So it looks like it's comments by one user, a few comments by the same user, and then another comment on from another user for the same video as before. So, okay, notice that we might use, now here, user ID is explicitly given. That is a good use case. That might happen that user ID is already known. Other times one might use macro like this one, UUID, as you saw the now macro. that is a built-in function, and it generates for me a new unique ID. There are situations where that comes very handy. Okay, so let's insert more tables. Now, we were inserting tables, data in the comments by user. Now we go to the comments by video, which is another table, and we just insert 1, 2, 3, and 4 different rows in this table. So those should be the same insertions mirrored, if you want, by hand in the other table. So we were writing to comments by users, and then we write to comments by video. And there we go. So we did a bunch of insertions. How to check if these insertions worked? Well, let's read the data. So there is this nice select. So let's look what is in comments by user. And there it's, I clean my screen. It's a standard SQL command, select splat from comments by, that was comments by user. So what happens if I run this command? Look, there is my stuff. So I have my results. Finally, I see some data in the SQL console. So I have a comment by user 222, and that's about video 123, blah, blah. Comment by...
Yeah, sorry, I would also notice what there is a nice highlight coloring. If you notice, partition key will be highlighted as red, and clustering column is highlighted as cyan, or what is it? I'm not so good with colors. And data columns are just gray.
Yes, good point. Yes. So this part you see graphically is the primary key, which is made by partition key, which is red, and the rest that is blue, light blue, cyan, whatever. And the data column are just purple, light purple. So you can see at a glance how your table is made. But you can also do describe table comments by user, and you would see in another form the same information with some additional default properties that you might have also modified to your will. So our select. So there are 4 commands. One is by user 2, the other 3 are from user 1, and they are all for the same video. So we are reading data easily. Okay, so there's a very important notice that you will find, and that's a point we insist on very much. That's not a good pattern, because this is, I'm asking Cassandra to give me all rows in my database, all rows in that table. And that's usually, think about how data is distributed across nodes. I'm asking Cassandra, go to all of your nodes and get me all rows of your table. But that's slow. Think about if you have 100, 1,000 nodes, that's a very slow query. That's not the right way to query data. So a good query is the one that hits only on one partition. And that's what I do in this second query. So that's the typical query. Select splat from comments by user where user ID equals something. And let's run this one, which I have to end with a semicolon. Oh, sorry, I think.
When you copy commands from the GitHub repository, you better push this button on the right. Take a look. No, on the right.
No, I know. Yeah, because I skipped a few ones, so it was longer.
Yep.
Yeah, the ID was longer. Sorry.
Yep.
So if I run this select, that's great because I'm hitting on a single partition. Notice that my where condition is not on any random column of the table. It has to be, and it is, on the partition key. So I'm specifying, dear SQL, dear Cassandra, go straight to that one node that has the 111 partition and get me the data. So that is a good way to query the data. Okay, so let's run a few other select. I can look at comments by user. That's what we done already. That's the not so good query, but just as a check. Let's look at the same data in comments by video. So let me clear this. This is comments by user, and this is comments by video. This is a similar way of querying, and those are both not so good queries because they are just full table scans, as they are called, and they would query all nodes that are not so good. Okay, so, but anyway, we have read data. Okay, so let's skip to updating data. Let's say, okay, let's insert a new row. A new row in comments by video. Let's insert this data, select insert into comments by video, blah, blah, blah. And then there is, that guy Patrick is such a geek. Okay, this row has been inserted. I can check by the way, if you scroll up with the arrow, you can go up the history and we can select from comments by video. And our new line, our new row is there. You see it. That guy Patrick is such a geek. Very good. Okay, so we now want to change this comment because, say, the user in the application has edited their comment. How do we go around it? So we update data, update a row that already exists. Now, look at the syntax. Update comments by video, set comment equal new string. And then we have a where clause that has to specify the full primary key. Why? Because otherwise, how can I specify which is the row to be changed? So you see, video ID and comment ID are the primary key here. If I want to change the value of this row, I have to specify the full primary key because uniqueness, because I need to go to one single row and change some of the values. By the way, I only can change values.
Yeah, if you will specify only video ID, it will overwrite a comment for the whole partition.
Which is not what I want.
Yeah.
And yeah, so by the way, I cannot change the value of the primary key because that would amount to creating a new row, right? So I only can change data columns, so non-primary key columns. But see, I run my command, and if I run my select again, I'm pretty sure I will see, you see, there was such a geek here, and now it has become, that guy Patrick is on fleek. So my update worked. Very good. The last step would be to delete something. So again, the statement to delete is delete from table where, and then there is a where condition. Even here, as Alex said, you should be careful because if you specify only the partition key, you are deleting the whole partition, which sometimes is what you want. And if you want to delete the whole partition, you better do it at once because that would create less tombstones. So, well, that's a bit too much today. So it would be the most economic way to erase the whole partition, let's say. So now I want to delete that one comment, and let's run this delete statement. Shall we? Let me paste it here. That's it. So I think my delete succeeded, and to check, I just do my next select on the same table, comments by video. Let's see. Look. No comment anymore. So the comment has been deleted. Okay, that was basically a very small demo just to show you that you can interact in a standard way with the database. Obviously, there is a lot more to learn and to know, but I advise you to do this exercise by yourself if you didn't do it now. Maybe take a screenshot of the last deleted, the last parts, so the row disappearing. If you take a screenshot and then you also go up in the homework part and there are a few interactive scenarios. Let me show them to you very quickly. There are very nice interactive scenarios here that you can start. And again, they are a bit of lessons made interactively with a real Cassandra installation there for you to play with. They are guided. It's very nice. And if you manage to finish them, you learn a lot. You take a screenshot, you submit all of these with this submit form that
a little bit higher. Yep, right.
Submit form, and then we will grade the homework and we will award you a nice badge. So yeah, I think we have to stop here.
Yep.
I can maybe stop sharing my screen if that's okay for you, Alex.
Yes, sure.
So let me remind that now we have a break. So stop sharing. We will have a break now until 13:15.
13:15 Jakarta time, right?
Yes, so in 45 minutes. But during the break, Alex will show you. Yeah, there is now. We finally can give you the link. You can go there, and there will be a quiz sponsored by SPS, if I'm not mistaken. And there will be some OVO prizes for you to win. You will find the link during the break here on the screen, and while we take a break, and you also maybe have something to eat. So great. Thank you for pasting it. So I think that's it. So see you in 45 minutes. Have fun with the break and have a good lunch.
Yeah, and don't miss this quiz. We and our partners, Strategic Partner Solutions. Many thanks to them for supporting us and you on this way. Well, when we dispatch a lot of prizes today together with them, so don't miss your chance to win that. But what matters the most, your knowledge. You know, our prizes are not Ferraris or apartments or villas. What matters more is your knowledge, because your knowledge makes you a better expert and raises your salary in the end. And how to confirm that? First, complete the homework, go to Astra or go to your, and complete the homework as specified in the repository, submit it to get your badge. It's not the end. Badge is good, but we have something better, we have something great. Because you attended this Cassandra Day, you get a free certification voucher. So you can pass a real Cassandra certification and become a globally recognized Apache Cassandra developer or Apache Cassandra administrator for free. Now take a look at the moment after one single workshop. You are not ready to pass the exam, seriously. We have a free resource for you to learn, which is academy.datastax.com. It's a free academy to learn about Cassandra, and there you can choose a developer path or administrator path. Take this path and with voucher pass your exam, and then you can become a certified specialist, absolutely sponsored by DataStax. So you have to invest your time to be a better developer or administrator, but you don't pay a cent for that. And well, you know what? I love my job. So now get your rest and get back for Stefano data modeling workshop, which is extremely important to learn in order to succeed with Cassandra and be better in your work.
Yeah, so I want to take another 30 seconds to say one thing. See you later, but I have to thank you all for being so engaging and asking so many interesting questions. That makes our job valuable, and that's why we like it. And Alex and I, you know, we woke up at 4 in the night for today because we are in Europe, but seeing you so interested and so active with the database, with Cassandra, makes us happy, and yeah, it gives us motivation to do that. So great, thank you guys. See you later.
Thank you, and see you soon.
Oi, halo Alex.
Hi,
So
Dicky.
did you have lunch or breakfast maybe?
Yeah, a little bit. Yeah, a little bit of
Breakfast.
breakfast.
Okay, so we're ready to continue, right?
Yeah,
With the
absolutely.
more exciting events and we are about to giving a quiz to let the people compete about their knowledge. Yeah.
Right, I love this game.
Yeah.
It's my favorite game, educational, entertaining, and engaging. But you know what? During the lunch break, you had a break quiz. So, are there any news about that?
Yeah. I think Andy already mentioned. Oh, congratulations to Biondi Septian and Rudiansah and Tommy Hendrawan. Congratulations, you got prizes from PT SPS for answering the correct answers for our quiz.
Congrats.
Don't worry, it's only one quiz. There will be more after this, right? Okay.
Yeah, we have more prizes. Now it's DataStax turn to dispatch some prizes, but first you have to answer our questions. So, I send the link to the quiz in YouTube chat. Join main team.
Yep.
And there is also, if you prefer a QR code, there is a QR code next to Dicky, or just jump in on menti.com using the code specified on the screen, 8753-5851. And I suggest you to do it with your mobile phone. It's just the easiest way to use Menti. Open it in your mobile phone browser. So, and I see there are many people watching us right now. So I want it to be a real competition. Stay focused, stay tuned. We are going to ask questions and you are going to answer. First two questions are not the quiz. First two questions are just to make you familiar with Menti. And after those two questions, we go for a real competition. So,
Jadi beberapa pertanyaan pertama masih kuesioner ya. Kita coba terbiasakan diri dengan Menti. Setelah itu kita baru masuk kompetisi. Okay, go on.
Good.
Alex.
Yep. I hope you join it. If you didn't jump in yet, because only two small questions, and when we start the quiz. And the first question is going to be, what's your experience with relational databases?
Oh, sabuk hitam, black belt.
Okay.
Oh, we got one black belt, sabuk hitam.
That's great.
Okay.
So most of the people have some experience. But if you don't, that's completely fine. We're happy to see here few students as well, of course, or people who don't have experience with relational databases. Good. So, looks like you are getting yourself familiar with Menti. Then here comes the second question. What's your experience with non-SQL databases?
Oke, berapa banyak yang tingkat dewa di sini? Ini, instead of guru, we use dewa here, means gods in Indonesia.
Okay, and that's pretty much expected. Because obviously people use normally much more relational databases than non-relational, but I hope today we may change it a bit. Relational databases are great, there is nothing wrong to use them. But, you know what, in some particular use cases, NoSQL databases can be much better. Okay, so looks like we have many people join it the quiz already. I give you last few seconds to jump in before we start competition. I paste the link to the YouTube chat again. And I wait for a moment. I need to have one more person there.
Ya, siap-siap. Abis ini pertanyaannya sudah mengarah kepada kompetisi. Ya, kalau tadi kuesioner, sekarang kita masuk kompetisi.
That is better. We send our prizes worldwide. We send our prizes to Africa. We send our prizes to Siberia. we can deliver to Indonesia as well.
Oh ya, nanti hadiah akan dikirimkan dari DataStax dari dimanapun Anda berada, khususnya di Indonesia. Yeah.
Right. Okay. So, let the battle commence then. We are going to ask you questions. Now, you have to give the right answers, but you have to do it also fast, because if you answer faster, you get more points. I hope you are ready.
Okay. Ya, siap-siap ya. Kita masuk kompetisi.
And that's a question number 1. And we start. Answer fast to get more points. Dikin?
Ya, yang cepat yang dapat ya. Oh, Alex.
Yep.
Anyway, that you because the question is cut. Is there any way to size down the font, maybe?
Mm-hmm. You can simply open.
No. Never mind. It's my screen.
Yeah.
Sorry. Yeah.
Okay. So the right answer is Cassandra does not have and does not need any master nodes, because Cassandra is a decentralized system. There are no master nodes in Cassandra. They are missing as a concept.
Ya, itu konsep utama dari Cassandra. Terdesentralisasi, tidak ada master node. Yeah.
Yep.
Okay.
Let's take a look at the leaderboard. Who was the fastest one and who gave the right answer? Looks like, I'm sorry if I pronounce it wrong, Rusdiansah gave the fastest answer, earning 921 points, and that's a great result. But Badi Hertanto is only 5 points behind, which is nearly nothing. It's like 1 millisecond. So Rusdiansah, stay focused. Body is very close. And we are getting to the second question. And that's a question number 2. So answer fast to get more points. Ricky, maybe you can read the questions also.
Oh yeah.
Mm-hmm.
Yeah, using address locator or replication in every server, or using partition, or using postmail. I think postmail.
Yeah, of course,
Postmail.
that's obvious. No one believed us. Right answer is distribution of data done using partitions. We don't use full copy of the data per server, because on the big deployments like Apple or Netflix has, it would lead to just like hundreds petabytes of data per server, which is obviously stupid. So the right answer is using partitions. Now let's take a look at the leaderboard. Who made the mistake? Oh, the top 3 winners made the mistakes that will change the face of the leaderboard, I believe. Yes, and Biondi gets to the first place, Ramdoni on the second.
Oh, we had familiar name here.
Yeah, Ananda, hey, well done. You are on the 5th place. That's a good result, and we are getting... That is great. Only top 3 places getting prizes. But Haidar was the fastest. Let's see what it will give him. We still have a lot of questions. And that's question number 3. So, answer fast to get more points.
Okay, how Cassandra cluster can be scaled horizontally using scaling factor, vertically, or no, there's no way to scale Cassandra. I don't know.
Okay, so most of you gave the right answer. Cassandra scales horizontally by adding more servers. And there is no thing like a scaling factor in Cassandra, only replication, which is different. And Cassandra doesn't scale, well, you can't scale Cassandra vertically, but the recommended way is to scale horizontally. So, well done, most of you. And let's take a look at the leaderboard. Okay, and Beyondy this time makes a mistake. It was the first place, but not for long. Now Theo gets to the first place, Ramdoni keeps the second, and Ferdi on the third.
Theo, new name, congratulations to Theo.
New name, yeah, and Kay was the fastest one, getting on the 8th place. Very well done. So, competition going further. Question number 4. Answer fast to get more points. Okay, so what's the recommended replication factor?
Yeah, it's about numbers. 15, 15, 1.5, 3, or 42. What is your favorite number?
Okay, it was easy. Most of you made it right. Recommended replication factor is 3. You, in theory, can have a replication factor 15, but that's definitely not the recommended one. And I would really like to see replication factor 1.5 in the real life, but cannot imagine how it would happen. Like, only half of a server participate, or a server may answer but not sure in its answer. I don't know. Right answer is 3. Yeah, it was an easy one, right? So, who was the first? And now Theo makes a mistake. What's going on here? That is interesting. So, Ramdoni gets the first place. Well deserved. Congratulations.
Ramdoni.
Right.
Okay. Congratulations, Ramdoni.
And take a look what's happening here. Rusdiansia returns to the top 3 with the fastest answer this time. That's a persistence. And new name on the top 3 is Ferdi. The freaky, very, very, very close to him. Okay. So, question number 5. Answer fast to get more points. Cassandra cluster can be deployed on...
Okay. Only one cloud, only AWS, anywhere, any DC, or AWS S3, your choice.
So, time is up. And this one was again very easy for you. Right.
Yeah. Okay.
Cassandra can be Cassandra can be deployed on any combination. Any combination of cloud providers simultaneously if you want to go multi-cloud. That is a good result. So
that's the key point of the Cassandra. Good.
So all the leaderboard did very well, and Rusdiansa was the fastest, keeping his second place. But Ramdoni gave
more Ramdoni once again.
Right.
Okay.
Ramdoni, Rusdiansa, and Ferdi. That looks good. Okay. And Beyondy is back in top 10, which is a quite good result. We have already 50 people competing. So, ladies and gentlemen, that's going to be question number 6. Answer fast to get more points.
Okay. Is it right or wrong? Only one cluster, one DC. Is it right? Okay.
And the right answer was answer number 4. Cassandra cluster may have multiple data centers. All data centers are active.
Yep.
So, looks like there are 13 people who said what I believe possible multiple data centers, but some of them are read-only. Take a look. Read-only, write-only, that exists only in relational databases world or some of the NoSQL databases world. I don't know, MySQL, Mongo, and so on. In Cassandra world, there is a Every node is ready to answer any query, write query or read query. It's a decentralized, masterless system. That's why I love it.
Yeah. There's no such thing as read only or write only on Cassandra.
And that was a mistake by Rusdiansa. Maybe answer it too fast. Of course, Ferdi uses this chance with his fastest answer to get to the second place. And Ricky is automatically slides up to the third one. And Romdoni stays calm and quiet on the first place.
What a boy.
Let's go on. That's question number 7. Answer fast to get more points. What CAP theorem states? C, A, and P can be simultaneously reached. Only 2 of 3 can be reached. Only availability guaranteed. And the fourth option I don't remember.
Need new chase cap.
Yeah, right. Okay. No.
Okay.
CAP
It's
theorem
not so easy
states.
this time.
Yeah, it was a hard one, of course. A CAP theorem states what in case of emergency, failure, outage, any kind of a network issue or power issue or whatever issue, only 2 out of 3 capabilities are guaranteed or can be achieved, but not 3 of them. Right answer number 2. And you know what? I expect quite some changes on the leaderboard now. There were a lot of mistakes. Okay, Ramdani makes it. Quite slow, but gives the right answer and keeps the first place.
Wow.
And take a look who is on the
Super.
third place. Biondi makes it back to the top 3. That's a competition. That's a real game. I like it. And Buddy Hirtanto, familiar name, is on place number 4, ready to fight for the third place. Well done, everyone. Let's take a look what comes next. We still have some more questions, and that's a question number 8. So, answer fast to get more points. What's the recommended way to reach immediate consistency? Read, write, quorum, quorum. Read, write, one, all. Read, write, one. Using video chat.
Video chat.
Yeah, video chat. I always reach consistency with my colleagues using video chat. There is no reason why Cassandra can do the same. Oh, you see, 2 people trusted us. Okay, so the recommended way to reach immediate consistency is quorum. Using
I'm really amazed with the answers.
using consistency levels 1 all, you can reach immediate consistency indeed, but it's not the recommended way. And read, write, one is not the way you reach immediate consistency, that's for sure. So, let's take a look what's going on the leaderboard. Now, oh no! Buddy and Ramdoni, I'm afraid that was a fatal mistake. Ramdoni gets only to the 3rd place, but that's still enough to fight.
Fairly this time.
Yeah.
Okay.
And Biondi climbs to the 2nd place. That's a good result. And Ferdi now have some quite solid gap on the 1st place, with almost 1,000 points difference to the 2nd place. And Robin was the fastest. Let me see what's going on the next question. That's a question number 9. Answer fast to get more points. What is a key space?
Someone asked about key space in the chat.
Yeah.
Yeah. This is a tricky question, actually.
Yes, of course. I don't want my quizzes to be simple. That should be a real competition. And the right right answer is the 2nd one, and that was a wall wipe. Like 26 mistakes only on the 1st one. So, That's indeed second answer, and now I'm quite afraid of the leaderboard thing. And now Ferdi, Ramdoni, Ricky, and Alodia make the mistake, and Biondi gets to the first place. That's a fighter.
Oh, Biondi.
And take a look, Robin, now the fastest one, like 2 times in a row, already on the 3rd place, and Buddy Hirtanto is again on the 4th one, again ready to fight for the 3rd one. That's quite a result, but Romdoni is still clear, he's still close.
Yeah.
That's going to be question number 10, so answer fast to get more points. What is required in Cassandra tables? Partition keys, clustering columns, data columns. Nothing is required, everything is allowed. And there is a question on YouTube chat, is this video still accessible after the class? Yes, this video will be accessible.
Yeah. Yep. Yes, of course, it will be recorded.
Okay, it was much easier. Partition key is required, clustering columns are optional. So, how it goes on the leaderboard? Who made a mistake this time? Ramdoni, oh, I'm sorry. Looks like he was in a rush to get back to the top 3 and made a mistake. Now Ferdi. Ferdi is well on the top 1st place of the leaderboard, Biondi on the 2nd, Robin on the 3rd, and Buddy is on the 4th, but with the fastest answer, which earns him a lot of points. Let's move on. That's a question number 11. Answer fast to get more points. Cassandra table holds replication factors. Second one I don't remember. Third one was about
only rows and columns.
Yeah,
only rows and columns and many partition. Or I choose the last one.
Right. Oh, that's quite an interesting distribution, and looks like you was too much in a hurry. So take a look. Replication factor is defined per key space, not per table. Then
that's a tricky question.
Yes, that's a tricky question, but that's the most important question, I believe. Yep. Take a look. That's the most common reason of mistakes and failures with Cassandra. Then people treat it as MySQL without joins, as I said already. That means they misunderstood or underestimate importance of partitions. Partitions are held in tables, and then in partitions already you hold rows. That's very, very important to understand. If you don't understand the concept of partitions and what a partition is, a base unit of access, not rows, but partitions, that's the only way to win. So, focus on partitions, ladies and gentlemen, they are matter. And that was quite a wipe. Okay, so Ferdi keeps the 1st place and moreover moves on with the fastest answer. Well done. Biondi is on the 2nd place.
Finally, Ferdi, the fastest and the quick.
Yeah.
Also the correct. Oh.
Yeah. Good. And Robin is on the 3rd place with Agung Vichaksono. I hope I pronounced it right.
Vichaksono, yeah.
Vichaksono. Doing very well. We still have a couple of questions, so you have chances. Question number 12. Answer fast to get more points. How does Cassandra executes joins?
Simply join using SQL. That's my suggest.
It does joins, but somehow lazy.
Oh yeah.
Also nice.
Quite lazy.
Yeah. And that was all wrong because Cassandra does not execute joins at all. That's Cassandra is a NoSQL database, and there are no joins in Cassandra.
That's also the important piece of information of Cassandra.
Yep.
It's no join. Yeah.
I want to say a word about that. So, take a look. Well-deserved points were enough to keep the places in the top 3, but now the difference between top 3 and top 4, top 5 are much less, and Agung Wicaksono made the fastest right answer, getting extremely close to the 3rd place. So now he, or she, I'm not sure, is it a male name? Agung? It's a male name.
Yeah, no.
Yeah.
What do you mean? A real name, I think. Agung Wicaksono, yeah.
Yeah, good. Okay. So that's very close. Now, what matters for us here is let's move on. We are a little bit out of time. I will explain it during the 2nd workshop.
Okay.
What's going to be question 13? This question will define everything. This question makes the leaderboard said and done, and after that, nothing can be changed. Ladies and gentlemen, we proceed to the last question of this quiz, and you know what to do. Answer fast to get more points. If we have a data center with 8 servers, how many servers should we add to double performance of this data center? 4 servers, 8 servers, 12 servers. Nothing can be done. It's impossible to double Cassandra performance within a single data center. Okay. So, most of you gave the right answer. Take a look. That's very important thing. Cassandra highest performance and Cassandra linear scalability is a shared responsibility. It means Cassandra has to do its job well, and it does. But also you have to do your job well. And to learn how to do your job well, you have to go to the next workshop with Stefano Lattini, who will explain you how do you do the data model for Cassandra right. But if your data model done right, then if you want to double performance of the 8 servers cluster, you have to double amount of the servers, so the right answer is 8. 12 servers is too much, and 4 servers, that would be great to double cluster performance, but by half of servers in that. But sadly, it's a little bit too optimistic. Right answer is 8. And we go to leaderboard, and if you will see yourself on top of 3 places, don't forget to make a screenshot of your leaderboard with your place specified. I cannot believe in that. All the top 3 participants made a mistake, bringing Agung Wicaksono to the top place. Unbelievable.
Congratulations to Agung Wicaksono. Okay.
Agung Wicaksono, Perdi and Biondi. Make a screenshot of your screen with you have a screen with your place currently. Agung, Perdi and Biondi.
Ya. Ya. Di capture di HP masing-masing untuk pemenang ya.
Yes, and there is a link. Stefano pasted the email of our community manager, Jack Fryer. Please contact jack.fryer@datastax.com to place your to claim your prize. Don't forget to attach your screenshot. And congratulations, it was a very interesting competition. It was just amazing. That was like a real such a twist. Positions changed so much. That was amazing.
Okay. Stefano, can you paste the link maybe?
It's already there. Yep, jack.fryer. Okay. It's already there. jack.fryer@datastax.com. And now, if you didn't win your prize, we run workshops on this YouTube channel, DataStax Developers, twice per week. So then just join, subscribe to our channel, by the way, and participate in the next workshops and win prizes. But first of all, My congrats to the winners. You did a really great job answering questions and learning something new. My congratulations to all the top 10 on the leaderboard. That was a competition of 50 people. So if you see your name on the leaderboard, that means you are in the very top first 10 out of like 50 people. That's already a great achievement. And what matters the most? If the real winners are those who participated in this Cassandra Day. You now know something new. You can be better in what you are doing. You can get better salary, maybe better job. And that's incredible. Now it's our time to proceed to a very important workshop, right? We go to data modeling.
Yeah, so it's time to leave for me. See you later. Yeah, okay.
See you later, and we will get back in a moment. Hey, welcome again.
Hello again. So it was a great quiz, lots of surprises, and congratulations to anyone and to the winners. Yeah, so we are starting this session right now, Rahul. So, okay, you should see my slides now. And Alex, can I start, I guess?
Yes, I think we can start.
Great. So we are right on time. And yeah, welcome. This is a very important part of today, and it is about data modeling. Subtitle, Building Efficient Applications. Because as you will see, maybe even more important than in relational databases, designing your data model properly is the key to success for your application and for its performance. So let's start. Subtitle, How Not to Shoot Yourself in the Foot with Apache Cassandra. That's not to scare you, but you should take data modeling seriously, because that's the very important basic foundation of a successful application when you have Cassandra as your database, because Cassandra can give you much, but you have to get to know it as you already started. So just a very quick introduction, just to remind you for those that might have tuned in right now. We are communicating on the YouTube chat, and also this video in its entirety of today will be there on YouTube for you to rewatch later, anytime. And you can ask questions in the chat, because it's not only me and Alex, but there are also the SPS friends who are helping, so you can ask them in English or Basque. But remember that the YouTube chat will disappear when this is over today. So you might want to ask your questions to the link that you see here for the later Ask Me Anything session, which is where we will discuss the best questions. And by the way, the best questions will also get a prize, and you can also vote somebody else's question. So if you want to be eligible for the prize, put your name next to the question. I've already seen there are many questions there, many juicy questions waiting to be discussed. The other option, you can join our Discord channel. That is a very thriving community, and it's all about Cassandra and related things, web development, backend development, and so on. And that is where the discussion goes on. So you see here a few links. We are going to paste them now and then today in the chat. So please connect with us. Another point is that this workshop will be about 2 hours, a bit less maybe. And we assume you know something about the fundamentals of Apache Cassandra. That means what Alex just explained before lunch. So you might find it convenient to have a knowledge of what is a database. Maybe some of you know what is, have experience with a relational database. Good, but also careful, because when you approach Cassandra from a relational perspective, you have to unlearn some things, and you will see what I mean. So another last remark, when I say Cassandra here, I mean in a broad sense. So Apache Cassandra, but also DataStax Enterprise, which is a product built on Apache Cassandra, and also AstraDB. AstraDB, you know, because you have been using that this morning to do a bit of exercises, and they are all based on Cassandra. So that being said, let's start. You know me already. I'm Stefano. I work at DataStax, and here are my contacts. You are invited to connect with me and join me anytime. So let's start. What are we going to see today? First, there will be a bit of introduction about Cassandra for those who might be new to it, just to set the stage. Then we will start speaking about the contents itself. That is, we will start with the idea of denormalization, which is a key concept in Cassandra data modeling. Then we will have another look at something that you already seen this morning, namely how Cassandra stores data and groups data in keys and partitions, which will then make us able to look closely at how querying works. And then finally, armed with this knowledge, we will be able to look at how data modeling works. And that's the most important part of this workshop. After that, we will just round your knowledge with a few other important collateral concepts. So, that being said, let's start with introduction. Okay, what is data modeling? Well, broadly speaking, data modeling is that operation that allows you to create your database in the best way to fit your application, to make your application work best. And data modeling starts with just an idea of what your application has to do, and it will end when you create the database physically. You create the tables, and you create the tables with all of the details connected to it. By the way, Alex, anytime there are interesting questions or there is anything, feel free to stop me, because I think we will spare some time throughout this workshop, so
Sure.
we will have time to touch a few questions. Okay, so let me quickly review something that you have seen this morning with about Cassandra. What is Cassandra? Well, it is a high-performance NoSQL database. And as I mentioned, it can give you so much, but you have to learn how to use it. So let's break this sentence down in a few of its aspects. High performance, in particular size. Cassandra is designed to work at the so-called web scale. So it can handle databases of hundreds of petabytes. Can you have an idea how big that is? That is the scale of the web. That is these modern big data applications that is all the rage nowadays. And the nice thing is that Cassandra is able to do that with commodity hardware. So you usually don't have to buy very specialized, supercomputing expensive hardware. You just have to buy a lot of machines, or even better, you just have to get them in the cloud. And speed, also performance in terms of speed. Cassandra is optimized for fast writes, but that's not to say that reads are not fast, but usually writes are the bottleneck for many databases. Cassandra is specifically designed to support a very high write throughput. You can have a throughput of tens of thousands of operations per second per node. And when I say per node, I imply that Cassandra is very distributed. It's made to be distributed. You can have databases made of thousands of nodes, of single machines, servers, virtual servers, Docker containers, whatever. They act as nodes and they share the data, they communicate. And this can also be delocalized. You can have a single database spread over the world. Okay, so it's a NoSQL database. That's very important for us now, because it means that it is not a relational database. It is not based on the key pillars of relations and transactions. There are no joins. That's a very surprising and important concept. There are no joins, there are no foreign keys, and there are, to some great extent, no transactions as you know them in relational databases. You can already imagine that such a different structure compared to relational databases requires a very different way to think of how you structure your data. We will come to this point later. Okay, so you have to learn how to use it. That's because it's rather easy to just jump in Cassandra with a relational mindset and make a very underperforming, very non-optimal data model. That means you are not squeezing the power and the performance that you could from Cassandra. And to use Cassandra best, you have to unlearn, to forget something from your relational background if you come from that. And that also requires you to know a bit of the internals of how Cassandra stores data and accesses data. Alex, is everything all right there?
Yeah, all good.
Okay, so I just go on. Okay, now there is an important point about Cassandra and about databases in general. One usually speaks of two different kinds of workloads that you can have on databases. One is OLTP, at the other end is OLAP, OLAP. So online transaction processing is that kind of approach that requires very many fast queries that just have to work on a single piece of data very fast, almost real time, and they usually are always the same. So you need to change one single piece of data very fast all the time. I don't know, there is maybe some information about a warehouse, a physical warehouse. You have to change the status of an item from available to shipped, and that has to be real time. So that's very simple, many queries, and they have to be real time. On the other end,
OLTP is usually customer-facing side of the application, because your customers don't want to wait, like people so much in a hurry now. If you don't answer immediately, we will just switch to your competitor. So OLTP is something what has to happen all the time, very, 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 very fast.
Yeah, good point. On the other hand, a very different kind of use of databases is OLAP. OLAP is usually, let's say, the kind of complex analytics you can have on a data warehousing platform. Let's say every Friday night, there is a big analysis job that starts. It takes hours to run. It makes a lot of complex joins, comparisons, averages, a lot of data crunching with a lot of CPU, and that can take long. That doesn't have to be necessarily very fast, very real time. Actually, it isn't, because it's usually something that my own analytics department does for me to optimize next week's special offers for my store or whatever. Usually the queries are changing constantly because it's a bit of a working process of experimentation, where queries are complex and so on. So it's not often customer facing. And that's a very different kind of usage. That's the data warehousing side of things. So usually relational databases sort of sit in the middle. So they are a bit good for every kind of workloads. Cassandra, in comparison, sits heavily on the OLTP side. So it's very, let me say, stupid. Actually, it's very complex inside, but it's best at being fast at simple changes in your data, let's say. And when I mean fast, I mean fast. So that's not to say that you can't pair Cassandra with OLAP workloads. Actually, there was a question this morning on that by, maybe I wrote it down. No, I didn't write this down, but somebody asked a very interesting question on that. You can actually pair Cassandra with tools like Spark or Hadoop on top, and you can have best of both worlds. But Cassandra itself is poised to be OLTP database.
Right. I would say that no, all good. I would say it this way: if you are going to build a small house, you may be fine hiring a single person who will do everything: walls, roof, plumbing, electricity, and so on, because it's like simple, tiny house, cabin in the woods. It's maybe fine. But if you are going to build a skyscraper, you are going to hire multiple different persons because it's already much more advanced. That's why when you run a tiny, or well, maybe not so tiny, but when you run a small to medium size project, you may be fine with MySQL or PostgreSQL or something like that. But on the huge projects with service-oriented architecture, with microservices, people tend to use multiple different purpose-built databases. Not general purpose database like relational database, but purpose-built. And they can have, for example, Cassandra working in Apache Cassandra working in team with Apache Spark. Spark for OLAP queries, Cassandra for OLTP queries, working together on the same data.
Yeah, that's sort of, the best of both worlds, right? Like having your cake and eating it too, as they say. By the way, a very practical thing to say is good luck working with queries over hundreds of petabytes. So that's more or less the point, the practical point. So, but we will see then later. Okay, so summarizing, Cassandra is good to deal with big data, very big data. It's highly available. You saw it this morning. It has no single point of failure. It can withstand, if properly configured, it can basically have zero downtime in all conditions. It is able to be geographically distributed, so it meets a lot of nowadays important requirements. And distributed means that you will have to deal with the CAP theorem, so you will have to do your choices. But as you saw this morning, you can pick your choice in a sense. You can tune your consistency requirements. It is very good at reading and writing fast, and which is important, and there was a question on that. It is also vendor independent, so it's open source, protected by the Apache license, so you can just use it. On the other hand, there might be some cons in that, in Cassandra. One is that it is usually important to have qualified engineers. You can't just plug it and use it. It has a reputation for being rather complex to manage because it's heavy machinery. It's heavy artillery today when you have to deal with heavy data. It is, as we said, OLTP specific mostly, and it has limited search capabilities. So it has no native full text search or similar matching word search or stuff like that. But these cons have actually their counterpoints. So it requires qualified engineers, but that might be you tomorrow because, by the way, we offer for free to everyone who attends today, we offer a voucher to take your exam for free and get certified. And when you are certified, you will usually be able to find a better wage in your position. You can make your resume shine. It's complex to manage, yes, maybe, but there are today managed solutions. So you saw this morning a good example of a managed Cassandra in the cloud, managed for you. So the complexity is hidden from you. OLTP, yes, but we just said that you can use Spark, Hadoop, and similar distributed computation tools. As for the limited search capabilities, but you can also plug Lucene-based search engines, Elasticsearch or Solar, and they integrate pretty well. So the cons are not so unsurmountable after all. Okay, so before we jump into the topic, let me quickly summarize the main differences that you will see today as far as data modeling is concerned between standard relational databases and Cassandra. So in a standard database, in a relational database, you use a lot of joins and you use a lot of indices, while Cassandra to this answers with denormalization, and we will soon see what that means. A relational database is based on the idea of referential integrity. On Cassandra, there is no such a thing. It's your responsibility. And that's mostly because referential integrity is a very nice idea in theory, but when it comes to very big quantities of data that have to be distributed, there is no way to make this work fast as we need. In a relational database, the primary key controls uniqueness within the table, while in Cassandra, that's not only that, but there is also the concept of partitioning. So you control how data is partitioned and how data is accessed. You saw that already a bit. Now, how queries work, what kind of queries you can do, and so on. When you model data in a relational database, you start with entities, while in Cassandra, as you will see, it's important that you start from the queries which means the queries you need, which means basically you start from the needs of your one application. Indeed, the standard way of modeling that starts from the data and ends up with the application in Cassandra is inversed. You start with the application, and then you end up building your data, your tables, according to your application. Now, that's all nice and good. And Alex, are there any questions we want to touch?
Nothing what I didn't answer already.
Okay, so let me go on. Denormalization. That's a concept that is very important, as I said, and let's start with normalization. So normalization is a noble and great concept that somehow is the foundation of the relational databases. And it's an idea that is now 51 years old. That was invented by Edgar Codd, basically the founder of relational databases. And the basic idea is that there are a series of constraints that a relational database has to obey, called normal forms, and they are there to ensure data integrity. So no contradictions in your data if you want. The idea is that you never duplicate any piece of information. This idea is a very well formulated and very consistent mathematical concept, if you want. And you see here in the slide an example. So we have a table with recipes, such as pizza. Did I say already that I like pizza very much? So you will see a lot of pizza today. And then there is a table with ingredients, such as mozzarella or champignons. And to express the relation between pizza and its ingredient, you have a third table that just contains, just contains numbers, the code for pizza paired with the code for each ingredient. So you see, the name of pizza and the name of mozzarella is never duplicated, is only there in one single place, and relations are written in a separate table. That's very good in theory, and as you will see, as you probably know, it has a cost. It has a performance cost. So it's a nice idea, but it might have a performance cost. So that is to say, it would not scale so well at the giant web scale of data.
I would say what people normally realize what joins can be slow, especially when you go through multiple joins in a chain, but they don't realize how slow they are and why it's so a big problem. The main thing for you to understand here is what chain of joins can be executed only one by one consequentially, and you cannot run them in parallel. And there is a simple law in the modern applications. If you cannot run it in parallel, it's going to be way too slow, whatever you are doing.
Yeah.
And joins cannot be executed in parallel. Just like there is no way to do it because you cannot do a next join before the previous one is completed.
Yeah, good point. The point is that when you design something in 2021, you have to consider scaling to very big size. And Cassandra is built on this idea, and indeed it is able to scale. And as you will see, as you have seen this morning already, when you access data the right way in Cassandra, you have constant access time. So if you have 10 nodes in your cluster or 10,000 nodes, the time to get your piece of data will be the same. So that's very good. And that's something that relational databases, unfortunately, are not so able to guarantee. So, okay, normalization, we already said what is in the slide. So the idea is that you start with tables that describe items in the world. So a table for ingredients, a table for recipes, and then additional tables that describe relations instead of items. And the advantage is, so you see just a bunch of SQL statements, the good old ways. And then you can decide later what questions to ask. So a good thing of relational databases is that once you have your tables, you can ask basically any kind of question from those tables. So the price is that these kind of queries involve joins. So if you need, in our example, you need to know the ingredients of a pizza, that requires joins. But then that's a good thing. From the same tables, you just can have different kinds of answers. That's good, but yeah, joins are expensive. They don't scale, as we say. So let's see what happens. It happens historically that as databases increased in size, database engineers in relational databases started to think, yeah, joins are good. They work mathematically, but I'm more focused on performance. So let's duplicate the data here and there. Okay, I know that I'm violating the normal forms, but still I want this speed up. So just a bit here and there, I just duplicate the data. And that's a bit of a clandestine thing too. It's a bit of a violation of the model. So it's risky in a relational database. So what Cassandra does it says, okay, let's take this idea of duplicating data to make reading fast, and let's make this idea a first-class citizen in my database. You see this table? This table directly contains recipes and ingredients. So you see there are two different rows with pizza. One is pizza mozzarella and one is pizza champignons. Oh, the horror. Pizza appears twice. And Cassandra says, who cares? It's just fast. As long as I am able, when I write data, to handle this duplication, I win a very important thing. I win fast reads. So basically, you are moving the concept that was the join, you're moving it when you write data instead of when you read. And this has two advantages. One is that usually reading has to be fast because my web application is usually reading mostly. So my customers will see very fast reads and they will not leave me for my competitor. Second point, if your application, when is writing, let's say, makes the join and writes the denormalized data, that can be made parallel easier than the joins. As Alex was saying, you can make them parallel, this kind of denormalization in writing. So the idea of Cassandra is embrace denormalization as a foundational idea and just deal with that. So you can scale up.
Yep. I want to add a point on that. Many people were taught in universities or whatever courses what denormalization is bad. And I claim it's wrong. The point is denormalization is bad when you do not know how to do normalization, how to do denormalization, and when you need what. Then denormalization controls you, that is bad. But when you control denormalization, it's fine as long as you know what you are doing. That's Stefan exactly showing you how to do.
Yeah, that's a very good point. Thanks. So yeah, so the goal is, in Cassandra, the goal is let's design the data so that every query just goes to one single table. And that's it, like the table before, right? Pizza, ingredient, pizza, ingredient. If I want to know the ingredient for a pizza, I just read that one table and I'm done. No joins. There are no joins, so I have to do that. So one table per query is absolutely a law to follow. And that's fast. That's good for distributed systems because there are no joins, so everything can be as fast as I want, even if I scale my size of data. The price is that the application in general has to deal with ensuring integrity. And yeah, you see this drawing. In relational databases, every query speaks with a certain number of tables, while in Cassandra, every query just goes to one single table. Okay, so the idea is that I combine all columns that I need in a single table, such as recipes and ingredients in one table. No joins. I will never tire to repeat no joins today. And queries are simple. So even from a maintenance point of view, queries are not those horrible monsters made of tens of joins that I can never debug or optimize anymore. They are simple, all simple. So the big takeaways are one table per query, which implies I have to first know which are the queries I have to run, and then I create the table. And that's the one line that may be most important of today's talk. And we will see it in detail. And don't forget that redundancy is your friend. So no problem in having duplicated data.
Right. I wanted to add what it can be up to one table per one query. And you can tell me, you can tell us, yes, that's, well, quite a lot of work for developers. And my answer is, as a developer, I do admit I have more work to do with Cassandra, but as I get better paid for that, I'm fine with that, doing more work at the application layer.
Yeah, I like this observation, very practical.
Yep. And there are some mechanisms and approaches to decrease this count. So it can be one table per one query, but normally there are ways what can help you improve this count.
Yeah, but still this would be, let's say, your ideal sense for best performance. So yeah, now pay attention to this. One table per query is something that has to be, because Cassandra doesn't work otherwise. While one query per table is something that usually helps and usually has to be, but you can also have many queries going to the same tables, but probably most of your queries will have each one its own table. But okay. So don't forget that you can have duplicated data. You might, raise an eyebrow for that. Duplicated data, the horror. But don't forget that performance and keeping your customer is very much more precious than storage. So disk is cheap, right? It's commodity disk usually. It's not supercomputing expensive hardware. So disk is not so expensive after all nowadays.
Yep. Disk space is definitely cheaper than your reputation.
Yeah. And in order to be able to apply these ideas, we have to deep dive into how Cassandra stores data in tables. So let's move to how keys and partitions work in dictating how data is stored in Cassandra. Are there any questions?
No, we are good. We are
okay,
answering.
So we can. Great, thank you. So let's go on. Okay, as I said, it's important how you design the table, how you choose your partitioning and your primary keys, because that determines uniqueness in your table. That determines how the rows are grouped and distributed among the nodes. And that also has an effect on which are the queries that you can run. Okay, I say it's not that you can't run other queries, but other queries are so inefficient that you don't even dream of using them in production. So it's the same as you can't run. So today I will just assume you can't run the bad queries. Okay, so never in production. Those I already mentioned the full table scans, which are those queries that go asking to every node in the cluster, and that's a terrible idea in production. So it's just something that I will not even consider for a realistic application. Not only that, but also the design of the table determines what is the needed information to write a row. And this you need to know even if you are just a developer and you're not concerned with engineering your database structure. Okay, so let's start with a familiar concept to relational database, uniqueness. First, as you saw already this morning, a table in Cassandra is superficially a very similar concept to what is in a relational database. So it's rows and columns. Think of it as a spreadsheet. You see this table here on screen. You have some columns, recipe name, date, and so on. And you have rows. Every row is a single review of a recipe made by a particular reviewer on a given date. So you see our application is a sort of a cooking website where reviewers on a given date write their own review of pizza, of cake, and so on. So you see I have recipe name, date, reviewer, then rating, that is a number, the vote, and a comment. Okay. Now, a familiar concept is primary key. The primary key, you saw that this morning, is a set of columns that defines uniqueness of your rows. That means that you can't have two rows with the same primary key values. So you see in this table, which I called reviews by recipe, and the reason will be clear in a second. In this table, let's choose our primary key with the requirement of uniqueness. So if I choose just recipe name as primary key, that clearly does not work because I have many different reviews of pizza. So that's not enough. Maybe recipe name and reviewer might work because I might have different reviewers writing about pizza. Let's think if I just add rating to the primary key, I don't think that makes much sense because I don't want the same reviewer on the same date giving two different ratings to pizza, right? So that would be a quantum thing. So if Anita gives an 8 to pizza on the 1st of January, that's it, that's an 8. I can't have a different row with a 4, let's say, right? So that doesn't make much sense. And what about adding date? That's also good. And ultimately, that depends on what is my application doing. So do I allow Anita to give different rates to pizza on different days, that's my choice. That depends on what my application is doing. So those are both good choices. And now, just for the sake of going forward, I will choose yes, that I can store the whole history of ratings by Anita for pizza. So I add date to the primary key. So recipe name, date, and reviewer will be my primary key today. And as you see, I just marked them in blue just as a reminder. So now this table makes sense because you see, every row has a different set of values for these 3 columns. Alex?
Sorry.
You were about to say something?
No, I'm good.
Okay. So far so good. That is very similar to relational databases. Obviously, once I choose the primary key, if I insert a row, I have to at least give the values of those 3 columns. Otherwise, I'm not writing any precise row. And also, when I update a value, when I update a row, I can't change these. There was a question this morning on that. I can't edit the value of a field, of a column that is part of the primary key, because that would be more like I delete a row and I create a new one. So I can change the rating because Anita wants to edit her rating, but I can't change Anita into something else because it's a different row. So that's the role of the primary key. Now somebody might ask, now we are using pizza, but we might want to use a recipe ID and have a different table with recipe IDs and their name. So yeah, why not? So that's actually something that depends on the exact flow of your application, and it might work in some situations, it might work better. And that's a sort of a trace of relational approach. But actually in this case, the relation between tables, so between IDs here and ID there, would be done by your application, basically. And that might be also good. There's nothing against that. It depends on your application. So every time you design an application, you have to think whether to use natural keys or surrogate keys, as they are called. So you can generate random IDs for every item and use them elsewhere in your tables, but that's really up to the application. So there's a trace of relational, if you want. But today we stick to the natural name pizza as the key. Okay, so far for the primary key. Let's look at partitioning. That's a concept more specific to Cassandra and other tabular NoSQL databases, actually. The partition key is a part of the primary key, maybe all of it, and it tells me which rows will be grouped together in storing. And it also tells me how our rows, this group of rows, how they are distributed, scattered through the nodes making my cluster. This is something that was explained in detail this morning by Alex. And I want to just refresh it because it's very important to have a good working data model. So let's jump into an example. I have my table with reviews for recipes, and I decide that the partitioning is made by recipe name. So the partition key is recipe name. As you can see in this graphic, well, probably you can't see much because there are a lot of tables and it's a mess, right? That's because I'm in production and I set replication factor to 3. So every piece of data is actually on 3 different nodes. So that's too complicated. Now, let me switch to replication factor 1, which makes it for a more readable schema. And obviously, I will not want to do that in production because it's too fragile. But for today slides, that's good. So okay, every one of these orange blobs is a node in my cluster, and they share. Each one has a part of my table. You see, the whole table is spread. As you can see, every partition is identified by the name of the recipe, and all rows for pizza are on one node. All rows for pasta are on a different node, and so on. Now, you see on the bottom, there is a node containing 2 partitions, pie and fish. No problem with that. And usually, any node contains more than 1 partition. The opposite is the problem, but that never happens. So a partition is never split in pieces that are on different nodes. A partition is always all together. And that's very important. So, okay, as we said, each row belongs to a partition, depending on the value of recipe name in this case. Where is this partition? It depends on the hashing algorithm that you saw this morning and decides the node that will host a given partition in its entirety. All the partition is on that one node. Now, if I want my queries to be fast, I probably want that every query just has to go on one single node, so it's very fast. That means that my query will have to work within a single partition. And that's a very important law. If I want my application to be fast, I have to design my tables so that every query the application needs will be going to a single node. That means every query will have to access one only partition. All of it, part of it, no problem, but no more than one partition. And that's a law that I ask you to remember for later. Now, just as an experiment, a thought experiment, if I change partitioning for the same table, so same primary key, the recipe name, reviewer, date, but just a different partitioning, look what happened. The data, the rows, are distributed in a very different way. But again, partitions are all together. So you see, look at this node on the right, salad Aldo. That's a partition now because recipe name and reviewer define the partition, and that's not split. That's all there on that one node. And that is true for all nodes here. So if I choose a different partitioning, the same data will be grouped differently. And then, since I want my queries to access every time a single node, choosing the partitioning enables me some queries and not other. And that's very important. Now you might ask, what is the right choice for a partition? Well, as I just said, it depends on the query. Look at these two examples, the two examples that we just saw. They group data differently, the same data. Now, the choice on the left is able to give me all reviews for pizza at once. So if my application needs that, I need such a table. While the choice on the right is able to give me all reviews on a given recipe by a given reviewer. If I need only that from my application, that's maybe a best choice. And there are compromises to be done. So if I might want to go for the left choice, but maybe there my partitions are going to become too big. And this is a point we touched this morning. Okay. So all good so far, Alex?
Yep, very good.
Okay, great. So let's go on. Because I think many of you now have a question, but I might need to do all kind of queries on the same data. Yeah, probably. So look at this example. I want all reviews of pizza, but I also want to see all reviews by a given reviewer for all recipes. Yes, the answer is create two tables. What's the matter? Again, disk space is cheaper than performance. So yes, I can create two tables and basically keep them aligned in my own application. So yeah, I must take care of doing two insertions per every piece of data. Yes, so that's what I meant when I said it's not only one table per query, but maybe sometimes one query per table. So I need to access the same data in two different ways. Probably I might have to do two different tables. No problem. So that's something that is strange to relational approaches, but that's exactly the Cassandra way. So keep that in mind. And let's go on. Okay, so all good so far. I just want to draw your attention to some typical problems that we mentioned this morning already. Let's say at some point, so everybody knows that pizza is good, and maybe soup. I don't like soup as I like pizza, honestly. So I can imagine my reviewers to constantly write reviews about pizza, and maybe not much of soup. So that is not a good So if I have pizza, if I have recipe name as a partition key, in this case, I end up with a partition being very small and never written, and the other one, the one for pizza, being very big and constantly written all the time. That means that I'm not using my nodes very well, because many nodes are just sitting there idle, and one single node has to deal with the pizza partition all the time. So I'm actually having a bottleneck, and that's the hot partition problem. So to heal this problem, usually one has to rethink partitioning and maybe also invent some different techniques to handle the data in their application, to handle the flow of the application differently. Another problem, and you saw it this morning with the IoT sensor example, real life example, by the way, I might have partitioning that works, but then time goes by and these partitions start to pile up, to accumulate rows and rows and rows. And at the end, they are too big. And there the solution might be bucketing, for example. So you can invent a synthetic new column built from a column that I already had, just to slice a partition so that it doesn't become too big. Let's say there is this year month string that I invent from the date, just to group every month in a single partition so that they are not becoming indefinitely big, and I seal them when a month is over and I move to the next partition. Then probably in my application, I probably can imagine that I never have to look at all the history at once. So that might probably work. That's a typical solution, and it's the bucketing solution. You saw that this morning already, so I'll just skip ahead. Okay, so partitioning, I hope you are now convinced that it's very important. So it is something that you have to know for a good data model. So the points are, every query should always be able to go to a single partition for performance. That means the mantra is stored together what you retrieve together. Another point is be careful, because partitions cannot be too big, again, for performance. So there are some some soft limits to avoid performance penalties, as you see them on the right. So it's not good to have giant partitions, but don't worry, because it's absolutely not a problem to have very small partitions. Indeed, you can also have partitions made each by a single row. That's absolutely fine. And can you guess when this happens? Well, this happens whenever your primary key is the partition key. The whole primary key is used for partitioning. That, by definition, means that every partition is one single row. And then you have to take care that your load on the partitions must be as evenly distributed as you can, so you can exploit your nodes the best way. Otherwise, you have hotspots and idle nodes that you are not using, so that's not so good. Okay, I just mentioned the possibility of having one row per partition, but that's not necessary. You can actually have more than one row within a partition. That happens when the primary key is not completely the partition key. So you have additional columns. These additional columns we call clustering columns. And those are, in the example, you see those are the one in blue, and they are date and reviewer, because recipe name, we use it for partitioning to group together data. But then within a given partition, let's say within the pizza partition, I have different dates and different reviewers. So how is data sorted within the partition? Well, they are kept always sorted by Cassandra, both on disk and in memory, according to these columns. By the way, yeah, maybe the example is the best way to explain that. I have many different reviews on pizza, and since the order is recipe name, date, and reviewer, they will, inside the pizza partition, they will be sorted by date. And as you can see in the salad case, if the date is the same, they will be sorted by reviewer. By the way, you can also choose whether it's ascending or descending. But knowing the clustering and having control over the clustering is very important, because do you remember when I said that your query has to go to a single partition, but it can also, no problem if it gets more than one row, as long as it's within the partition? Well, yes, your query can get more than one row, but for efficiency, Cassandra lets you only get contiguous chunks of the partition. So let's say Cassandra is able to scroll through the partition, but it always scrolls through the data within the partition in that particular order that you define here. And this is an ordering that you define when you design the table, and then you can't change it on that table. It's just like it is. And this have implications on the queries. So you should keep that in mind when you design your clustering. Yeah, indeed. How to choose clustering? Look at your queries, because Cassandra scrolls through within the partition in the order defined by the clustering. So look at these two examples. Those are very slightly different choices for the table. Both have the same partition by recipe, but then the clustering is date reviewer in one case, and in the other case, it's reviewer and date. So you see here, there are two different queries. The typical query might be, I need all pizza reviews from that date or from that date onward. You now know how the data is sorted within the partition, so you can easily see that this kind of query is answered by the table on the left, because then date is the first clustering column, is the most important one. While if I need reviews of pizza from Carl, any date, I need the choice on the right, because then reviewer is the first clustering column. Remember what is in the partition and how it is what is the order within them. So, and that defines the query you can have. Now, there are also queries that you can run, other queries that you can run on the same tables. There are queries that you can run on both tables, because you might want just all pizza reviews and that's it. So you get the whole partition in both cases, but usually the precise queries will tell you how to choose partitioning and clustering. That's very important. Okay, so I hope this concept is now clear. We will see it popping up again. But in the meantime, I want just to show you some SQL code. You saw that this morning. You also probably ran it yourself in our small hands-on session. This is how you create the table in SQL. Now, the table will have, so this statement, create table, is very similar to SQL, by the way. Look, so create table, name, and then there is a bunch of field or column with the type, column type, column type. Then look at this primary key statement here. Primary key contains all the three fields that we decided are in the primary key, recipe name, date, and reviewer. And you see this additional parenthesis, the reddish part here. That's how you specified what is the partition part of the primary key. And that's the syntax. After that, you usually want to specify the sorting order, whether ascending or descending, of the clustering columns, if there are any. So basically, this is the command you ran this morning. I just wanted to show you. So let's summarize quickly the relation between the various keys, because that might be a lot at once. So the whole primary key is what defines uniqueness of rows. That's, say, a conceptual thing. The rest of the table is data columns. Within the primary key, in general, you have a subset of columns that is the partitioning. And that is defining the physical way data is grouped over the nodes. And there has to be partitioning. You can't have tables without partitioning. And yeah, every partition is only on one single node, or better, a partition is never split across nodes. Your query will have to go to a single partition to be efficient, so it's important to make the right choice. If there are additional columns in the primary key, those are clustering columns, and they define the ordering within the partition. So whether date come before reviewer or the opposite, is also important because that determines how the data is sorted within the partition, which in turn tells me what queries I can do. We will see it better later. Okay, so much for partitioning and keys. And this is one of the most important parts. So I'm very happy that we managed to go in much detail on this. And I want to ask Alex if some interesting questions came out. We might want to.
Well, many thanks to you, but in general, all the other questions are answered.
Very good.
Yep.
Very good. So we are perfectly on schedule. So there will be time to play a little maybe at the end. Okay, so next section is writing, or better, querying. So read and write. But I will start with writing because it's easier. A very important point that I want to make clear at the beginning is Cassandra wants to be fast, especially wants to be able to write fast. That means that when I say write, I just mean write. So you didn't see much of how the write path works in detail within Cassandra. But the main point is that in order to be as fast as possible, Cassandra does never look, well, never. Usually in the general usage, Cassandra does not look at the table before writing anything. What I mean by that? I mean that insert and update are the same operation because you just write. Usually Cassandra does not check the table before allowing you to write. So indeed, insert and update are basically the same operation, and we usually call that upsert. Now, there is a very tiny corner of difference that is related to counters, but we are good to ignore that today. So let's say insert and updates are the same. That's important because it's important also because the database will never tell you, oh, wait, this row exists already. Be careful when you write. No, you have to just write. And that's important because there is a pattern in relational databases that is, I don't want to overwrite data, so I try to write with an insert, and the relational database will usually complain. So I catch this error in my application and I do this and that accordingly. Well, be careful because that does not work in Cassandra. That's for the sake of speed. So if you just write a row and then write a new row with the same primary key, you are silently overwriting it. Now, there are ways to control these, and you will quickly see them at the end, but those are not meant to be the main basis your whole data model is based on, because then you kill performance. Okay. So, well, the syntax for inserting data is very simple. By the way, you ran some commands this morning, and it's just very similar to SQL. Insert into table, then you list the column names, and they usually have to contain the whole primary key, at least the partition key, values, and you provide the same list of values matching the name of the columns, and that's it. So this statement you see here, this SQL statement, will insert one of the reviews made by Carl on pizza on that particular day, and with a rating and a comment. Very good. So Carl likes pizza, apparently. Very good. I do too. Did I say that already?
You know what, Stefano? If you did this data modeling workshop based on pizza, what I would do, like, should I build one based on vodka?
Yeah, why not? We might make a beverage section of this sample application. Okay. So I by the way, I also mentioned Spätzle later in the talk. So since you are based in Germany, well, Spätzle are Schwäbisch, but still they are very popular in the whole of Germany.
Right.
So I like them a lot, but not like pizza, I have to say. So, okay. So let's move on to the most important part, that is reading data. Most important because not only you usually read, your reading is customer facing more often than writing in most applications, but also because it involves some more subtleties. And let's see what that means. So by the way, don't be fooled by how similar SQL, the Cassandra query language, how similar it is to SQL, because this superficial similarity, it's a gift and a curse. So it also hides a bit of the underlying differences in architecture. But yeah, back to the point. These, you see here a little piece of SQL code that reads data. So select columns from table where conditions. That's very simple. By the way, also a similar command we ran this morning. And this is the typical result I would get. So a bunch of results. Each one is, let's say, Zui gave a rating 2 of pizza. Carl gave a 9, and so on. But there's a difference with relational databases in SQL because there are a lot more constraints when you read. I mean, I guess now you can imagine them, but let's look at them in detail. Because you must query a single partition, and the reads within the partition will follow the same sequence as the data, the rows are stored. So there are some constraints. Let's look at them. The where clause is the most important because the where clause must specify at least the partition key with equal signs. So you should have field equal value for the whole partition key, not necessarily the primary key, but the partition key, yes. That's because you have to tell the reading to go to a single node, to access a single partition. Then, within the partition, you can, but you're not necessarily, but you can specify some or all of the clustering columns. But again, if you specify them, you have to specify all of them to a point. So you can't just skip the first clustering column and go to the second. Try to imagine why. Well, the reason is that you would have a leapfrog way of reading your data within the partition. So you would not have anymore a contiguous scanning of the partition. And that's not good for Cassandra. And for the same reason, you can have inequalities. So you can have range queries. So date greater than something, but only on the last clustering column you're specifying for the same reason, because otherwise you would have a skipping thing. You would have a leapfrog access within the partition, and that's not performing. Last thing, the where clause should not and cannot involve columns that are not in the primary key, not at all. That sounds like a very harsh specification, but remember, you can duplicate your data. You can create more tables. So this is somehow the other side of the flip side of that coin.
Secondary indexes can help you improve the third point, but they have their own limitations.
Yeah, so I will briefly mention them at the end, but yeah, they are a very helpful tool and they are indeed powerful. But besides, it's not so easy to learn how to use them properly. It's very easy to misuse them. And most important, again, if your data model is completely built on using secondary indices, that's probably a sign that you can invent a better data model.
There is a question by Rahul Bhoyak. Can you explain by use where secondary indexes? The idea of secondary indexes here is very simple. Normally, you can query your data and search your data only then you specify any parts of a primary key. So you must specify partition key, and you can query data by any of the clustering columns, left to right. But if you will try to query for data column, which is not part of a primary key, Cassandra won't do that, will throw an exception like that's not allowed. You can do it. If you build on that secondary indexes, you can query also by data column, so it will work. But you have to be careful on that because, as said, secondary indexes have their own limitations.
Yeah, Rahul, stay tuned because by the end of this presentation, I'll have a slide with an example, and we will just maybe mention the reason for this limitation. So again, since it should not be the foundation of your data model. So we put it at the end of the presentation just as a additional thing you better know. And yeah, you will see an example, but then you can find a lot more information on secondary indices in the documentation. So let's just mention that later, shall we? So, okay. By the way, probably those of you who used Cassandra already might encounter this questioned, how do you say, opinionated statement, allow filtering, that you can add to a query. I will, for those of you who know this statement, I will basically pretend this does not exist because we are in production and we don't want to use this statement. What does allow filtering do? It opens the way to
bad things.
Sorry.
But what does allow filtering do? Bad things, very bad things.
Yes, very bad things happen. So allow filtering is a way to open the way to queries that are very inefficient, because it's a way to say, okay, I'm okay, dear cluster, I am okay with speaking with all of the nodes at once and getting my data in a bad way. So it's something that you might want to do if you have a very small amount of data, if you're testing, if you're developing as a test, but if this is used in production, bad things happen. So I will, okay, there are exceptions, but they are pretty advanced use cases. So I will just pretend it doesn't exist if it's okay for you.
I want just to add one more thing. Speaking seriously, speaking for real, allow filtering can be harmful. Allow filtering can be dangerous. What does that mean? If you are a developer, do not use allow filtering. If you see your colleague using allow filtering, stop him or her. And if you
harms you and those neighbor to you, those next to you.
Yeah. The point is, that's quite a typical use case when some junior developer just joined your team, has no idea about Cassandra, but already has to work with it. What do you do?
Let's add allow filtering to all queries. It works.
Yeah. I mean, I build the query, query doesn't work. I go Google that. Google says use allow filtering. I put allow filtering, query works. Yay, now I put allow filtering to all of my queries. And if
then your cluster sucks.
Yeah, then your cluster sucks. Then your clients are unhappy. Just why? Because before letting your junior work with a production code, you didn't send him the record of his workshop.
Yes, and maybe he didn't get the certification, which is for free.
Yeah,
and all the courses are for free, and they are very valuable.
Yep. But my point. Yep.
The real point is.
And my real point is, if you are a team leader, if you are an architect, if you're someone somehow responsible for code and code quality, if you have continuous integration and code quality checks, I do recommend you to add checks for allow filtering in your code, because it indeed can be harmful, very high for the production cluster. So you have to catch it before it reaches your production.
Remember when we said Cassandra is very powerful, but you have to know how to use it. Yeah, if you start slapping allow filtering in your production code, you might really divide by 10 the efficiency and the performance of your cluster easily, because you keep the cluster all the time very, very strained, and it will have trouble of all kinds. The best thing is that it just works slow, and even worse can happen.
Yeah.
But I think we scared our audience enough. Ooh, allow filtering. Let's move on.
Right.
Okay, so let's summarize about where clauses. So where clauses must specify the partition key. They have to deal carefully with clustering columns, and they can't involve other columns. So here, look on the upper right, I summarized the structure of my table. Recipe name is partition key, and date reviewer are clustering columns. So these are all permitted where clauses. So recipe name equal pizza, perfect, the whole partition, no problem. Recipe name equal pizza and date equal something. Okay, block within the partition, contiguous block, because of how the sorting is arranged. Recipe name equal pizza and date greater than something is also good. It's a continuous block within a single partition. Recipe name equals salad and date equals something and reviewer greater than Bob is also good. think of how the structure within the partition is defined, the ordering. That's good. That's a contiguous block. Recipe name equals salad, date greater than something, and date lesser than something is also good. It's a completely well-formed range query within the partition, no problem. So these are all good. Counter examples, and I make them in red, as in danger, because they will not work. Let's say rating equal 9. Come on, rating is not even in the partition key, it's not even in the primary key, it just don't work. Recipe name equal pizza, and rating equal 9. No, not even if I specify the partition. Even there, I can't just go for the value of the rating column. Recipe name greater than pizza? No, because that's partition. So if I say greater than pizza, I'm still trying to get a lot of partitions. Let's say I'm getting apricot or cake, but maybe not tzatziki. Anyway, it's many partitions because it's alphabetic order. So no. Recipe name equals salad, that would be good. And reviewer equal Carl. I skipped the date. So again, that would be a leapfrog way of accessing a single partition, but still no good. And the last example also doesn't work because recipe name equals salad and date lesser than something. That would be good, but and reviewer equal Carl, again, same thing as before, leapfrog access, no good. So these are all bad queries. Okay. Now, just to complete this topic, this is the full syntax, the official syntax of the select statement. And this is not even looking so different than SQL. But just be aware that many of the parts of this statement are heavily constrained, as we just saw. Yeah, so that's more or less just it. And I think we are closing this very important section. So I will repeat that once more. Writing. You have to provide the primary key if you want to write a single row. And don't forget that inserting and updating are just absurd. So you will silently overwrite a previously existing row, if there is any. There are exceptions, we will see them later. And as for reading, there are heavy constraints. That's the price to pay to have the table structure that allows you to scale and to be fast and to deal with giant amount of data. So you have to specify the whole partition, one single partition, so the whole partition key with equal signs. When it comes to clustering columns, if you are specifying them, you have to think of how the ordering within the partition works, and you have to go for contiguous chunks of data there. And you just can't mention any other column in the where part of your select. I think what you just saw should have convinced you that you start from the query and then you design the table, because yeah, there are very heavy constraints, but that's life. That's the price to pay to be able to scale. And once you know that, as Alex was saying, it is, if you are controlling the data model, then it's all good. If you're controlling denormalization, it's all good. You just have to be aware of the compromises here at play and keep control on your side. Okay, Alex, I guess you have been dealing with some questions. So
yep, we are good.
Is there something that might be of interest to anybody?
No. If there would be any, I would tell you.
Great. Okay, so let's go ahead. And this is the titular topic. Sorry, yeah, go ahead.
Before we go ahead, I want to say thank you to all of the attendees who are still with us, because that's already many hours after the event begins and you are still with us. You just best of the best. Thank you.
Yeah, thank you, because you're a very valuable colleague and support and friend and mate in this day. That's going to be, yeah, thank you guys. Especially, by the way, because we don't speak Bazan, so you are a valuable help in that as well.
Yeah.
Maybe you have seen me writing some Bazan in the chat. That's thanks to Google Translate, so I don't speak a word, fortunately. So yeah. So okay, let's start with the titular part of this talk. and data modeling itself. So all of this was very important tools to be able to address this point. How do you practically design your tables? How do you start your data modeling with Cassandra? As we anticipated, you start with the application and its requirement, then you model the data, and then you build the actual tables. And this is summarized by this flow chart. So let me say that data modeling is both a science and an art, because, yeah, it's a science because it's been formalized very tightly in a precise methodology. But that's not the end of it, because it's not just that you follow the rules, because you have also to think and to make some choices. At the end, you have to think and make some choices, let's say, from your heart. And there is also some creativity involved. So we will see it later in the last stage. So basically, we start with understanding the data involved in my application. And this is ER diagram, which is probably familiar to all of you relational data engineers. At the same time, it's very important, and it's one of the most important parts. You look at your application from the start. So simultaneously with understanding the data, you look at your application, you look at the workflow of your application. And these two, by the way, this is the part where you mostly speak with non-technical people. So product designers, users, salespeople, anybody, because you have to understand what your application is going to do, even in a non-technical way, because then it's up to you to merge these two information and map them to queries, basically, so to a set of queries. And then you will start from the queries and you will write down the logical data model. So every query will require a table. So you can now start designing your table, at least in an abstract way, what is called the logical data model. From the logical data model, you then derive the physical data model, that is the final structure of your tables. Basically, it's a set of create table statements, if you want. And this step will involve some optimization and some practical choices. Okay, so let's start with the conceptual data model. That's the typical entity relation diagram. And you speak around, you also speak with non-technical people, as I said, and you end up with a mapping of the entities that play a role in your application and the relations between them. And each one of those entities or relation will have some attributes, right? So you have recipes, in this example, you have reviewers, and they are related by the relation that a recipe has reviews by some reviewer. And both entities and relations have their own attributes. So a review might have a date, a rating, a comment. A reviewer might have an URL of their website, a picture of their face. A recipe might have a name, might have a preparation time, a category, I don't know, sweet or first dishes, and so on. Okay, that's very similar to relational starting point, but then things change because the other step to be done together with this, oh yeah, by the way, sorry, I forgot. This is also the step where you start thinking whether you should use, you remember, whether you should use natural keys or surrogate keys to relate things. So shall I have recipe ID or just the name pizza as a attribute? These are similar questions might start already here. Simultaneously, you should already have a good idea of the workflow of your application. So let's see, I'm thinking of an application where user goes to my website and they want to search for pizza, and once they click pizza, they want to see all reviews for pizza, let's say the most recent first. Well, then I probably want a table. So there is a query that here I write as select all reviews for a recipe name, sorted recent first. Let's say this will be answered by a table reviews by recipe. Then I can imagine my web application and there are recipes, and one recipe is by Anita. So a user might want to click on view all recipes by Anita. And that's, you see, there is a proper workflow between queries. Now there is a second query, select all reviews by Anita, sorted recent first. of all recipes. So for pizza, for soup, for everything. And that's probably, as you saw so far, I think you know that now, is going to be answered by a different table. At least it's a different query and it's going to be a different table. We call this table reviews by reviewer because that's going to be partitioned differently because of my query, right? Another way, another kind of interaction of the user with my website would be they want to look at the profile for Anita or for Carl with the profile picture, the website, I don't know, the appearances in cooking shows, etc. So there might be a third query, select a reviewer by name. And that's probably going to be answered by yet another new table, which we call reviewers. So that's a simple example. And let's go on, because now I know which are the entities mapped in this relation diagram, and I know my queries and my workflow. So here are my queries. And that's a good point to map my queries to actual SQL statements. So let's look at my first query. Select all reviews for a recipe name sorted recent first. And then I make it into a proper SQL statement. Look at this. Select reviewer rating comment from reviews by recipe. So far, so good. And this is now important because it's the where condition, where recipe name equal pizza, because I want reviews for a recipe, and date greater than this. So why do I add this? Well, because probably I don't want to show a review that is too old. So that's probably the good way to go. And anyway, I'm going to sort them by date. So that's, you will see. Now you know how clustering works. So this requirement in the where clause basically is the same as saying I want the recipes to be sorted by date. And yeah, let's concentrate on this first query because that will lead us to designing the table. And this is the step of the logical data model. So I look at my query and I start drawing what is called Chebotko diagram. And that is a notation to easily express my table in a Cassandra data model. You see how it works. I have a series of rows. Each one is a column. Each one will be a column in my table. And with symbols such as K and C, I'm noting down what is the partition key and what are, if there are any, what are the clustering columns and the other data columns. So how does it work? Well, I look at what are the entities and relationships attribute that I need from this query. So reviewer, rating, and comment, I need them. But then I look at the equality conditions. So recipe name equal pizza tells me what is basically the partition key. Then I look at inequality conditions. So there is an inequality on date in the where clause that tells me that date is going to be a clustering column. So I'm really building out of an algorithm, I'm building my table. Then I look at ordering. So I need date to be decreasing. That's easier. That's the easiest choice. And that's not the end of it, because I also have to take care of unicity. So even though reviewers has not yet been considered for clustering, I need that to be part of the primary key. So I also add reviewer to the clustering columns, just out of unicity. Once this is done, I have my draft for a table, and that table will work with my query. There is still something to be done, namely, I have to finalize and to go to the physical data model. This is a good point to start thinking about the problems we already mentioned, hot partitions, large partitions. I estimate what size will the partition be, whether there will be data imbalance, workload imbalance, stuff like that. And it's also a good point to start thinking of the data types, because Cassandra has several data types. So I can decide that date is going to be, guess what, a date. Reviewer is going to be a text. Rating is an integer, and so on. There are also some other choices here to be done, because I might choose several ways to handle denormalization, such as user-defined types, static columns, something that I just mentioned passing by. So collection types and so on. So there are various ways to handle denormalization and one-to-many relationships in Cassandra. And for that, I have a small intermezzo about data types. So very quickly. These are the main data types that are available in Cassandra. You see there are some types that you probably know, such as text, integer, float, boolean, binary blob, stuff like that. Then integer or float have different sub-types, so to speak. There are various precisions. There are types dealing with dates, time, unique timestamps, so timestamps in the Unix sense, and also unique IDs encoding also timestamps, unique IDs to occur. There is also something called counter that is a sort of a special thing, and yeah, it is useful. It also has its own limitations, so we will not touch it more than this today. But the nice thing is that you also can have collection types. So you see that the usual collection data types, you can have list of stuff, so list of dates. You can have set of texts. You can have a map between text and integers. And you can also have tuples and as data types for a column. So you can have mentions in social, mentions, many, as a single column for a reviewer, if you want. So you can have a single column that is a set of numbers, whatever. That's not the end of it. You can also have user-defined types. So you can create a type called reviewer with named subfields, such as here, ID, name, photo URL, and score. And then you can have a column called type reviewer. So you see there are various ways to encode relations if you want to denormalize in creative ways in Cassandra. Okay, back to us. This was just to show you that there is a lot of choice to be done when completing the data model and making the table physical data model. In this case, we just do a small optimization. We think, oh, wait, rating is not going to be any number. It's just 0 to 10. So instead of integer rating, we make it a small int, which takes a little less bytes. Why not? So the diagram you see on the right is the final physical Chebotko diagram. It has all information needed to create a table. Indeed, we now have a create table full-fledged statement. And this is the final statement that creates the table. And yeah, that's the end of it. So our journey into data model has finished. We have our data model. We just have to write the application. We know which queries to use, and we are good to go. Yeah, that's been quite a journey. Huh? Let's see. If I have to summarize data model in a single slide, that would be the slide. Indeed, that is the slide. So you start with your application needs, and you end up with creating physical tables. And the process is summarized from the queries to creating the tables. I hope I convinced you that there is a process that is mostly an algorithm with some input from your creativity and experience. So the partition key will come from which are the rows that I have to get at once. The clustering columns, again, I will repeat it endlessly, depends on how, so they dictate how are the rows arranged within the partition. And then clustering columns and maybe other columns will be the data I have to get back from my queries. Then I add some performance considerations to jump to the physical data model, some optimization, some calculations on the projected partition size, and so on. And that's it. And my final advice, which is a very important thing, is please spend enough time on data modeling because it's time well spent.
Yep.
If you start your application after thinking carefully about your data model, you will not have to migrate it painfully afterwards, which might be a bit of a pain because let's say your application is running, you have customers, you serve customers, and you notice that your data model is not so perfect after all. Now you might have to do a migration. Maybe you can't afford the downtime, so that's going to be a rough month or more.
Yep.
So I would sincerely try to avoid that. That's very important.
I want to clarify a bit on that. I mean, why? Take a look. In Cassandra, Partition keys define how data is distributed over a cluster, and clustering key defines how data is stored on a node. And basically, you are not allowed to change any part of a primary key because, there is a thing in SQL called alter table.
Yeah.
When you want to change something in a table. Alter table exists in Cassandra and exists in Cassandra query language, but it's extremely limited. And basically, you cannot touch anything what relates to primary key, any parts of it. Because you want to change a partition key, it will bring the recalculation of all the tokens and reshuffling of all the data of a cluster, which is
Let's say petabytes.
which is obviously no-go because all your cluster will be busy moving data instead of answering your customers' queries. So that makes no sense. And changing any part of a clustering key will lead to rewriting all data on the disks.
All partitions.
So that's again a complete no-go because all your cluster will be busy rewriting data on the disk instead of answering queries. As a result, basically, as model once created, its primary key cannot be changed. And it's quite easy to design a proper data model when you are migrating from a relational database for an existing application to Cassandra. Why? Because you already know your queries. You just go and watch your queries on your existing application with relational database, and you write them in form of SQL, and you know which tables you have to create. Then you design something from scratch. That's a very different story. That's very well said by Stefana. Spend time on modeling. It's a time well spent.
Yeah, absolutely. So let's say you have to do this unfortunate migration. How would you do about it? Let's say you have a lot of free space on disk and you have a lot of nodes. Then you might start to create a new set of tables with a new structure. You will keep serving the application from the old tables, and you will start writing twice on the old and the new for a lot of time. Then you will have a job that copies the data from the old tables to the corresponding new tables, all the while serving your customers. And then after painful testing, you would secretly jump on reading from the new tables. And then after that, you would delete the old tables. So that's those of you who went through such a thing also in other similar systems, you know that migrations are something that makes your hair go white. So please think carefully about data modeling. That being said, it's time well spent. And if you are planning on writing an application that has to be very powerful, Cassandra is going to be your friend. Absolutely. Okay. So that's very good. And I think we reached the end of the most important part of this talk. There is still time because it's 20. So we have another 25 minutes to go through a bit of odds and ends before closing. Let's start with LWT, which stands for lightweight transactions, which are also called CAS. Compare and set. Okay, so you remember when I said that whether you insert or you update, for Cassandra, it's the same. It's just something that goes writing, and if necessary, it will secretly, silently overwrite previous data. Yeah, that's the point. So inserts and updates are the same. And I can hear you saying, wait, there are situations where I don't want to overwrite a row if it's there already. And maybe somebody says, I want to update conditionally. I want to update this row only if the previous value is this one. Yeah, that's true. So you might be tempted. So there are, in your application, there are probably parts where you want to do that. And in your application, you might be tempted to do that in your code. So you read a piece of data, you do your logic in your code. If this then right, that's an anti-pattern for a very simple reason. There are no transactions in Cassandra. So you might run into race conditions, right? So there are two different applications, two different instances. They read, they do their calculation, and they write. But this happens at the same time, and you end up with a unpredictable result. So reading before writing in general in Cassandra is an anti-pattern, besides being not so performant. But the main point is race conditions. And then you will say, okay, so what can we do? Well, the answer are, these I kept secret so far for a reason, but there are so-called lightweight transactions. So look at this syntax. This is an insert with a final clause that is if not exists. So I want to write this row only if it doesn't exist yet on the database. Such a statement I can run, and it will have two different outcomes. You can have applied true, okay, inserted, or you can have no, I could not apply because the row existed already. There is another similar usage of lightweight transactions. So I might want to update a value only if the previous value was so and so. So in this case, I want to update the rating to 9 only if it was 2 previously. And also here, I will get either applied true as a response or applied false, and the previous rating was 5. So that's why Cassandra could not apply it. So these are a sort of miniature transactions, and you can use them, and there are cases where you should use them, but let's be very clear on the caution to be had. So lightweight transactions have use cases, and the typical example is you have a small table of users, and there is an interface to create a new user in your application. You probably don't want two different browsers to create the same user with the same ID, same email, say, at the same time, because then that would be a mess with the passwords or stuff like that. Or maybe when you want to change a password, you want to change it only if the previous password matches right then, because you want to avoid race conditions. You can actually ask Cassandra to transactionally take care of that. Or maybe you have an item in your warehouse that has 5 items. You are shipping one and you want to move from 5 to 4 only if the previous value is 5. Otherwise you fail and then you do it again, or anyway, stuff like that. Small, circumscribed, limited cases of transactional behavior, let's say. The point is that these operations do not have the super fast performance as the rest of Cassandra, because there is indeed a transaction going on. At least the nodes have to speak to each other and to agree on a change simultaneously. That is implemented with a consensus protocol that is called Paxos. But this protocol, this behavior to occur, requires the nodes to speak to each other a few times. So you have lower performance, which might be good, say, for the creating user case, because I don't see creating users to be the main workload of your application. But if the whole of your application is based on these transactions, then there's something going wrong with your data model. Another caveat is that when we say lightweight transactions, lightweight does not mean light performance. It means light guarantees. So there is no database lock as in a relational database transaction. So it's not that the whole database is locked, you can do whatever you want and then you commit. There is nothing like that in Cassandra. It's just a very small localized lock on that one partition, usually. And there is no rollback, so it's not right. It's not a transaction as you might imagine. It's something to be used sparingly because it's not good for performance. So if it's the main pillar of your application, think your data model again. That being said, there are use cases where you should do that. Alex, do you want to add something on this?
Yes, always.
Yeah, go ahead.
Yep. Well, basically everything, all the most important things are said already by you. Thank you so much. I would add 2 things. So actually 3 things. One more time, that is not a transaction in the relational world, like in the relational world where you have commit, rollback, and fancy things like that. The point is traditional transaction with rollbacks and so on require a database lock. And on the high pressure, under dozens, millions of queries per second, we cannot afford this lock, because lock on the openly accessed point of data may just paralyze your clients on the other side of the ocean, and so on and so forth. So there are no database locks, and therefore there are no rollbacks. So you cannot commit transaction when decide you don't want to do it and roll it back. It's just read ahead of write. Second, Stefano said that already, but people still don't realize the point. They think, okay, lightweight transaction is a read before write. Then, so basically it sounds like I do read when I do write, so it will cost me like 2 operations. No, okay, I can afford that. Well, yes and no, because lightweight transaction by the performance and time costs actually 4 to 5 times more expensive than simple write, because of all the consensuses on the replica servers. So in some scenarios, it may be cheaper to do it on the application layer. First do read, then do write if read confirms there is no data. Because there is, let's say, quite a minor chance what the same millisecond, 2 John Smiths with the same emails will try to register on your application. So for the sample use case, I would suggest a different use case when you really need lightweight transaction. Imagine someone, your client, buying something from you at the same time from a mobile phone and from the laptop. And there are different connections to different application servers, right? And first application server loads his statement, his account data from the database, and second reads his account statement from the database. So we have 2 copies on the application servers. When he buys something simultaneously on the mobile phone and on the laptop, but he has enough money only for one operation, not for both of them. As a result, if you just do the operation without lightweight transaction, he will get 2 things, but although he was allowed to get only one. And that's quite a bad situation, because let's say by the rules of your application, you customers are not allowed to go into the minus on their debit account, for example. In this case, to avoid that, you need to use lightweight transactions. Do you have an example of LVT with if in the end, like the SQL? Right. Oh, that's exactly what I want.
But yes, that's the point.
So you can say, for example, account state in the beginning of operation was $200, and you say update customer account set state, like, I don't know, let's say $80, if state equals a previous value, like whatever I just told, 100 or 200. So if it's equal to the expected value, if you have this LVT and both application servers execute this update, then first update will be executed successfully, because amount of money on his bank account matches the expected. But then second operation tries to complete, then it sees what the expected amount doesn't match real amount. Operation is stopped, applied false, because of amount of money doesn't match we expect, and then your application layer business logic can handle this situation and say, okay, sorry, you don't have enough money on your account. So for these kind of operations, when a really business critical, that's LVT a good match.
Yeah, well, I think that's a very compelling point, the way you put it. Yeah, I just want to add one thing. Okay. Alex?
Yeah, we are good.
Okay, sorry. I just want to remark that Mr. Helmut used not to like Spätzle, as you see, because rating was 2, but then he decided that Spätzle are very good. And since this is a German dish, that might be of interest for you. So shake Helmut's hand for me, because I like Spätzle.
Okay,
Sorry,
we'll
that was
do.
just to, relief.
Yeah, I was.
We always say of very terrible things that can happen with Cassandra, so I have to make a bit of a comedy part.
Right, of course.
Yeah.
I was
Okay,
typing
so
because I noticed it, Eric Ramirez in the comments, so I was to greet
oh,
him.
hi Eric.
Hi, Eric.
I can't see the chat because I don't have double monitor today. So yeah, hello, welcome. See you later then. Okay, so let me go ahead. That was it for lightweight transactions. We have another 15 minutes. Let me quickly go through batches. But I want to go quick because we might have, I want to show you some practice thing that you might want to do later. So batches, the concept of batches is, this is another of the tools in your belt to use Cassandra, and it's one of those tools that end up with us saying, use it but sparingly. So be careful. Batches allow you to run multiple statements in a sort of atomic way. So you can pack many statements and send them at once to the server for execution. Yes, so you sure have less overhead, you have less communication between client and server, and you also have a very strong retry mechanism that tries to ensure everything is executed within the batch. In a batch, you are limited to only DML statements, so only data changing stuff, so insert, updates, deletes. But now comes the important thing. Yes, it is atomic, sort of, but it's not a transaction. For example, there is no rollback for the same reason as before. So that would be too costly to coordinate a rollback in a 1,000 node cluster spread over the world and so on. You would just freeze your whole database, and that's no good. Writes are still made one by one. So it is sort of atomic, but it's not isolated in the ACID terminology. So you might end up reading partial results of your batch if you hit the wrong millisecond. Plus, there might be edge cases, so a node might fail and you might end up having a partial write. So what are batches good for? Well, the golden cases are either when you are writing on two tables with the same partitioning. So you group those statements. Let's say you have two different tables that contain the same data for different queries, as we saw before. You see there are just differences in clustering here. And you want to insert a new review of a new recipe in two tables at once. Well, if you think about that, it's two tables, but that's going to hit the same node because the partitioning is the same. So it's absolutely safe to group those into a single batch and to send them to the server at once. That's a golden case. Another similar case is that you might just have a bunch of reviews that fall into the same table, the same partition, and you just want to speak to the server at once. Look here, I have two different reviews of falafel. They go to the same partition, and I can group them into a batch and just ask the server, please, that one node, please execute this multiple write. That's good and nice. That's, I mean, I'm going fast because those are clear cases. They're just the advantage here. The problem comes when batches are used in the wrong way. So for sure, Cassandra batches are not bulk insertions. So a super mega anti-pattern is to think, batches, I can put all kinds of writes there and just send them to the server. That's absolutely against performance, because you will start sending a single batch that has to speak with lots of nodes. And that will be, that will be executed, but it will involve a lot of slowness and coordination and will probably time out if you exaggerate. So it's not for bulk insertion. By the way, within the batch, you have no guarantee of order of execution. So the batch is internally reorganized according to something you don't have control over. Then, okay, technically you can't mix counters and lightweight transaction with other operation in batches. Those are details. So there are idempotent batches and not idempotent. And if you start acting on multiple partitions in a single batch, you will have performance degradation, because then there is some coordination to be had. As soon as your batch is not the golden type, you will have so-called logged batches automatically. You can also specify that. But the point is that logged batches work in a slightly different way. They store a log of what is going to be executed. They execute the statement, and then they delete the log. This is to internally ensure coordination. And in a sense, similar problems as the lightweight transactions are into play here, because then you will have communication and overhead. And well, the lesson is, before using batches, get some knowledge on them, because they have to be used only when needed and only in the manner they are invented for. And again, if they are the main point of your data model, you might want to review that again. I would skip ahead, because batches are something a bit that you can then look up when you are advancing in your data model journey. And let me just very quickly go over a few other points, 2 or 3 of them. One is time to leave. That has been mentioned already this morning, speaking of the IoT example. You should be aware that when you insert cells, you might give an explicit time to leave to these cells. So, well, let's say when I insert a row, I can give it a time to leave. When I insert a single value of a single row, I can give it a time to leave. And then this value or this row will automatically disappear after a given number of seconds. That is very useful, and it might be used for clever solutions. But yeah, you have to be aware that it is always per cell. That has a weird consequence. So let's say I insert a whole row with a time to leave. Then 10 minutes later, I update one value with the same time to leave. Now what happens? That some of the cells in that row will expire earlier than others. So I will end up having a partial row after a given amount of time, and I wonder, where did it come from? So, okay, use time to leave. There are very valid use cases, but take care when you do that. So that's just it. But it's a very useful tool anyway. That's just a quick mention. I will just skip ahead. Indices, and we come to Rahul's question finally. So these are indices. Okay, now a very important point. So far, all of today has been about create multiple tables, be careful of your queries. You can query the table only in one way, and so on. That's true, and that's the main pillar you should build your data model on. But still, there are indices. You can build what are called secondary indices in Cassandra on tables, on existing tables. And this is an example, Rahul and everyone. You see, there is a query here that first would not work because reviewer is just part of the primary key, but it's not a partition. So you see the error tells you that. And then you create an index on this column based on the table that already exists. And then magically, the query will work. And by the way, Helmut appears not to like Spätzle at all anymore because ekelhaft means disgusting. So poor Helmut has a changes his mind a lot over this recipe in this example. Now, there are some caveats over creation and indices and some limitations. So the most important thing is that you should index columns only when they have medium cardinality. So when there are not just 2 values like a Boolean and not one different value per each row, because there you would get the best performance. Otherwise, it's almost useless way of indexing, or anyway, performance-wise is terrible. And you should take into account that indices are distributed exactly as in the base table. So even if I index on a column like reviewer, the index will be spread over nodes as the data in the original table. So I will have pieces of reviewer equal Helmut here and there and there. That means that if I'm interested in just a row by reviewer, that would be good. But if I want to have all reviews by Helmut, the index is not the right way to go, because again, that would require me to speak with a lot of nodes. So in many cases, you should think carefully, and probably it would be better to have just 2 tables and maintain them by hand in many cases. So think carefully. Yes, so I used to have a slide over materialized views, but I think I'll skip that. Just know that there are materialized views, but they are considered experimental, so you might want to have a look. They should be tables that are maintained for you as mirrors of an existing table according to their own new partition key. Just know that. But by the way, Cassandra 4 came out after a long time of performance improvement and new features, and it came out recently, couple of months ago or more. And in Cassandra 4, materialized viewers are still experimental. So I'm not even mentioning them anymore at the moment. So they have their own opinions. There are contrasting opinions on that.
Some data architects say what DataStax enterprise version implementation of materialized views are significantly better. But let's say there are also some people, like Cassandra engineers, what contradict this opinion.
Yeah.
So our recommendation, especially as for beginner Cassandra users, avoid materialized views at this moment.
And before using them, get some more knowledge and maybe speak with somebody on, say, community.datastax.com and gather some opinions.
There is a question what got me, what got my interest in it. Vadi Hirtanto asks, in what cases the select TTL will be used? Okay, so Eric already answered that.
Okay.
I was surprised. Yeah, TTL only applies to writes.
You might be interested in knowing how long will that piece of data be available, basically. But okay. Okay, so I think we come to the conclusion, and we have 5 good minutes for a very important thing. I think you have been exposed to a lot of interesting concepts, and there will be much to think about today and after today. But honestly, 2 hours are not enough to explore data modeling in Cassandra.
No.
So you are strongly invited to find out more. Maybe, Alex, you can paste the link to the learning
of course, I have it by
website
name.
and also the academy as well. Because you see, we have the academy for courses and to get you prepared maybe for the certification or whatever, which, we spoke about that already.
Mm-hmm.
But in particular, I want to draw your attention on these hands-on exercises. So you see this first link here, datastax.com, learn data modeling by example. I'll show you that in a second. The point is that those are interactive exercises, which are a bit of lessons, lecture, plus interactive exercise that you can do in your browser. And they are different exercises about data modeling with use cases and examples. And they will guide you through more and more understanding of what is data modeling through practical cases. You will interact with a real Cassandra installation in the browser, and you will end up learning a lot of things. And surprise, surprise, if you finish any one scenario and you send us a screenshot of your final screen, you will get a completion badge. So you can reach us here. Maybe, Alex, you can write these 2 links.
I already did, but I will do it again.
Okay. And the final screen would look something like this one. Congratulations, you completed the scenario, and then there is some explanation of which scenario you completed. That's more or less it. So I have a final slide of thank you, but I want to very quickly show you this. This is the page Alex should have sent you the link to.
Already.
You see there are a few data modeling by example, and let's open any one of them. So there you see there is a very well-built learning material. And by the end of it, you will end up with an interactive scenario that you can start. And guess who prepared these scenarios? No less than the person Chebotko diagrams are
name it, yeah.
named after. So,
yeah, he is the author of data modeling methodology for Apache Cassandra.
So I think you would be in very good hands with these scenarios. Right. And good luck, and see you when you submit your completed scenario. I hope you will learn a lot by that.
Right.
And I think with that, unless there are some other questions, I think it's...
no, we are good.
It's, let me see, it's 5:45, right?
Yep, and we have to switch to Ask Me Anything.
Yes.
Just one last moment. So,
Yeah.
ladies and gentlemen, I see some of you already submitting their homeworks for the first workshop, and that's
good
great.
point.
That means what you will get your badge for Cassandra Fundamentals. Now you can get the second one if you complete the thing. Stefano just send you. Pick any scenario which is the most interesting for you. Personally, I would suggest sensor data modeling. Which is on this list, datastax.com/learn data modeling by example. Incredible courses. There are 7 options. You can pick one you like the best, you like the most. In the end, make a screenshot, send it to me or Stefano on LinkedIn. Links to our LinkedIns are in chat. And we will issue a second badge, so 1 day, but 2 badges and a voucher for a free certification. Isn't that amazing?
Yeah, it is.
So,
Alex, just a question. Is there a bubble for me in the AMA?
Give me a moment. Okay, I believe at the moment we anyway switch to hold on screen for a second, and we will discuss it. And so don't switch off. Ask me anything with your questions. Start in a minute. Give us a minute for setup, and we will get back to you. And you can use this minute for whatever you need. Yeah, because we will also need a minute or 2. See you soon.
So stay tuned. See you soon.
Yep. everyone. Looks like we are back online with our incredible experts. So let's do a quick check. If you can see us, if you can hear us, set the thumbs up in the YouTube chat right now, and we will start. But for me, it looks like we are good. Okay. Dimas Kozi already started scenario for sensor data modeling.
Yeah.
But it's just
page.
a blank page? Okay, where it works for me.
Let me check.
Yeah. Okay, but what matter is we will do it anyway. First, questions and answers. And I think we can start. Looks like, yeah, we can see. Looks like we are good with video and audio. Congrats. So we can proceed. And let's start with first things first. First question was...
Let me help to translate me.
Right.
Okay. So the first question from Budi Hertanto. How is the replication technique in Cassandra to ensure there is no effect on the performance when the data becomes so huge? Yeah, that's the first question from Budi Hertanto.
So, do you want to answer this one?
Yes, I think. Yeah.
So go on.
Oh no, I mean yes. Maybe some of you.
Okay.
Eric, yeah.
Eric, why don't you start?
Yeah, so you're probably thinking about replication in the way that, for example, if you did it with Oracle or anything like that. So in Cassandra, replication happens in real time. So when you do a write, so it doesn't matter if it's an insert, update, or a delete, that mutation gets sent to all the replicas. So it doesn't matter if your replicas are on the other side of the globe, it gets sent there in real time. So it's not something. So it's not something that's batched, or it's not something that's scheduled to say gets all the writes in the last 5 seconds get sent at a specific time. It doesn't work like that. So the data size is not an issue.
Right. As long as your data model done right, which we already discussed for the last couple of hours. Okay, so if anyone doesn't want to add anything to this, I will mark this done. And Budi Hertanto, so many people voted for your question, so it's obviously best question from the audience point of view. Please contact us using the links in the YouTube chat, me or Stefano on LinkedIn. We will need your address. Congrats. Okay, there is a question about select distinct.
Yeah.
Yep. Could you please translate?
Yeah. Okay. Is it possible to do select distinct on Cassandra? And if there's not, what is the alternative actually?
So yes, there is an option to do a select distinct. But for me, if you're asking this question, if you have to do a select distinct, it tells me that maybe you're doing a select on multiple partitions, which doesn't perform very well. So the Cassandra is designed for high velocity transactions. So you're meant to be selecting, you're meant to be retrieving just one partition, not multiple records. But the quick answer is yes, you can do a select distinct, but try to avoid that. It means that it probably tells me that maybe you got your data model wrong.
That's a great answer. I have nothing to add. Anyone? Okay, so let's move on to the next one. I like this one. I want to take this one. So Danny asks, what happens to existing data in my cluster when I add new nodes? The general idea is when you have some servers, let's say we speak about a small cluster of free servers, one single data center, free servers. What happens to existing data in your cluster when you add new nodes? Take a look. There are free servers responsible for all the data in the cluster. Therefore, all the possible token ranges are allocated between three of them. Then you add new nodes. Those token ranges will be recalculated automatically by Cassandra. So you simply start new server, join this cluster with this server, and cluster then recalculates token ranges, gives part of the responsibilities to store data to this server, and then transfers data, streams data to the new node. So when it's bootstrapped, it starts also to answer queries and accept writing requests. Basically, that's what happens. Anyone wants to add something?
Yeah, it's exactly that. It automatically balances, so it redistributes the data so that it's balanced across all the nodes. So if you started off with, say, 3 nodes and you add a 4th node, you'll end up with 25% of the data between all the 4 nodes.
Right.
Just to point that this affects newly written data, but to be sure the data already existing goes in its new place, you're supposed to run a manual repair just to make sure every piece of data will be dispatched to the right place. And again, we mentioned the consistent hashing that has the consequence that the minimal amount of data moving around takes place. That's detail, but it's important.
That's important detail. Yeah, Cassandra is well optimized for these scenarios. And yeah, I like this question. That's a good one. And I like the automation behind that. Okay, so Diki, that's for you.
Okay. Yep. So when the data is distributed, if we want to query data from all the server, isn't it going to be slow because it has to be connecting to every server? Maybe I can add something. Maybe what Budi Hertanto means here, something like select all, select star from some table without mentioning partition. What about that, guys?
Yeah. So my answer would be if you have 1,000 of servers in your cluster, and if you run stupid query with allow filtering, with no real conditions and partitions, yes, it's obviously going to be slow, but we are here to teach you not to do that. So that would be my answer.
Yeah, so the partition here is the key. Yeah.
Right. So if you need to select, if you need to do a full table scan, then that's probably an analytics workload, not an online transaction workload. And so if you were using Spark would split the data into smaller chunks, and it won't do a full table scan.
Right. Okay. So
it's still fast.
Oh, sorry. I want to mark this as answered. Anyone wants to add something?
Good.
No, good. Okay. Well, again, Diki, your step.
Yep. Okay, what's the main difference between Apache Cassandra with MongoDB, which both have the same base NoSQL? Yeah.
Okay, that's one of the most oftenly asked questions, I would say, how Cassandra compares to MongoDB, because MongoDB is one of the most known NoSQL databases, and Cassandra as well. So what's the principal difference? First of all, I have to highlight a point. NoSQL is not a one particular type of a databases. NoSQL is a wide bunch of very different database families, and there are many hundreds of different NoSQL databases, and they are very, very different. And MongoDB and Cassandra belongs to different families, so their behavior is different. There are many, again, differences between them. I would, from my side, mention first two. MongoDB uses so-called schema-less approach, which is technically not correct because it's a flexible schema, but it's still inside. But for developer, it's kind of hidden, so it's known as schemaless. And with Cassandra, you have to design table first before storing data. So from the flexibility point of view, MongoDB makes kind of some benefit. But there are many different also points to compare. For example, if you want to scale out Cassandra for reading queries, like if you have a lot of reading operations, but not so many writes, Cassandra can make it, but it still has these primary server, secondary server kind of masterful approach, more or less traditional. And then you want to scale it for the writes, you can be quite deep in troubles because it ain't so easy to scale Mongo for writes, and at some point it just don't work as well. Quite opposite, Cassandra, because of its decentralized no single point of failure architecture, is a very good fit for scaling also for writes, not only for reads. Briefly speaking, Mongo can handle these flexible schema or schemaless documents, which is great if you need that. But if you understand the structure of your data and you're going to have more operations per second when Mongo can handle, then Cassandra definitely can be your choice. Last point, Cassandra is a better fit for multi-data center deployments. Gentlemen, I'm done.
Did you want to add anything, Stefano?
I think I'm good with that. I was addressing a question in the chat actually, so.
Yeah, so before you answer that, I was going to answer that follow-up question from Budi.
Okay, sorry.
So just to add, so you choose MongoDB because you like storing stuff in JSON documents. It's like Alex said, it's flexible. It's easy to store data because if you've already got the JSON for it, it's easy to store stuff. But, and here's the big but, when you get to play with the big boys, with the internet giants, when you need to scale, you don't have a choice. You have to switch to Cassandra because Cassandra is optimized for high velocity throughput. Whereas MongoDB, there's nothing wrong with MongoDB, right? But we have a lot of users that come to us to say, we've got a problem, it doesn't scale, and so they switch to Cassandra. That's the major difference.
Right.
Yeah.
I would add a point on that. So you see, those questions like Cassandra, Mongo, or any other database, people ask them all the time. There is nothing wrong with Cassandra, there is nothing wrong with Mongo. And sometimes those questions like, what is better, hammer or wrench? Wrench is better when you need wrench. Hammer is better when you need hammer. It's quite easy. We cannot say what wrench is better than hammer or hammer is better than wrench. It all depends on your needs. Okay, Mongo is a great database and I like it. There are just scenarios to fit better for Cassandra, or there are just scenarios to fit better for Mongo.
Yeah. So I might add one small thing that for those of you who prefer to work with so-called schemaless approaches, but still you want to use Cassandra, there are ways to plug a layer on top of Cassandra that makes it look like, even though there is an underlying Cassandra with all of its guarantees, you can still interact with it in a document way, in a schemaless way. And that is something I will briefly mention in the later application development talk. There's an open source tool called Stargate that is an API layer on top of Cassandra that opens the way to accessing the data in a document schemaless way. So just as a parenthesis, it's not Cassandra itself, but it's an open source tool that neatly integrates with that.
Yeah, absolutely. And thank you for mentioning that. Stargate indeed can be a great tool for many scenarios. So I guess we've answered this one. Now, Danny, which of the following is... which of the
I was just going to say, can we just quickly answer the follow-up question from Budi?
Yes, sure.
That Stefano wanted to cover.
Yeah, no, I'm done. Go ahead, please.
Oh, yeah.
Oh, yeah, so just going to say, so Budi's follow-up question was they have situations where they want to do multi-partition reads. That's what his original question was about. Again, there are ways of doing it. There's a thing called the in operator. So in and then brackets, you specify the keys that you want to retrieve from the database. We provide that as a convenience so that you can do like 2 or 3 keys, like you can do a read of 2 or 3 partitions. But again, if you need to have like if you need to scan lots of partitions, you probably, one, either got your data model wrong, or 2, you probably have an analytics workload, and you need to offload that workload to something like Spark, because Spark can handle it more efficiently than direct SQL select statements.
Absolutely. And I would say what in general, that's not a disaster, that's not a huge problem, then your query from time to time access to free partitions. Okay, that's an additional network operations and so on, but no one will die, let's say. What's the real problem is like for things like allow filtering or querying without the partition keys and so on and so forth. But the occasional querying for 2, 3 partitions, it's completely fine. I mean, yeah, of course, it will be a little bit slower, but it still will be very fast in comparison with many other databases. Okay, so we can proceed? Okay. Good. Well, then, Danny, which of the following is a replication strategy of Cassandra to specify how data can be replicated? So I would say there are 2 primary things to consider. First thing, call it replication strategy, and second thing, call it snitch. About the replication strategy, we discussed it a little bit already. So basically there are 2 kinds of replication strategy, simple and network topology aware. Simple strategy cares about nothing. It's good for your development environment, for your laptop, but bad for production or any kind of production-like environment. And network topology aware strategy is about to put data within single data center as far away from each other as possible, so all of the replicas won't be located in the same server rack. Now, there is a second point, snitch. What is snitch and how it matters? Snitch is exactly the tool what replication strategy will use to identify in topology what are the data centers, what are the server racks. So how exactly do we put data far away from each other within single data center so it will be more reliable? Very simple snitch is basically based on file properties. Every Cassandra node you start, you can write a configuration file. So it is located in data center 1 server rack A. And then this file-based snitch will take a look at these configuration files to make the decisions with replication strategy. There are more advanced snitches. For example, AWS, Amazon Web Services based snitch, which understands the topology of Amazon Web Services deployments and knows what there are regions and availability zones, and it helped network topology aware strategy to allocate replicas as far away from each other as possible, therefore to different availability zones. Gentlemen?
I'm good.
I think you've covered it.
Okay, good. Wow. So, boom.
Okay.
So we are giving some further links in the chat just to go deeper, but okay, those are obviously a bit of a more in detail things. So take them as say the start of new journeys. So yeah.
Okay, so the next question from Budi once again. Okay.
Mm-hmm.
Yeah, so it is mentioned that Cassandra is masterless to avoid SPOF, but then there are some coordinator nodes. Are these nodes potentially become SPOF?
Yeah. Okay.
Yeah.
So may I just say something on this?
Sure.
Very quickly, because I think the answer is pretty simple. So there is to be made a very important distinction between a node being coordinator, as in a master-slave architecture, and a node being query coordinator. So when a node is query coordinator, his special role is only there for the duration of the query. So your application reaches the cluster to ask for some data, for example, and it will hit a single node. That node, only for the duration of the query, yes, will have a special role because it will be the node speaking to other nodes, collecting the data, ensuring the consistency works and everything, and then coming back to you with the answer. Yes, so that will be a special role for that node. But once the results are given to you, to the client, it's not coordinator. So the role of coordinator doesn't exist anymore. So it's a very short-lived thing, which means that, yes, your query might fail because in that very moment, the node might have a problem because, something might happen. But then in the worst case, you just retry the query 1 millisecond later on another node. And drivers, by the way, are also able to do that for you. But all in all, in the general long term, so to speak, in the long-term architecture of Cassandra, still there is no special node. So yeah, query coordinator, but not coordinator in any greater sense.
Right. Then as soon as you start to speak query coordinator, people from relational database background start to think of that as a master node, which is completely wrong. Let's say I have a cluster of 5 nodes, single data center. Which one of them are query coordinators? All of them. The one who gets the query will coordinate the query. If server A gets the query, it will coordinate the query. If server C gets the query, it will coordinate the query. So that's basically how it works. Every node is a coordinator node.
Yeah. And by the way, if I may add something, usually the drivers might be made aware of the token distribution in the cluster. So when you do a query on a partition, usually the drivers will know which nodes to hit to directly reach a node that holds the data. So it will generally skip one useless jump of data because it will directly go to a good node with my data. So yeah.
Which is a good segue for the next question.
Right. I just wanted to say what we answered 2 questions in a row. Well done, gentlemen.
Yeah, cool. I didn't see it.
So I close first one, right?
Yeah.
And this one we also just answered. There is no really query coordinator. Whoever gets the node will be query coordinator. And as just Stefano said, client always tries to contact the replica node because it knows data allocation over the cluster and token ranges over the cluster. If for any reason it cannot reach a replica node, then it may retry it to just the node considered closest. Good.
So if I can just explain, so the Cassandra drivers have a built-in load balancer within the driver itself. So you don't actually need to use a load balancer or a virtual IP in front of the cluster. So you can fit when you use the driver in your application, you configure it to say which load balancing policy you want. So there are different kinds of load balancing policies. So there's a DC-aware load balancing policy so that it knows that it will try to contact a local DC instead of a DC that's on the other side of the globe. There's the token aware, which Stefano was talking about. So token aware means that the driver knows where the data lives within your cluster. So you might have 100 nodes, but it knows, for example, that node A is where the partition lives. So it will try to prefer that in a token-aware policy. There's also a latency-aware policy. So it prefers to contact nodes which are fast compared to nodes which have had a higher latency, were a little bit slower to respond in the last 5 seconds. So by default, the driver, if you don't tell it which load balancing policy to use, it will do the DC aware and the token aware wrapped inside it by default. So that's how it knows which nodes to contact as a coordinator node. And don't want to get into too much details, but when your application talks to the driver to send a request to the cluster, there's a query plan that gets built. The query plan is a list of nodes that it will contact. So, and those are the list of possible nodes that will be used as coordinator, and it tries each one in turn. Like you could end up, if in a 50-node cluster, you could end up with like 30 of them being part of the query plan. And the driver will try them one by one until one of the nodes responds. Doesn't have to do all 30. It will just contact the very first one, and the very first one that responds will be used as the coordinator node. Obviously, the driver node knows if a node is, for example, has been shut down, it won't include it in the query plan, so it won't be considered to be a coordinator for that request. And this happens for every single request that you send to the cluster.
Yep. Thank you so much. I want to use my administrative privileges to move one question above because it's extremely important for us. Actually, give me a moment. I'm almost done. Yep, here we go. So sorry for moving it ahead the queue, but I find it very important. We already mentioned it many times what SQL has very limited search capabilities. And what are the ways for us to solve the limited search capabilities? Because obviously search is essential for any kind of applications mostly. How would you answer, gentlemen?
Cassandra is, like we said, Cassandra is optimized for very fast reads. And to get very fast reads, you're retrieving a single partition. When we talk about free-form search, you're no longer retrieving just one partition. You're effectively doing a table scan. And so we need to have something like Elasticsearch or Apache Solr that does an inverted index of your data so that you can quickly do a search against those indices and then retrieve the partition that satisfies your free-form search query.
Gentlemen, anyone else?
Yeah, that's okay for me.
Yep, that sounds great for me. So the point is, teamwork makes dream work. Someone alone cannot be good enough in everything. So if you want to reach great goals, if you want to build not a hut in the woods, but if you want to build a skyscraper, you need to have a good team. Typical teaming for search or, for example, analytical queries. For Cassandra will be Apache Solr, Apache Spark, Elasticsearch. There is a more or less a known project known as Cassandra, which unites best of both worlds, and so on. In short answer is just unite, make teamwork of that. Good.
Yeah.
So next question. By the way, Stefano, how much time do we have left?
So it's well, let me do the conversion for the guys, the listeners. It's 16:20 now, so we have 10 minutes more.
10 minutes. Okay. So as we answered most voted questions already, I suggest us to speed up because we still have 57 questions left. Thank you.
Yep.
And so let's.
No way we will make them all, but
we cannot make them all.
Okay, we'll pick some. So yeah.
So next one, I'm not sure I really understand that question. What efficiency, Cassandra, to tuning and migration DB?
Maybe ask your question on community.datastax.com, Sudar, just because it doesn't make sense to us. Just so in the interest of time. So the next one is, can I change replication factor on a large cluster? Yes, absolutely.
Yeah, this one is easy. Yes, you
Depending on what
can.
you're doing, you need to run repairs.
Yeah.
Yep.
I think
and for the next,
if I'm not wrong, in particular, if you increase the replication factor, you have to run repair.
Yes.
If you decrease it, you can leave it like that, but probably you want to do a cleanup to avoid the useless replications, useless replicas from sitting there, and you want to free space, right?
Right.
That should be it.
But,
Yep.
but in almost all cases, we recommend replication factor of 3 for each data center in your cluster. I cannot think of any use case where you shouldn't have replication factor of 3.
Yep.
I agree completely. Yeah.
No, it cannot be changed automatically. I mean, you can if you specify some special script to do so, but in general, I would avoid that because it's the decision what has to be done by people, not by robots, in the 99% and 9 period scenarios.
I don't see it as a variable replication factor scripted operation in any case. Yeah.
Sudarno,
but all operations in Cassandra are live. There are no offline operations in Cassandra.
Yep. Cassandra is designed for 100% uptime. So, Sudarno, please ask your question again at community.datastax.com and we will take care of it. But for now, we are not ready to answer. Sorry. I will temporarily close it. Please.
Okay, let me answer the quick question from Mirza ya. In bahasa. So untuk pertanyaan dari saudara Mirza, jadi di Cassandra tidak dikenal join, bisa diikuti di sesi sebelumnya pada saat normalisasi. Jadi tekniknya adalah mengganti join dengan normalisasi. Jadi ada beberapa perbedaan dengan SQL pada umumnya. Nah, ya, secara singkat memang tidak dikenal join dalam Cassandra. Demikian. Oke. Yep.
Joins are bad. It means that they don't perform well, particularly when we're talking Cassandra, because you have billions and billions of partitions, and your tables are massive when we're talking Cassandra, right? And you don't have a toy application anymore. It works in like MySQL or Postgres because you have tiny amounts of data. In Cassandra, your users don't want to wait, seconds or minutes. They when they open up their app, they want to be able to see the data straight away.
Right. Okay. I will get one from the bottom, but very quickly. Regarding data security, does Cassandra have access control features, authorization, authentication? Yes, sure. All of the set it's used by enterprises all across the world. So everything what you may think of. What differences between Cassandra and other open source data?
I want to add one sentence to this answer.
Please.
Just one very quick thing. Not only that, but there is also support for all kinds of encryption in transit and in storage, just to complete the picture. Yeah.
Okay, so what's the difference between Cassandra and other open source DB? I'm sorry, but there are hundreds of open source DBs, and if we would take to compare Cassandra with each one of them, it would take next, I would say, years. So that's a too general question. I'm sorry.
You choose Cassandra because you have a scale problem. It's as simple as that.
Yeah.
Okay.
Yeah.
This one is actually not technical, but maybe you guys can help. So someone asking, he is a teacher, he is teacher, and he asks how Cassandra can be used on education fields. Can you give some example? Yeah, thank you.
Yep. So first of all, Cassandra is open source, so you can use it free of charge. Second, if you don't want to install Cassandra but still want to use it for educational purposes, you definitely should take a look at Astra. So Astra DB is Cassandra as a service, and it has a very, very rich free tier where you use Cassandra but don't pay anything. As long as you don't have production-like workloads with dozens of millions of queries, then it's free for you. It's sponsored by DataStax. And for education, you can use our academy.datastax.com with free courses. They are in English, But now we will have very good subtitles. I'm working on that. So at least if you can read English, you will be fine with that.
Yeah. Plus
I
we
think
have
Barry's question we've already answered with the search, so we can skip that. And Tommy, we've talked about using Spark. So yes, Cassandra is a good fit for analytics. Use Spark because that's the most popular. But of course, you can use, like you can do Hadoop stuff as well.
Yeah.
But everyone likes using Spark.
Yeah.
Next one.
Okay. Which one?
This one, or you answered already?
Yeah, that's the one that I was talking about.
Okay,
that's
good.
the one with all up workloads.
Or Anas.
So this one was answered already. Yes, Cassandra supports end-to-end encryption.
Okay, great. Not only between client and server, if I may add, but also between nodes if you want. So if you have, say, regulation requirements, that's good for you.
Yes. Node to node, client to node, node to client, and so on.
Rahul asked you a question on community.datastax.com because it doesn't make sense to us.
Yep.
Yeah, we lack
Dimas,
context
yes,
here.
Cassandra is built for big data.
Yeah.
And IoT time series.
Regarding this question, Cassandra is not suitable. Cassandra is perfect.
Yeah.
Good. So this one, we need translation.
Anas,
Okay. Yeah. Can Apache Cassandra become solution for save huge data? And because there are so many database solution here using centralized architecture. I think
the answer is clear from today's from what you saw today. So it doesn't have a central master or point of failure. So if you want big data, not centralized data distributed, then Cassandra, it's probably going to be your solution.
Yep.
Yeah.
Good. Okay, next one.
Okay, Cassandra supports multi-DC backups, whether it's on-premise, whether you got hybrid deployments, like, some of your DCs are on-premise, some of your DCs are on the public cloud. We support all of those use cases.
Okay, but I'm sorry, Eric, you are way ahead of me. Which question did you answer?
That was anonym.
Okay, but do you understand Bahasan?
Some.
Oh, really?
Yeah. Okay. Yeah, great.
Okay, then I will close it as answer.
Well, I think multi-cluster and backup are easy to understand in Bahasan.
Yeah, right.
Yeah.
Okay.
By the way.
I'm not sure I understand these questions, sorry.
Yeah.
I think the answer could be there are no transactions in Cassandra, if I get it right. So transactions in general don't scale so well.
So if you mean a transaction like commit rollback, like so there is an interesting development of the story. There are no general purpose transactions in Cassandra yet, but there is a Cassandra enhancement proposal which may be accepted, and then after some time we in theory could have general purpose transactions. But it's very unclear yet if it will be accepted ever, and if even it will be accepted, when it will appear in Cassandra. It may take years because we cannot risk stability of the database. So big changes take a lot of time to put.
Plus, it is not easy to make it friends with the current philosophy of Cassandra of being fast and say goodbye to transactions in a sense. But yeah.
Next question about data visualization and data modeling tools. Accolade is a very popular one for Cassandra. There's also KDM. If you wanna get the details of where those are, just post a question on community.datastax.com and we'll send you the links.
Yeah, sorry. I think the question is, what is actually the purpose of data modeling?
The purpose.
Yeah, the purpose, the function, the purpose of.
I would say. Yeah, I would say you do data model to create the right database to make your application fly.
Oh, sorry. My mistake. Yeah, it is. Is there any tools for modeling in
Typical
data
question.
visualization?
Right.
Yeah.
Accolade and AKDN are very popular. There are lots of others.
And they have support for CQL, for Cassandra data model in particular. They are graphical. You can drag and drop and build a lot of nice stuff. And it will create, I think, if I'm not mistaken, they create the actual statement, SQL statements for you at the end.
I don't like using them.
Good. Okay, so is it possible to select data from Cassandra only for a certain period of time? Yes, of course. But if you do a range query, so after yesterday, but before last month, that has to be a clustering column. It cannot be partition key, obviously, because on partition keys you cannot have inequalities. So it has to be a clustering column, and it cannot be data column because only clustering column and partitions key can be using for querying for data.
Wait, unless you want queries for that particular month, and then the month might be your partition key, in which case, so anyway, the general answer I would say is yes, if you design your table accordingly.
Prima. That's the right answer, right? So
I think we are a bit short on time at this point. So
Okay.
I would say we have to stop here.
Okay, so
Alex, just a question. Did we
Yep.
introduce Eric at the beginning?
no, we didn't.
So maybe he deserves it.
Oh,
because
definitely.
Eric is a bit of my hero because he's patrolling the questions, the community, and giving always a lot of answers. And he's a knowledge giant, and he's also very active in answering and helping anybody. So you should consider yourself lucky to have him here. And we thank you, Eric, for being here on a Saturday. So yeah, thank you a lot. You've been super helpful.
I'm only to double on that because Eric is our community hero, and you know what? There are a lot of people who answer questions about Cassandra, and sometimes it's a problem because not all of them giving the right answers. So Eric is the one who gives the right answers, and that's incredible.
Absolutely.
Okay, so at this moment, Ask Me Anything is done. If your question was unanswered, please proceed to the community.datastax.com and we can discuss it there, or you can also use our Discord. Link is in the description of the video. And our next step going to be, Stefan, our next step is your talk.
Yeah, I'll speak about the application development. So we show you a few examples and briefly survey the status of the Node.js driver in particular.
Great. So I have to say many thanks to Eric Ramirez for joining us on Saturday.
Thank you so much.
Joining us on Saturday. Many thanks to Dike for translating and answering questions. And
absolutely.
We will meet again in the final words right after the last workshop.
So we now have application development that is 45 minutes. So at 5:15, we will just meet again to say goodbye to every one of you and to close the session, close the day. Yeah.
So see you soon.
Yeah.
Okay.
Thank you again.
Okay,
So,
and we are back online.
Yeah, okay, so we are back. So first of all, thank you for the very nice question session. It was interesting. There were a lot of nice questions, and it was a pleasure to discuss a bit more in detail with you. Now, before the end of today, which has been and is going to be a full day, we will briefly survey something about application development. As you can imagine, this is a topic that goes well beyond 45 minutes, so I will try to just give you an idea and run some example. I prefer to put a bit less things and show you some working code. Simple examples, just to give you a feeling of how easy it is to start. Nevertheless, originally my plan was to have some hands-on session for you as well, but unfortunately 45 minutes is really too short for that. But I found a way to sort of find a solution. So let's see, application development. Now, let's start with the start. You're writing an application, and this application will be using Cassandra as your database. You need something between your code and the database, right? And usually the answer is you need a driver. Indeed, look at this. In this graphic, in my sketch, I draw a driver within your code or within your serverless functions if you have a serverless architecture, or within your API. Anyway, this driver will be able to speak to Cassandra. As I mentioned during one of the answers just before that, there is another way that is a different kind of layer between your application and the database, and it is this Stargate I keep mentioning. And that's an API data layer that exposes the data in your database in different ways. Data API, GraphQL, document, and you name it. Anyway, always built on the underlying Cassandra. And the advantage is that your application, your code, will just have to do HTTP requests, and we'll have access to different ways of looking at your data. But that being said, today I will concentrate on the good old drivers. Okay, drivers. Cassandra drivers are available for the majority of the most popular languages. You see Node, Python, Java, C, C#, you name it. And they more or less share the same advanced features that are well paired with the nature of Cassandra. So you will see some of them, but more or less they all have the same high-level features. Today, I will concentrate on Node.js. Now, a little anecdote. Originally, this presentation was supposed to be about Java, but we realized that most of the developer community in Indonesia uses Node.js. So we built, exactly for you, we built this new presentation, and you are the first one to see it. So consider yourself a beta tester, but most lucky to be exposed for the first time to this new presentation. I hope you like it, and feedback are welcome. Back to our points. So I'm giving you here a link to the Node.js to the documentation for the drivers to Cassandra for Node. But most of what I say will be more or less the same for other languages, with syntax changes, basically, more or less. And most important, everything that you will see today, every piece of code, you will find in this repo. You see here the link. This is my own personal GitHub, and you will find a repo with all pieces of code and a very well-structured README that will guide you through all exercises if you want to try them, and it will explain you how to set up everything to run the code examples. Okay, so, oops, I did something. Okay, I opened my repo, but it's open already, sorry. I don't know what happened. I think these happened, sorry. Lost control for a second. There we go. Okay, so before moving on, let me show you the repo. This is the repository. Just very briefly, you will see here, hello and welcome, this is blah, blah, blah. So you can go there. Maybe, Alex, you might want to paste this link in the chat, just for those who want to bookmark it for later.
There are actually. Can you please send it to me on Slack so I will pass it?
It is in the cheat sheet I shared with you, so it should be there already.
Yep.
Anyway, if you go by yourself and you are invited to, you will find instructions, and the instruction will ask you to set up your environment by installing. We'll now see what. So basically, the driver. You will create your own AstraDB if you haven't done so already this morning, and then you will be able to do the practice after creating a new database, or at least a new key space called chemistry, because today's example are about chemical elements. Why not? But it is all explained here. So I chose AstraDB for the exercises, so you won't have much to install, obviously, but in the instructions, I also explain exactly what to do when, if you have a Cassandra, another type of Cassandra, and you want to use that for the exercise. So no problem with that. Now, you also have to set up some secrets to be able to access your database from remotely. So some authentication, as was asked in one of the questions, and luckily, so this involves generating and taking some access tokens, and also a file containing certificates. This will be available on the Astra UI, or if you use Cassandra in other ways, you will have other authentication, other connection. It's all explained. But luckily for you, everything here, I did it already, and it will take just, say, 10 minutes, 5 minutes, but we don't have time. We want to get to the point, so sorry, but this will be left as an exercise for you if you want to repeat everything here. The last thing you would do before, if you want to run these examples, is you have to create a key space. On Astra, that will be created by creating by following the instructions. You will have to create a table, and just let me show you the table. It's a table containing chemical elements, so symbol, name, atomic mass, atomic number. Why not? Then you will be required to populate the table with a ready-made, just to show you this list, a ready-made list of chemical elements, hydrogen, helium, and so on, just to play with. Yeah, you see there is some setup to be done, and that's just if you want to run exactly these examples. So not necessarily, obviously, but at the end of all this setup, you will be able to go for the practice, which is very simple pieces of code. Anyway, now before going on, let me show, this is my Astra dashboard, and you see I already have this node practice key space created, database created, and if I click on it, there is a key space called chemistry. You saw this morning how to get to the SQL console, so I'll do that. And before switching back to the slides, maybe I can make this a bit larger. So I have a key space called chemistry. I hope what I'm typing will remind you of this morning small practice session. I'm now on the key space chemistry, and if you see, there is a table called elements. I will just show you desk table elements contains. So this table has 4 columns, symbol, atomic mass, and so on. Let's have a quick peek at the contents, but I guess you can imagine what is there. So limit, say, 15 elements. You see, I just have my chemical elements, neodymium, californium, nickel, and so on. So this is just the base sample data I will use then. Okay, that being said, let's go back to the slides. Okay, so, I think it's I keep clicking in the wrong place. I'm sorry for that. Let's go back to presentation mode. Okay, so let's start with the start. In your Node project, and from this point on, I will focus on Node, but you find information on all other drivers, and they change only in the form and not the substance. You just do an npm install of Cassandra driver, which means if you work with a package JSON, you use such a dependency. That's so far so good. Now, the main point is how do you connect to your cluster from your code? So conceptually, you need to provide contact points to your driver. So your driver works at your application level, and it just needs some of the nodes. It needs to be able to reach some of the nodes in your cluster, the ones that I made purple here. Even just one, but maybe a bit more than one, so you are a bit more resilient if some of the nodes might be temporarily down. And you don't have to specify more than a couple, or maybe 3 is best, because what happens is that from these nodes, the driver will ask, hey, nodes, tell me about your friends. The node is aware of the cluster, the whole cluster, because there is a mechanism called gossip, according to which all nodes speak very frequently with some other nodes, and they collect information, and they are usually very up to date with the status of the cluster. And this purple node will reply back to the driver, which then, from this point on, will keep memory of the cluster topology, and it will be able to query all nodes. And as we said, usually it is able to reach directly the node with the partition I'm interested in, which is good. Okay. So that's more or less the story. And in practical terms, to connect from your Node application, you create a client. So a client is an object in the package Cassandra driver. You create a client, giving it some configuration, and then you call its connect method. Then you do your things, whatever you want to do. And then for good practice, since the client is a resourceful object, is a stateful object, it will keep stuff in memory, it will keep connections open, TCP connections open. You should shut it down when you're done. Now, the syntax is very simple. We will come then later on more details on that. What you write in the config, at least you should give the address of some of the contact points, as you see here, and you will specify a data center probably, and you better define a default key space to be able to directly go to some tables to work with them. That's more or less, sorry.
Oh, yeah. Sorry. I want to highlight one thing. You said that already, but again, I see a lot of people making a mistake, so I want to highlight before you are doing that. People working with traditional databases, they use it to what you have in the configuration of a driver will be used as the main permanent all the time contact point for your application to work with data center. Cassandra is not MySQL without joins. Cassandra works differently. Contact points, I use it only to load information about the cluster. And after that, it will work. After that, your driver will work with the closest replica node it has to work with.
So yeah, the point, the right point, good point, Alex. The whole cluster will be auto-discovered, but starting from any contact point. So no problem with that. You will still have scale. And by the way, we will come to that later. The driver is also can be configured to apply load balancing of its request. So it can distribute the request across all nodes if you want. And you usually want to do that, by the way. Okay, so you create a client like this, and that's it. Now, just to out of completeness, if you have an AstroDB instance, instead of giving directly IP addresses, because that's in the cloud, that's there, and you give a slightly different way of connection. That's all explained in the documentation and in the README of the repo I prepared. But usually you give it the location of the zip file with certificates, and you give username and password to the configuration object. The rest is the same. In this code snippet, I don't directly write any string with secrets in my code, as is good practice. So I put them in a secret environment file and environment variables, and then I read them from my node process, as is, let's say, the standard practice, but that's a detail. And by the way, this is the way I'm going to connect in the demo, but just because I'm using an AstroDB for easy illustration. Okay. So I think we are ready to run some code. Just have a quick look at this. I instantiate my client with my configuration. So, okay, in this presentation, I will show the connection with contact points, but secretly in the code I run, I will be contacting Astra. So this config part is different, but nothing else changes. So don't worry too much about that. This is a very simple example. I have a function main that connects the client and then runs a query. You see, I define a query as a string. I call client.execute query, and then I act on the results. One very important thing is that the node driver works asynchronously by design. So almost every call you do is something that you can await if you want to be synchronous, but in general, you should attach to a promise or a callback if you prefer. So it's all very much asynchronous. And as you see, client execute gives me a promise, so I can tie it to a then clause, and then the callback within the then will take the results, read its rows, and then loop over the rows to print them. So what I'm doing here, I am selecting symbol and name from the chemical elements table, and I just print them one by one. So let me jump here, and I can, so in this shell, I already injected my environment variables. I already installed my node dependencies. Sorry, this goes a bit, let's try like these maybe, just so you see, better. So let me run this code 02 connect connection Astra. This is basically the same code that you saw in the slides, and I'm running it. Bam, you see, I'm reading the table. So I'm looping over the results, and I get element by element all my results. And at the end, client closed. That's it. By the way, client close also is, you see here in this line, client shutdown is also promised. So I attach it to a then, and then as a callback, I announce the client has been closed. So this is the typical promise chain, but you can actually interchangeably work with callbacks or await. Okay, so let's go a bit more in detail on the connection options. As I mentioned already, you can provide several different options to when you set up your client connection. You can specify load balancing policies. In this example, I want to stay on a single data center, and I want this load balancing to be aware of the token ranges. So I want this driver to be able to pick the right node directly when possible, when a partition is specified. Then I can specify a special parameters of the reconnection policy. So what to do when the connection is dropped, how long to wait to retry, and stuff like that. And when a single statement fails, I decide whether to retry it or not. And that might seem like an easy point, but there are some subtleties with the retry policy, because you see, not all statements in CQL are idempotent. There are statements that increment a counter. There are statements that generate a new row with an ID left to CQL to the side. So I have to be careful with idempotency. Otherwise, I might end up with duplicate rows or other problems. So this retry policy has to be, I mean, it's a bit subtle to handle. Alex, can I go forward or?
Yes, we are good. We are good.
Okay, great. So there will soon be a bunch of pieces of code that I will run, because I'm now about to show you how to query data. Or better, how to run queries, because the very first query is not for data, but we create a table in the code. Before starting, let me do something useful. Let me open an interactive REPL of Node. So I'm just not running a script now, even though you will find all pieces of code as single scripts. But now I want to work in a console just for more interactivity. So let me just paste the client connection part for later, and then I will go back to the slides. Okay, to the slides. So the basic way you execute statements, you just write them in CQL. You see create a table, nothing new now, nothing that you haven't seen already today. And I just client.execute this string. Indeed, I want to create a new table called metals with properties of a metal, kind, name, and density of a metal, say copper, zinc, gold, whatever. Okay, so let's run this simple example. I just take the whole create table statement, that's a long string, and I just feed it to client execute method. You see, in this case, I am awaiting on this command. Why not? So that will take a few seconds, because creating a table requires nodes to speak to each other, because it's a schema change. It's a heavy operation, so to speak. It's not like inserting data, and looks like it's finished. So my command should have worked. And you know what? I'm going to my SQL console just to check. So desk tables. Look, luckily, metals is there. And I trust this table to have the shape that I just showed. So kind, name, density, very good. By the way, this kind will be used later. You will see why. Anytime is as good as any other to remind you that here I'm awaiting this command, but usually I can work with promise logic or with callback logic, which are more or less the same. You will see how to switch between the two. And just for you to know, the drivers support concurrent execution. So I might want to run several commands at once, and that the driver does it for me. I don't need to write any custom code for that, any concurrent code myself. And they can also support speculative query execution. So if a command is supposed to be highly possible that it fails or something, I can try to run it also on other nodes and just hope for the fastest to come back. Again, idempotency is to be taken into account. Okay, so let's go forward. How do you write data? Well, the basic way is you just wrap the same insert statement that you saw already today in a string, and you client.execute it. Let's see that in action. Writing just by putting a whole string of a query. Trust me, I just ran it. I inserted copper as a regular metal with a density of 0.001. These should be, I think they are grams per kilograms per liter or something like that, kilograms per square meter. I don't remember, but I guarantee you that this is a wrong value. So copper is very much heavier. And yeah, I just made a mistake apparently. So if I select, no, I'm again this problem with, yeah, I think, okay, here we are. So if I select splat from metals, guess what? Here is my copper. So here I'm looking directly at the database. Here I'm writing commands in my node code, and here are the slides. But you know what? This is not the best way to run commands with the Cassandra drivers. Why? Well, there are three problems. One is that this is not optimal for serializing data. So you see, I'm using 4 bytes for a number, which is, I mean, I'm writing a number as a string. That's terrible serialization technique. I have to escape quotes. Let's say I want to insert a string with a quote. I don't want to enter escaping hell. And last and most important, suppose my insert statements are behind a web application. I'm opening the way to injections by malicious users. So that's really not the best way to go. I can do better. And I can do better means that I can write a command separated by the values. So look at what I'm doing here. I'm using client execute again, but I write the statement here, insert into blah, 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 but values is 3 question mark, 3 placeholders. And the second argument to execute is a matching array of values. So string, number. That's great. And it will work as long as I provide a third argument with type hints. So now I have to tell the execution, wait, the first argument is a text, the second argument is a text, and the third is a float. Let me show you that in action. So this is the same statement ready to be executed, and it worked. Don't mind the results, which is a control return value to check what happened. My point is that my Palladium has been inserted. And just to reiterate, let's try to make without the hints. It might work, it might not, but in this case, it will not work. And the error would be basically a serialization error. So it's not good enough. So writing this number is not good enough to make it serialized in the right way for this column to be written. The main reason is that JavaScript data types are not aligned with the very much more refined Cassandra data types. So I have to provide some more information for the data to be properly passed to the drivers, to the database server. But I can imagine that to be a bit heavy to do all the time. So there is even a better way to insert data, which is the way usually the recommended way, which is using prepared statements. What does it mean? Prepared statements are a very clever way to work because Basically, the drivers go to the server, go to the nodes on the cluster and tell them, wait, I'm going to use this insertion statement many times. So you are aware of the data types in your table, right? So get the statement here ready for me. The first time you prepare knowledge of your data types, and then this time and also the next times, when I send your data, just the numbers and the strings and whatever I have to send, you will know how to make them into the columns. You see this example here? I'm executing insertion, values, and then there is just prepare through as an option. The first time the nodes will be preparing the statements and be inserting my zinc metal. And the second time the statement will be ready for me to use. No need to provide hints anymore, and no need, and it's also optimizing the time needed to execute these queries. So if I'm using the same statement many times with the same shape and different values, I absolutely want to prepare the statements because the mapping to Cassandra types is automatic. By the way, in these two examples, I also show that you can provide the list of values as an array like here, or as an object with names matching the column names. So let me show you these two insertions. Prepare statement, I have my string with the same insertion and the placeholder here, you see. Then I insert zinc, then I insert mercury. So it's two metals, and let me run this. And very quickly, select them. Oh, here we go. Mercury and zinc have arrived to the database, all as expected. Okay, so now, so far I've been awaiting my statements because I wanted to show just part of the game. Now let's go to the promise part. There's nothing different than usual node promise-based execution. So I'm now inserting a metal that is actually a metal band. So it's not a regular, so type, no, kind will not be regular, but it will be band. And this band is a metal band, AC/DC, with a heavy density. You see the execute method is the same as the one I was, Alex is laughing.
I love it. It's one of my favorite bands.
Yeah, great. So I will be doing a few metals, a couple of metals. So you will see that. Okay, so execute method is just as before, statement values prepared through as an option, but now I will just attach a then and a catch. So if it succeeded, I will print insertion successful, otherwise I will just print an error. So this is the promise-based way, nothing new, nothing different than the usual node way of handling promises. This is just to show you that it will work. Okay, so you see, this is my output. AC/DC inserted, very good. Now, just to have a little fun, let me break something. So now the statement will not match the data. I expect an error. And indeed, bam, a terrible error that at the end is this one. But you see, now I am in my error branch of the promise. So everything as expected after all. Let me fix this. Okay, so you will see. Here we go. Okay. How to switch to a callback based, because sometimes you don't want to be caught in infinite promise nesting. So you want to work with callbacks. Why not? And you will use, that's a nice surprise, you will use the very same execute method as before, client.execute. You just provide a fourth argument. And this argument will be the callback, which will have two different arguments, error and result. And if error is not null, then errors have occurred. Otherwise, you just can go ahead. So now I'm inserting Iron Maiden, which is another metal band. And let me show that to you, how it works with callbacks. There we go. I run it. Iron Maiden inserted. Very good. So, okay, now I think you know how it goes. I just have a quick look at my database. Cool. Everything seems to work after all. Okay, so this is more or less all there is to say about writing in your Node application. Now let me show you quickly how to read, because reading is not so different after all. You run the same thing of query, execute something, and this time it's, instead of an insert is a select. And again, also in the where conditions, you can use placeholders and then provide values separately, prepare the statement, everything. But then this time in the promise part, you will read the results and do something with them. So results will have rows, and you can then loop over rows. And then you see, I'm now reading all metals with kind equal band. So let me run these. I want a listing of all the metal bands, and there we go. These two are there. Nothing new about how to work with callbacks. So again, I just provide a fourth argument to my execute instead of a then. And I do the same. This time I want the density of copper. So I trust there to be just a single interesting row. So I use result.first within the callback, and I print the result. Now, nothing new. I remind you that I don't want to spend time on much of the details of this code, but again, you find everything in the link. So, copper density is a bit low, but we will see if we fix that later. There are more interesting ways to read data because the client, besides the execute method, which we used extensively so far, has specialized methods to handle looping over results, such as this each row. So client.eachRow has arguments, the query, the parameters, prepare true, and then you should give it another two arguments, a callback to be executed row by row. Here, you see every row will be subject to this function that I put here. And then also a callback both for errors and for the end of the results. So in this error callback, if error is null, I will just have hit the end of the results. And if error is not null, there will be an error. So let me show, this is just to read all regular metals, so zinc, copper, and so forth. And this is for the each row method. You see, I get my results, and at the end, I will get my finished reading, which comes from having, here, no error with this callback. Now, very briefly, we mentioned batches before, and this is how you do batches. Actually, there's nothing much to say. You group your queries in an array, and you give it to the method client batch. We are a bit short of time, so let me skip this. Let me run this, because that is finally the one that fixes the metal density of copper besides inserting silver. So let's get this right. The whole batch succeeded. That's it. So you can have promises, callbacks, the usual here. And finally, my copper has the right copper density. Yeah, chemistry is saved. Okay, so very quickly, you probably have mixed the workload in your application, no problem. You might want some queries to work with a given timeout, some other to work on a given data center, some other to have different consistency level, no problem. You can define different execution profiles when you create the client. As you see here, I define various profiles. I put them here when I create the client. Then I can run different queries just by specifying execution profile in the option, and they will just be run with different settings, consistency levels, and so on. So a real program probably needs different kinds of workloads, no problem. Just very quickly, also when I run queries, so this each row, for example, I might want to specify consistency levels and other parameters directly when I run a query, no problem, because this third parameters of execute or each row allows very many different options. You can find them all in the documentation. So yeah, there is quite some flexibility. Now, I want to show very briefly a mini API, a full-fledged API, because we have a table with metals. Somebody hijacked it and put some metal bands, but I wanted a table for real metals like copper, zinc. And this is the whole working code of a mini API that makes it able to get all metals, get a metal by name, and insert a new metal in my table. So this is a standard, very small toy express API, which I can then reach with a REST-like HTTP request. I can get, I can post, and stuff like that. So let me quickly run this. So node code 04 API, API.js. Now, this is running here on port 5000. And well, very quickly, be outside of any endpoints. I'm instantiating my client ready to use. And then in every one of these express routes is basically a wrapper around a given execute method with the particular query. Nothing fancy here, right? So for example, when it's about getting a metal by name, I use express request parameter in the array of values for the query. When I have to post to create a new metal, I read the body and I add regular because I know it's real metals here, and I run my insert query. So nothing really complicated going on, but with a few lines, I already get a working example. So let me open a new window to run, for example, my here I just asked, you see this curl does a get, and I get back my result from the database. Or I can get only silver only, and that's it here. I can do a post to insert a new metal that is called harmonium, which by the way does not exist, and I get back an OK and an acknowledgement. So now if I query again for my metals, I get my harmonium back. Now, I'm going pretty fast because there's nothing really fancy with the code. I just want to quickly show you that everything would work. Obviously, you are invited and you should go much more in detail by looking at the code, especially if you are a JavaScript developer. But yeah, there is much to show yet, and we are almost at the end of time. But I think, Alex, would that be a problem if we go 5 minutes further?
No, I don't think there is any problems.
Okay, so how is the audience going? Am I going too fast, maybe?
No, all good. At least there are no requests to go slower.
Oh, okay, good. So now there is an important topic to touch, pagination, because you've seen queries that get some result and they do something with the results, maybe one, maybe more, several rows at once, and that's okay. But there are some use cases where you have to get batches of results from a long list of results. So for example, I have a lot of metals and I want to work 10 at a time. So I would like my query to be able to keep tabs on, progressively getting page after page of the whole results. And that's what pagination is for. Now, by the way, by default, the fetch size, that is the number of rows to get back, is 5,000, which is a lot. But if my rows are very fat, very big, I would probably have to make them smaller because there is a performance problem otherwise. So request response is too big. Now, there are various ways to handle pagination. If you don't do anything, you just get the first page of results and that's it, which usually is enough because 5,000, but maybe there are cases where I have to do something different. So look at what I'm doing here. Here I define a query. I want all of the regular metals just for fun. I want to go 2 items at a time. So every page would be just 2 rows here. Indeed, in the options of my query that I will pass to the execute, I have prepared true, but I also have fetch size 2, you see here. So I will be sure to get 2 rows at a time. Now, there are various ways to handle pagination. One is this for await asynchronous iterator construct. So I call my usual client execute, and then I loop over these results with an asynchronous iterator. In this way, pagination is handled automatically by the driver. So let's see what happens. I now run my for await and look at what happens. I don't even notice there is pagination, but I know that behind the scenes that's taking place. But I get my all metals, including this made up palladium. Okay, harmonium. Palladium exists. Oops, the chemist in me. Okay. There is another way to do automatic pagination, that is with passing autopage through to the each row method that you saw already. Nothing fancy, so I just run the code. It's just different the way so it's the same difference you saw already for the each row result, method invocation, and there you go. So you see there is this index 010101. Small remark, this index and here in the callback will be an index within each page, as you saw, 010101. Nothing else. Now, there are other cases in which you want to have direct manual control over page progression. For example, you might have a web application where the user has to click next after viewing a screen full of results. So you need an explicit way to keep tabs on the page. And these, again, you can do in various ways. One way is you have an execute method as usual, and the result of the execute method might have a page state property, and then you use this page state and you pass it as an argument to the next call to execute, and the driver and the server will be able to know, okay, I will start from here in giving you the results. So this is how, so this page state you can pass around in your application and do whatever you want, and you will be able to have direct control over your pages. And let me show you how this works. I run it, and you see I have an explicit, first page followed by 2 items, because I still have a 2 items page, another page, 2 items, another page, 2 items, another page, and then stop, because the last time page state was null, signaling me that it was the end of the whole thing. I also can do a slightly different variation by calling explicitly the next page method within each row callback, basically. Let me skip this so we can get to more interesting stuff, because the interesting stuff is sometimes I want to consume items without, if I'm processing items as they come page after page, but my processing takes time, takes resources, it might be good not to, fill up the local buffer. And for this, the stream method of the client comes handy, because it allows for, say, handling back pressure or forward pressure in this case. So I create this stream object, and then I can attach readable event and end event to it. So as soon as items come available, I consume them, and then I just stay waiting, and then new items will come up, and then at the end, I will have a callback attached to the end event. Now, this is interesting because it creates the very stream object, and as you can see here, there we go. So I have readable rows, I consume them, new rows arrive, and so on. This is all based on stream and events, and it's completely asynchronous, as you can imagine. Okay, so now so far I've been showing you how to basically plug SQL statements in your Node code in the right way. I want to remark that Node also offers, and many other drivers also offer, an object-based approach. So you can have objects built directly for you automatically by knowledge of the schema. So you can attach this mapper to a table or more tables, and then you will have a way to interact with rows in the database as if they were objects. So you can create an element like you see here with fields, and then you just call insert. You can get by a property, you can remove items, and so on. I'll skip that. The only remark is that this mapper is very smart, because you remember we said a lot about denormalization, and maybe some insertion might have to go to several tables at once. Well, the good news is that this mapper is able to do that for you. It just compares the names of the fields of the columns in several tables, and when you insert this one new element here, for example, it will know if there are more tables defined here in the mapping. It will know which fields to insert where, and it will maintain for you the multiple insertion that you remember we said it's your application's responsibility. So that's not bad. But I will skip the demo because that's just that code. You can run that by yourself as an exercise. Okay. I admit it was pretty much a long series of pieces of code that I showed you. You are invited to tweak them, to play with them, to run the API, to modify it. Please go to the repo and play with it, because it's much more instructive. And look at the documentation. Now, I'll just close with a few words with the other option to interact with Cassandra, or AstraDB for that matter, which is Stargate IO. So Stargate is a different way to interact with your database other than the drivers. And as we said, it simplifies interaction with the database, to a matter of HTTP requests according to various APIs. So the most notable maybe at the moment are document API, which is a bit like the usual schemaless document databases. So this is just a screenshot, but you see I create what is called a collection that is basically a particular kind of table in Cassandra. I then create documents. I can update a subdocuments. I can search by various. So you notice this last line has a Mongo-like syntax, so it makes it very easy to work with schemaless documents. Okay, so you see on the first line there is a SDK for Node and as well for other languages to interact with this. But actually, what's happening behind the scenes, if you prefer, is it's simple HTTP request. So this is how you update a subdocument, for example. So nothing fancy going on there. Stargate makes it also possible to work with data in a GraphQL syntax. So you see this is a typical GraphQL query. So yeah, there is quite some freedom. And speaking of those Stargate-enabled ways to speak with your database, we DataStax developers run a lot of workshops, and they are basically all based on Stargate because that's very interesting and multifaceted way of working with your database. So if you're more interested, you're invited to join us and to and to watch some of our workshops because they are much more in detail on this part.
If you have a dedicated workshop on GraphQL, and how do you use it?
By the way, yes. And it's very, very nice because GraphQL is a cool topic nowadays, and we are explaining it very well, I would say. Yeah. Okay, so well, that was a lot of stuff. I know I appreciate that, but okay. So I remind you that everything you saw today in this talk and more, you can find here. By the way, you should already have your AstraDB, so it should be very easy to set it up and play with the code. This is where you find everything about Astra, and as for Stargate, this is it. Now, maybe Alex, you can paste a few of these links. You know where to find them.
Yep.
Yeah, as we mentioned, right now we run workshops, and most of them are Stargate based. So please, if you want to go here and also on our YouTube channel, which is the channel you are probably on right now, you will be able to find much more detail and much more examples and play with the code. All of our workshops are basically interactive. They have a lot of hands-on, not only that, but they are backed by GitHub repositories, which also contain a README that makes it possible for you to just go by yourself and just do the exercise. And by the way, if you do the exercise, you want maybe to submit the homework, and you will get another badge, other badges. So you can really collect the badges like this and be a super Cassandra hero if you want. Okay, so yeah, there are then some resources for developers that we gave you already, Academy to study for the certification, community where we can exchange question and answer like a Stack Overflow. Please connect with us on various channels. You saw them already. They are in the comments below this video. And please reach us on Discord where the discussion can go on. Now, you know everything there is to know almost on the drivers and on application development. So the way ahead is long and interesting. Please go ahead and create your wonderful applications and maybe let us know. Why not? With that, I stop here and I thank you very much for listening. And sorry for taking a few minutes more than expected.
No, it's completely fine. Register. Good, I was answering questions.
Okay.
It looks like we are proceeding to the final word.
Yeah, I can imagine it's been a long day for those who attend, as it has been for us. But yeah, very rewarding, I have to say. Very interesting.
Definitely.
So
It was a great day.
I think Diki will join us again to say goodbye.
Yep, I hope so. Because I don't see him yet.
Okay.
You have the slides for the final word, right? Oh,
Yeah.
here we go.
You probably do as well, but we can stay on this if you want. I can share my screen.
We can
Yeah,
stay
let
on
me go to
yours.
conclusion here.
Just a second. And okay.
Yeah, so closing word.
Okay. There are 3 of us now, all on the screen.
Okay, great. Thanks for telling, because today I have one monitor only, so
Boom. Now.
great.
Good. So that was incredible.
Hello.
Hi.
Hello.
So hi Dicky, welcome back.
Yeah, thank you very much for such a wonderful day.
Yeah, it's been great. I have to say, it's been great.
So
Very
I
much.
believe today many developers of Indonesia have known one beautiful name called Cassandra.
Yeah, I guess
Yeah,
so. Yeah.
Yeah, mengingatkan bagi para peserta, di link chat ada kuis terakhir. Silahkan gunakan kesempatan untuk mendapatkan hadiah lagi OVO untuk 3 pemenang. Monggo diisi dengan cepat. Siapa yang cepat dia dapat. Okay. Yeah. So thank you once again, Alex and Stefano, for being here to guide us from what a rough day. You maybe you didn't have enough sleep last night.
Well, let's say
starting at
a bit less than usual, but it was worth it.
5 a.m. in the morning until now in the afternoon.
It's now 12:30, so lunchtime for us.
Yep.
Yeah.
But I believe it's gonna be the first start, and it's gonna be a big start for Cassandra here in Indonesia.
I hope so. Yeah.
Actually, you made history. This is one of the first event in Cassandra in Indonesia.
That's great to know. Yeah.
Okay.
So we are making history. So all of you who attended, you are part of history, and I hope it's been very fun, maybe interesting, and for sure it has been great for us to interact with you and to give you hopefully useful information, useful knowledge, and thank you for the attention and all of your very good questions. And now Cassandra is your friend, and please reach us, or even better, maybe reach the friends at the SPS, so Diki and everybody, because, by the way, we thank you all for the help in the chat and for the logistic setup and assistance in setting this up, for the translation to Bahasa, and not only that, for the quizzes and everything. So,
sorry, Diki, how do you pronounce thank you in Bahasa?
Let me try. That should be...
In the guide?
Terima
kasih.
Terima kasih.
Okay.
Terima kasih. Terima kasih banyak.
Thank you very much.
Thank you.
Terima kasih banyak.
Okay. So we have a feedback form. You are invited to fill it to tell us maybe what you would like to see on the next Cassandra Day. And by the way, this is the same form that you will want to fill to get your free stuff. So everybody who attended today will be entitled to get a free voucher to try and take the exam to get certified and boost your resume and your career. And alternatively, you may want to get some free credit to use Astra, a bit more credit than the one that is already free monthly for everybody who registers. So you can have heavier workloads, heavier storage, and whatever. We invite you to keep in contact, maybe not only here, but in particular on Discord, where most of the community is built. And by the way, maybe this will involve our friends at SPS, Diki, and so on. Maybe this is the start of a solid Indonesian Cassandra community. That would be great. And so all of these links, I hope they have been pasted already in the chat. So let me switch to this very important point.
Just one second. Thank you. Sorry.
Yes, sorry.
So take a look. This year we did Cassandra Day Indonesia with a single track with workshops. But I dream next year to do it
very good point.
2 tracks with talks. not only for the beginners, for complete Cassandra beginners, but also with talks for also more advanced audience like you, or moreover, maybe done by you. You can be a Cassandra speaker at next Cassandra Day event. If you learn, if you apply your knowledge, you definitely can be a speaker at next Cassandra Day, and we will be happy to host it in 2 tracks with workshops as today, but also with talks done preferably not in English but in Bahasan. That would be great.
That would be great. Yeah, usually we love to hear about usages of Cassandra out there, because there are many and they are always highlighting some very interesting aspects of it. So absolutely.
2 words from me. 2 words from me. Why not? Yeah. Why not?
Yeah,
Okay.
sure.
Okay. So yes, thank you once again for a wonderful evening. So
Next slide.
we can.
Next slide is very important because we had already 1 quiz during lunch break, 1 quiz interactively right after that, and with prizes, both of them. And we also give you vouchers or free credit for AstraDB, but that's not the end, because surprise, there is going to be another quiz now. So after this event is over, you just go to this link and you will be able to compete for another prize in the form of OVO vouchers. So look at this URL here, scan this QR code, and you will be able to compete again and win something more. Where shall these prizes going to be? Where are these going to be announced?
Okay.
By the way.
So by filling this form, this quiz, and winning this quiz, then we are from SPS will contact you.
Okay.
It's easy because it's like a e-payment. OVO is like e-payment. Simply what we need is simply a phone number, and we can top up their money actually.
Okay, great. So but still we hope to see you on Discord or so DataStax would like to keep in contact with anyone who uses Cassandra. So please join us and you will find out more, and we can discuss and we can answer your questions and whoever knows what. But also please go ahead and keep in contact with SPS, I guess, because Cassandra is their thing. So I think we reached the end of it. So the link is still here, don't worry. The same link is here.
We already got the winner actually.
Really?
So fast.
Great.
Congratulations for Pak Budi Hermawan, Denny Rizky Aryasta, and Muhammad Ali Romdoni. Wow,
hey, great job.
Familiar names.
Great. So real time. Great. All OLTP.
Yeah, indeed. Speed is the password.
Okay. I think for today that's it.
Yep.
Okay, thank you.
It's been really worthwhile to get up in the middle of the night for today. So it's very cool to see so much interest in Cassandra. So I hope this is the start of a very cool and strong community in Indonesia.
Right.
So terima kasih.
Terima kasih.
See you in the next event.
See you in the next event. Thank you for your
Bye,
likes.
everyone.
Thank you for your subscriptions. See you again, and a little bit music in the end. Enjoy.
Shipwrecks, so glad it's over with my ex. But we stay afloat cause you're my index. Seeing clearly now, don't need Windex. Zooming in what's important, I don't need the context. I know less is more when you keep my data in check.